Welcome to our second edition of Zak World of Façades in the great architectural wonderland that is Chicago. This is our 193rd edition of our global conference series, which started about 12 years ago. I'm Susan Kramer, the Americas Director, and I'm very happy to lead off today's event. As you can see, we will cover the globe in 2026 from A to V. Thank you all for taking the time to be with us today, and to all the speakers who have created presentations especially for this event. We think you'll find the talks to be relevant, informative, and most of all, inspiring. Each of our conferences is planned specifically for their city and region, and we strive to offer as much original content as possible. I also want to thank our partners whose support of the Zak conferences make this all possible. I encourage you to take the opportunity during the breaks to speak with them one-on-one to see what the solutions they can provide to your design and technical challenges are. So let's give special thanks to Eneko, Arctura, Atlas Energy Shield, Boston Valley Terracotta, Cosentino, Dow, LMX, ES Windows, Exo, Fassada Steel, Guardian Glass, Hendrick Architectural, Jangho, Janssen, Kale Group, Kingspan, Knight Wall Systems, Curaray, MSI Synthetics, Owens Corning, Reynars Aluminum, Rotoblas, Siderise, Stowe, Turkish Glass, Viracon, Vitro, and Walker. Yay. Our next cities will be in Atlanta next Thursday for our very first time. And be sure to share this with any colleagues that you have down there. It should be a great event. And our largest North American event will take place on October 15th. And you should all come down for that one. Seats are very limited, so I would sign up ASAP. And we finished the year that started in Mexico and Brazil with our very close neighbors up north in Toronto. We are planning to make this an annual event, so come up and see us there also. And we will be in 7 US cities and 3 in Canada next year. We're excited to add some new ones like Houston, Phoenix, and Calgary. And just a couple of housekeeping notes for you. AIA members, you'll need to sign up at the end of the day on the sheets on your way out. Members can receive 8 AIA HSW credits, or you can request a certificate of completion. Please be sure to sign those sheets. And the venue asks you not to bring lunch inside. Drinks and coffee are fine. And we will also ask that all of the session speakers return to the stage at the conclusion of their session for a photo op. And now I am proud to say that we have a star with us today to host our event, Lynda Dossey, who I'm sure a lot of you know. Lynda has been so generous sharing her knowledge of the Chicago AEC community with me, coming off her role last year as president of AIA Chicago, which of course is the second largest and one of my favorite local chapters. She is a leading principal of Jahn, part of the team that is bringing their original James R. Thompson Center's design into the 21st century while maintaining its iconic form. You can Google it.
When I was looking for someone both energetic and knowledgeable to host today's event, she was the first person who I thought of, truly. Please give a warm welcome to Lynda. Good morning, everyone. Thank you, Susan, for those kind words. I'm now going to use this time briefly as a shameless plug for Jahn. I am a director at Jahn, and I just wanted to show quickly some of our most recently completed projects, 2 here in the US, 2 in Germany. 1000 South Michigan was completed last year, and if you have a time to take a break to go outside at lunch and look down the Mag Mile to the south, you should be able to see it on the skyline in the distance. We also recently completed up in Wisconsin the Pritchard Military Library and Museum, and it's about an hour drive from Chicago, but it's worth the trip. It also has lovely grounds designed by Tom Oslin. We've also recently completed 2 projects in Germany near Berlin or in Berlin. The campus Olauer Strasse, which is the Oren project, that's an affordable housing project and campus that we designed and completed a few years ago. And then Eden is opened up and leasing now in Berlin, and it includes a growing facade. So that's some of our more recently completed work. And then some stuff we've got on the boards. As Susan mentioned, we are working to repurpose and reimagine the Thompson Center with Google as their Chicago headquarters. Happy to report I've got some colleagues in the crowd here today that I've seen. It's nice that we get a break today. We're also working on, in upper state New York, an artist studio as part of an artist campus, and we're also doing a new headquarters for a manufacturing facility for car parts down in Greenville, South Carolina. And not unlike the Thompson Center, we are asked to kind of repurpose and reimagine our Sony Center in Berlin. So a few of the buildings are going offline and coming back online, reimagined, repurposed, restructured, reglazed. So that's some exciting work that we've got going right now. Feel free to ask me about any of those projects except the Thompson Center. I will be hosting you all day today and introducing the speakers for you. Someone thought it was a good idea to give me a microphone of my own. Right now, I am proud to bring up our first speaker. His name is David Dadoyan. He is a director at KPF, and he will be speaking to you about 1325 West Fulton Market and the vibrancy of that neighborhood.
Going to talk about 1325 West Fulton, which is a project by Sulo Development. We're collaborating with Park Fowler in Chicago, as well as TT in Chicago, and Lara and Salas O'Brien. We have a great team. We're out of New York, of course. So probably makes sense to talk a little bit about our mission, because it kind of ties us in many ways to this project. So our mission is to elevate cities through context, craft, and performance. And by context, of course, it's the social, historical, economical, and also the sort of architectural, urban context. And for this project, it's particularly relevant in terms of how we develop the ideas for 1325 West Fulton. Craft, obviously harnessing materials, detailing, and really telling our spatial narrative through the details. And finally, performance on many levels: social performance, economic, and also kind of the technical performance. Context. The site is located in a place where you have like various ways of accessing the site. It's in Fulton Market. It's close to the L line. It's close to bus lines. It's close to bike stations as well. So obviously it's a site that's pretty kind of walkable on many levels and very accessible, especially with the new station that was recently added. So a very vibrant part of the city. And the history of the site you probably know much better than I do, but how it went from a site of production and being a sort of a major sort of hub for meatpacking industry in the region, and a lot of the architecture there is still kind of evidencing that history, and kind of obviously going or trending from a site of production to a site of a lot of consumption with high-end restaurants, amenities, an art scene, and but we still see a lot of the architecture kind of carrying through and being transformed for all these uses. So Fulton Market today, this is an interesting kind of analysis comparing the sort of like the loop to the market in terms of access to different types of amenities within a square kilometer. So the comparison kind of shows how much the Fulton Market area has so much potential to be vibrant and active as a central district, which is also a social district, because of all the access to the arts, dining, all the amenities, whereas in the Loop you sort of have a more restricted sort of range of access to the same amenities that would make a district sort of active. And that's evidenced through the market and how there's like throughout the day there could be activity during the night, during the day. Then thinking about the identity of the development, which is a residential development, obviously we've done a few glass towers, more than a few, and we thought, how do we sort of like, what do we tap into here in terms of the vocabulary of the area, the neighborhood? So we thought there's a lot here to learn from and to explore. So we looked at there's more recent developments, obviously, and there's also a lot of sort of brick masonry architecture, which also carries over a lot of the industrial sort of language as well. But we also thought, this being a luxury residential product, that there's also other ideas that could be injected into it, which is the integration of wellness, nature. This is our University Place project in New York, which also uses masonry. But also kind of thinking about the industrial aesthetic and turning it into what one might call an industrial chic look of you see it in fashion, you see it in architecture too, where like you take the same details but also elevate those details and transform them. And so here were some of our initial sketches where we started thinking about, well, it's how do we sort of take some of that language and develop it, but also use more contemporary techniques and contemporary methods of construction to create these facades. And that's where the precast system came into play with this project, at least for a portion of it. That's what we're beginning to explore. The project is sort of at the end of schematic stage, so there's a lot to develop and work through, but there's some good foundations for it. So coming to the project, the site's located, interestingly, as a kind of anchor on the west side for Fulton Market, and then over to the east you have the Loop. And in that sense, it's an interesting location for the site, and it's really creating a luxury residential development that brings more users here who can work, can live, and can play in the kind of this neighborhood. So it's really tapping into the energy of the neighborhood and its proximity to the city, but also with a lot of the tech companies that are also in the neighborhood. It's kind of got all the combinations to be a vibrant social district. Coming to the block, we were pretty sensitive. I'm going to see if I can point. There's a fancy way to point. Oh, that's a fancy point. But so we're sensitive to the scale of the urban pockets in the neighborhood, where you you really don't want to have a mega block as much as like trying to create more of an intimate scale to these to the block. And that's what really guided the way we introduced the massing of the three phases of the project, and sort of creating these sort of pockets that are kind of well lit and accessible and friendly. So it kind of breaks up the scale of the block as you walk along it. And looking at the landscaping of those spaces and integrating it into the space of the street and how you access the lobbies, and also using the amenities to activate the street frontage. There's a massing of all the phases together and showing how they kind of tie to the urban texture of the neighborhood. But the scale thing is not just a plan scale, but also in section we were very sensitive to introducing scale on the level of the street wall. And that's why we introduced these loggias, which tie to the amenity level and on the podium deck, but also they kind of break up the facade and create these urban rooms that speak to the street and also break up the scale of the project as the towers come down. So you can see over on the left, you have this loggia typology, which picks up on the glazed typology, but it actually creates these voids that communicate with the street. So coming to the language of the project, I mean, in a way, we think of it as a combination of two, where we have the materiality and the language of historic Fulton Market, but then there's the aspect of kind of how do we refine the details and how do we take it to the next level in terms of the expression of the wall and the expression of the interfacing and the detailing. So this is the project where you can see a double-story expression across the whole tower, and then you can see the loggias, which are kind of, let me see if I can, let me go back. So these are the loggias on the corner and also at the amenity level. And then on the street level, we maintain the double-story package of expression so that we actually break up the scale of the tower at the base and introduce these arched forms at the base, which at the moment may be handset or could be precast, but the main body of a tower is a precast system with a brick cladding. And of course, this is the podium deck where we introduce sort of a lush garden and the podium. You can see here the double-story sort of expression at a closer scale, where you have the frame, and then we have the inset arch, and then another kind of layer of glass which is set inside. So this whole idea of introducing depth is carried through the whole project. And this is the back of the project, which we're actually proud of because we love the back because it doesn't look like a back, or we're trying not to make it look like a back because it's kind of hiding the core, and you don't really have a sort of like a blind back to the project. So this is the street level where you have the most sort of articulated expression of the arch. So you have more depth happening at the base, so it articulates on the street level and also creates this packaging of 2 stories with the darker gray metal, which kind of laces through, which is another thing that we picked up from the language of the buildings, historical buildings around it. And you can see over on the left, we're looking to kind of introduce a finer grain of texture also within the brick. So the soldier coursing is something we're exploring now, both at the base, you can see it here. There's that expression of the soldier course, and also within the podium at a higher level. And then it kind of becomes more shallow at the top in the typical tower level. But, you know, we like this in terms of the sort of the higher level of articulation we're trying to create at the base. And then the loggia idea is kind of becomes this idea of these voids in the parks that kind of flow, and so the space from the lobby flows out into the garden, flows out into the street, and there are these spaces that are kind of pretty welcoming and they're well lit, so they're not sort of hidden kind of courtyards, rather they're really part of how the building interacts with space of the space of the street. This is an overall view. You can see the entrance over on the bottom right, the garden, and how those things kind of tie together. And we're going to do something similar for the other phases, where we really kind of give this character to the street level. Coming to the materials, obviously brick is something we're looking at, but also we're looking at the dark metal as a way to lace through everything, and also we're looking into developing a balustrade kind of pattern that kind of is more sympathetic than what you're seeing here to the overall language of the building. And then you've got the introduction of other elements like the red travertine, which I don't think I've seen in Fulton, but those are some of the touches we're trying to add at the base of the building, which is sort of sympathetic to the red tone of the flatting. And of course, some of the exposed concrete at the soffits. So how do we translate all these materials to more contemporary ways of construction? Of course, if we're not looking at the handset system for the whole tower, how do we kind of use some other material to create that kind of the effects of depth that we're looking at? And we looked at precast, obviously, where it's a kind of plastic material that can give us a shape to work with, and then the thin brick is what we're using in order to create those sort of offset forms in 3 dimensions. So it's at the nascent, it's kind of in its adolescence how we're researching this, but there's a lot of potential to use the precast in a double-story package for sort of efficiency. So I'll show another picture we're looking at for the precast system. Looking closely at the base, that's where you see the red travertine, the blade cut brick, and then we're kind of looking at ways of sort of using the soldier course also as a different kind of brick, which kind of gives the base a certain character and scale at a more intimate level. Some of the initial drawings we're not kind of very advanced yet, but we are looking at ways of either hand setting the base or using the precast system. We're going to have fun looking at how these forms are going to become trapezoidal, or what they're going to become, or how we're going to sort of negotiate the curve with a rectangular piece. All these things are kind of things we're working through now, but it just gives you a sense of the sort of like the texture we're looking to create with the light and the shadow and the depths. And here you can see the darker metal, which kind of is this recessive spandrel piece between the 2 levels. But, at the same time, you get this nice kind of street scale for the arches, which are double-story expressions. Here's another picture looking at the articulation of the corner and the angled bricks, and how we're going to negotiate the corners with the brick expression. A lot of this research is going to be developed further as we work through the detailing. And it's good to go back and think about what we were referencing when we're developing this facade. So obviously the layering is something we were really interested in to kind of give the street character. The dark metal, which is that industrial kind of, it's something from the industrial buildings too, which is used to frame, to be used as a liner. Again here, sort of picking up cues from buildings that are on the site. Then we come to the typical wall where we have that sort of the double-story frame expression. We're trying to be ambitious with our glass bay window system, but we'll see how we can kind of maintain some of that geometry. It's a little harder with window wall these days to do it, but we're working through that as well. And you can see some of the articulation of the spandrel here. We're looking at different ways of giving that some texture too. And this is some initial ideas we're looking at for the precast system, which is, how can we be more efficient with a double-story system so that we can reduce the erection time, and also thinking about where we would have those seams so that they would be sort of like most concealed, but really using the plastic nature of the precast as the sort of the bone for the structure, and then kind of working through it with the brick, which is going to be the sort of where the exercise kind of gets interesting for us. That's the typical wall where it's a little more shallow, but it still has character, and it still has the sort of a double frame. And that's sort of the back of the project, which again, we love the back of this project. We're working on it to kind of to develop the spandrel condition and sort of maintain that same sort of character on the back. And we get to the loggias, and I think like we were sensitive to how these balconies sort of create a certain scale on the street level, and also animate the street through these rooms, let's say outdoor rooms where people are outside, and it gives the street sort of life and character. So with our loggias, which are kind of interspersed at the corners and also in the middle of the base, sometimes you get that expression, that you see the double-story expression and the sort of like the intermediate balcony space. And they're sort of recessed enough to protect you somewhat more from the weather, but it gives you this kind of like an outdoor room that you can enjoy, but also you have some measure of privacy of being inside. From the interior, obviously that character of the arches also kind of translates to how the interior rooms are modulated. So a lot of the modulation of the different arches come from how we worked inside out with the planning and kind of aligning the great rooms with the modules of the arches. Yeah.
Thank you so much to Daniel. As someone who works in high-rise, it's always a challenge to figure out how to articulate a high-rise multifamily into feeling human. I think that's a very thorough deep dive through that and very respectful of the neighborhood. I look forward to it. Thank you. I'm now going to introduce our next speaker. He's going to be talking about the retrofit of a facade of a federal courthouse building, which is always its own unique challenge as well. There's two speakers. Bryan Howard, I'll introduce first. He's at Thornton Tomasetti, but he is also a licensed architect and a licensed engineer, so he's a dual threat. And he works at Thornton Tomasetti, and I'm so certain you were on the list for me. Dear Shatswell. Yes, also from Thornton Tomasetti, and they are going to tag team this. Very exciting. So please welcome them to the stage.
Okay. Well, hello. Good morning. It's a pleasure to be here. I am Stephen Shatswell with Krueck Sexton Partners, not Thornton Tomasetti, but I work with Thornton Tomasetti quite a bit. And Bryan?
I'm Bryan Howard with Thornton Tomasetti, licensed architect, associate in the Façades group.
Yeah, so today we wanted to talk to you about the Whitaker Courthouse facade replacement project. Let me get my clicker here. If you've ever been to Kansas City, the courthouse is a very large structure. It's about 500,000 square feet, 300 feet tall, right on the north end of the city. So if you're driving in from the airport, it sort of looms large on the skyline as you approach. And the goals of the project, the main goal of the project is to replace about 100,000 square feet of deteriorating glass. The project was completed in the late 90s and unfortunately had quite a few issues pop up over the last 25 years. And so this project addressed a number of those issues as well as some other things. So within that 100,000 square foot glass replacement, obviously, technology has come a decent way since then as far as glass makeup and our understanding of how facades, provide that protection both from the sun, from the elements, etc. So we partnered with Atelier 10, who many of you may know, did quite a few environmental studies. And so everything you're seeing or you'll see here today has kind of all of that as a backup, understanding the building and its environment and how best to capitalize on some of the properties, just the environmental properties. One of the things that Bryan is a bit more of an expert on, but I'll introduce here. So the courthouse was completed just shortly after the Oklahoma City bombing event. And so that means it was completed without the current or today's envelope hardening standards. And so part of what we looked at for the facade replacement is upgrading all of these facade systems to deal with the blast loading that we might anticipate. And But one rule of thumb that I found kind of interesting and just wrapping my head around this. So a typical building like this, the environmental loading you might consider for 90 mile an hour winds or something like that. Blast loading is about 10 times that amount, and it's both in and out. So as we're talking about all this, all the facade that's being replaced has to meet that criteria, about 10 times the amount of what you typically designed for. Brian's often joked that after the glass is all replaced, the safest place in the building, should a bomb go off, is actually behind the glass. It's not behind the precast, because that's not part of the project. But anyway, another really challenging factor and really a driving factor in how we approach the facade replacement is the fact that this is a large federal courthouse that's remaining in operation. So you can see kind of the layout here. The north, that big curved facade on the north is what faces the river. That's on the left of that section here. I guess I have this pointer there. So here along this north side is some of the more sensitive spaces. So the judges' chambers, the attorney offices and whatnot. And then the public space, you're coming in off the south end adjacent to a park. There's a large, about 60-foot atrium right at the entry with a skylight that looks up this courtyard space. And then the foyers into the courtrooms themselves sort of march up along that south facade and then back to another public lookout on the north there. So keeping all those parts and pieces, or rather replacing the facade and keeping all those people and their stuff in mind is a better way to put it. Moving federal judges and keeping them happy is, as you can imagine, quite a challenge. So keep that in mind as well. And so where to begin? This is sort of a diagram of all the different types of systems that we have within the project. A lot of different challenges, a lot of different complex conditions, and all of them are sort of needing to be tailor-made for replacement. And so if you're a fan of The Matrix, there's some sage advice that was given there that happens to apply when you're approaching a renovation project, which is know thyself. So from the start of the project, we started it in about 2021. So 4 years ago, a little more. This is in I won't say the dungeon, the building doesn't have a dungeon, but the bowels of the courthouse. There's a treasure trove of existing drawings that we did sift through. And then something that we also did, which I would highly recommend it. There's a handful of takeaways that I would say take with you when you're approaching a facade renovation project. Selective demolition. It seems kind of minimal and maybe, throw it off. But in fact, one of the best things that you can find when doing selective demo is exactly what you expect to find, right? Because then it means you're on the right track. But this was a very important part of where we began, was identifying different areas that we could open up and look into. And then this, I think, is probably the most important part as a takeaway for approaching a renovation project of this nature, which was we conducted a couple of envelope continuity workshops. So we took everything that we had learned. We had design assist on the facade. We had WJE, we had TT, we had the contractor on board at that point, and then the architects, obviously. We got everybody in the room, all that brain power, and the existing drawings, the selective demo, and we looked at the new systems and made sure that we were connecting all the dots and tried to really understand how we're approaching each detail kind of system by system. And so from here, I'm going to hand it off to Bryan. We're going to walk you through a couple of stories of those systems in the building.
Yeah. I think the first thing that we want to make sure that you all understand about this project is how big it is. If you get in the elevator, there's only 10 buttons. It's only 10 floors. But each floor is about 24 feet tall. So it's huge. Kind of go into that. You can see this is one of our punched windows getting placed in with a large piece of equipment. Everything is off-site. Everything's ready to be shipped on. We're about halfway through the project at this point. But like Steven said, one of the things that we needed to do was make sure that this building stays occupied and operational during this renovation. So the contractor had to build these giant weather walls only 5 feet away from where the work is going to actually be installed, because they had to minimally be invasive on where what they could demo inside the building itself. if you were to be in Kansas City at the time that this was up, you'd be really surprised at how green the building got all of a sudden. We're going to get into some of our systems now. So the first one is our punched windows, as you kind of saw earlier. The interesting thing about this, there are so many of them. We didn't want to build a weather wall for each one of them. So what the contractor did was they took out the sealant, kind of deconstructed around the window itself, pulled the window out just enough so that they could start doing all the steel work and detailing work around the window, left that in place as the temporary wall. And then when they were all done with that work of the steel and the detailing, they finally took the window out and replaced it all in one day. Perhaps the most challenging window or system in the whole project was these, what we call vertical ribbon windows. There are 18 of these around the whole project on the east and west facades. They are 1 foot wide by 90 feet tall, of aluminum and glass panels. And what I like to call them are our little archer windows, right? They look like little archer windows that you might see in an old medieval castle. The most challenging part about this was we were squeezed for space. There's nowhere to work in here. We couldn't touch anything to the left of this image, and we had very little space to work in regardless. What we learned more was during demolition, the hallway next to these windows, which you see, the windows are down here. The hallway just to the side of the windows is the MEP superhighway. So we couldn't touch that either. So that leaves us just a small triangle of space to do all the work. Within that triangle, we need to slam in this new steel that Stephen was talking about to harden the system. And around that steel, we had to work around precast concrete, steel, and building structure to get all of this work put in. Along that line of feeling the squeeze, we had to fit this system into a 6-inch space. These are 20-foot floor to floor. So usually you would see maybe a 10-inch deep mullion at that spot. We had 4 inches to get our mullion in. So we had to connect back every 8 feet to that steel structure that you saw. The other tough thing that you can kind of see here is because we had so little space to work from the inside, we actually had to build this from the outside in. So the glazing got installed first, was temporarily clipped, which you see here. These are the temporary clips to the precast. Then the steel was erected. And then it was connected back to the steel. The temporary clips were disengaged, and then they did the interior work. To do this work, you need the world's smallest man lift, which they found. And it's on site, but you can see it still interferes in the drawing to the left there. It still interferes with some of the work that we have to do in this man lift. So what do? We move the work. So we actually had to move the thermal line because of the tools that were available to us to do this work. Again, this was done from the inside out, so everything was staged at the top floor of the system. And here you can see it in its staging place, and we're going to see in a few images how they actually snaked this into the building. Here's our little 6-inch space that we had to go through. So again, we're stacking these things from the very top and then loading them down 90 feet to get into that space. To me, this reminds me of like a coal mine shaft or something like that the contractors had to work through. So here they are. Here's our little unit getting flown up and being placed through one of those 1 foot by 6 foot, or 1 foot by 6 foot, windows. Whoops. How'd we get here? And then it was winched down using the winch on the right from the floor above, going down 90 feet, and they were all stacked on top of each other. At the crown of our building, we have 5 storefront systems or clear story systems that feed daylight into the courtrooms themselves up at that space. These are the crown jewels of the building itself. So you can see here, they are very ornate, have very expensive cabinetry, And there are these interior louvers that diffuse the light and kind of prevent you from seeing directly outside. We couldn't touch any of that. And we had to get to the window behind it. And these spaces are vaulted ceilings, 30 feet tall, so very hard to get to the window at that space. But what's even more interesting is what's above this space. 20 more feet of void space. So you could fit a whole nother courtroom inside of this courtroom, just the way that it's constructed. And of course, they have to put the structure at the very top corner, where we need to tie in and get our loads back up into the structure of the steel, so you can see how far away it is from the window. But our engineers devised a very good way of connecting this. So we have this E-shaped steel bracket that actually goes through those louvers that we saw earlier, and they reclad around those louvers to hide them. To do this work, we had to do some amazing scaffolding work to get up into the space, and we couldn't touch much of the ceiling either. This is actually inside the ceiling, the scaffolding work in there, and they had to snake it up or kind of get all of the steel work and everything else that you can see through this one little hole. There were about 3 of these in each room. And this is the steel in its final location.
And then on to the next one, kind of the main event of the building, Curtain Wall 1, as we call it. So Curtain Wall 1 is about 100,000 square feet. It's about 200 of that 300 feet in height, about a mile of mullions. It's a big system. And it's very prominent in the building. It also, as I mentioned right in the beginning, it's where all of those sort of very private and sensitive spaces are. So the judges and the attorneys, etc. So this was phased. When we were working on A, E still had about 6 months of time in their office, for example. So looking at this, I think one thing that's part of this story that's interesting, kind of zoom into our space. So you've got your judges' chambers, and thinking about those loads that we talked about in the beginning, the push and the pull of those wind loads and hardening or blast loads, thinking about how we're going to attach back to the primary structure. This here is kind of the obvious approach, right? You've got a big, nice beam that runs around the perimeter. You just kind of grab onto it, and then you can drive forces in and hold on as things are getting pulled out. This is where we were at for, I think, about 3/4 of our construction document phase. And then during a meeting, somebody brought up, that's going to be kind of hard to do. You're 25 feet up in the air with hundreds of pounds of steel trying to drill in, 8 holes per beam and lifting these things in, and you've got to do that about 400 times. And so we scratched our heads and thought, how else could we do this? And I think it was somebody from Bryan's team that came up with the silver bullet, so to speak, of how we could approach this from the top side of the slab. And the way that we did that is we embedded or let in rebar at each location. So each node of attachment, each intersection of slab and mullion had 2 channels that were let in, and they cut in about 1,000 trenches with this cool German saw. I don't know why I put this in the slide, but it's because I really like tools, and I think this is a cool tool. So they worked and worked and worked, and one of the nice things about this approach is that they could do all of their steel work, and this is kind of a common theme in the building, before the facade came off. So you can see the tent up there. That's sort of the working tent, because remember, you're doing all this kind of very intrusive work, but you've got active courtrooms going on, just a couple hundred feet away. And so this was all that, as I mentioned, done in phases. They would demo the facade. They would add those trenches and anchors. You can see kind of the saddles that the windows start to sit on. And then they would install the new window system. Something we haven't talked much about as part of this process were the design opportunities that we had. And I kind of want to leave you with a handful of those. Because as we got into this project, it is very, very technical. But as an architect, I'm of the mindset that whatever you can grab onto in a project that is either interesting or meaningful, like those are kind of, that's what keeps you going. And so one of the things that we're really proud of with how this project came together, on the bottom left here, you can see the existing. And I mentioned in the beginning of the presentation how large this building loomed on the skyline. And it really felt almost like the Death Star as you were driving it. And I don't think there's anyone from the court here today, but I'd say they'd probably agree with me. And what we were able to do with the new glass is turn it into more of a beacon. And so it's much more responsive to the environment, to the sky, it really lights up. Wrong button. And so really happy with that. You can see also window treatments, even just the interiors, the spaces, and the way that we, updated the mini blinds to a different system, to a roller shade system. Really happy with how that turned out. And then the last one, this one is still, if you were to go to Kansas City, you could kind of see this in progress. Curtain Wall 2, which is kind of the counterpart to Curtain Wall 1. It's the other primary system of the building. This also, so this is kind of right at that main south entry. Right here is sort of where that, that's not the right button. Right down here is sort of the main entry with a skylight about 60 feet above that looks up through that space. And one of the things that we grabbed onto here, because it's such a tall space, one of the subtle moves that we did was actually lowering that first mullion. And what that did, it's you may not catch it when you first glance at it, but man, what an impact it's had in just bringing a little bit of human scale to that view. So it sort of frames your view looking out down that main axis over to that building, which is City Hall, just across the way. And so here we did some in-place mock-ups just to kind of test some of the articulation of the facade. What you'll notice is that we're grabbing onto some of the language that's at that north facade and bringing it to the south. There's sort of a 90s vibe to the existing, where we've got that, very flat facade with the metal panels and the glass. And so we're trying to liven that up a little bit with the articulation of that, those elements. And so won't get too far into the stories here, but just as complex as a lot of the other systems. Really interesting to see it come together and people working almost on top of each other, prepping these connection points. These are, about 600 pounds a piece. They're very large members that drive back into the beam. A lot of lead in here, a lot of geometry to navigate. But this is the image that we want to leave you with today. And this is one of my favorites that we've taken so far. You're kind of standing on that skylight 60 feet above the atrium and looking out across that great view. But then you see kind of the old and the new together. And so it's been a fun project, a lot of challenges, but we're really happy with how it's come together. Thank you.
Thank you very much, Stephen of Krueck and Sexton, Bryan Howard. I thought I was doing postmodern rehab surgery, but you guys are absolute magicians. That was very creative and informative. Thank you. Next up, we will be having Eric Claeys talk to us about hybrid steel facades. Eric is a founding partner of, I don't see it here. Eric Claeys is a founding partner of Fassada. And he will be informing us on the future of hybrid systems. So please welcome Eric.
Nice apple, no? My name is Eric. I'm coming from Europe. Maybe in 2 words what I've been doing the past 40 years. The past 40 years I was in curtain walling. After I spent about 10 years at university for civil engineering construction, civil engineering building physics, and economy, master in business. I'm in that business since many, many, many years. And in around 2000, I've been running some of these facade contracting companies. I discovered something. And this was the reason and the start, let's say, of our group Fassada. And there were two things. Very amazing, by the way. Facade contractors go faster bankrupt than they can start. All over the world. All over the world. In Europe, it's very bad. In US as well. Canada. Middle East is a catastrophe. That's not okay. Secondly, you have some of these system houses. They did it very well. So I decided to do a study about this, to discover the reason for that. And one of the reasons is the, let's say, the product you use. You have, I do only curtain walls, by the way, and not only steel. We have a huge portfolio of aluminium systems. 2 families, stick systems and unitized, and they all do the same. All do the same. Do you know one single industry where they use the same products the past 50 years? I don't. These so-called system houses, they only did one thing the past 50, and they 2 things. It's counting their money, their profits, and copying each other, even their stupidities. Nobody had thought about anything if it could improve something in the interest of their customer, the facade contractor. By the way, we have lots of consequences for, as well also architects, as building developers. What is my main concern? Before I start about this, I can assume that you received this in your package. As we are present in about more than 40 countries, and this is 40 years, I discover every day, and my concern is the lack of basic knowledge. You know what it is, a curtain wall? I hear nice, all these stories. A curtain wall is an envelope going around a building. You hang it on. You hang it on that building. And the behavior of that curtain wall is defined by 2 basic science. Building statics, building physics. Building statics, building physics. I'm going to take 2 nice examples. The lack of basic knowledge. You see my apple? You know the law of Newton? What did Newton? He took an apple in his hand, and when he opens his hand, what's going to happen? Lots of architects, they think it's going to float. Fall down. That's a problem. I see every day. All over the world. That's a problem. I've started many years ago, I said in the building industry, a curtain wall is hanging on your slabs. When you had real slabs, now they don't construct anymore. They give you a lasagna and they hope that your facade should absorb everything. And then we have the idea that it is the curtain wall system. Completely nuts. Bullshit. It's bullshit. Sorry, it's nonsense. Second thing, about lack of knowledge of basics building statics. Your country. You are testing. Inter-story testing. Vertical. Did you ever see move a building like that, like an elevator? I don't. Building ways that move like that. Did you ever hear about differential movement? Differential dilatations? We did testing. Many years at university. But all this is, and believe me, 90% they fail. If you do this testing, which are representative for what's happening on a building, but it's unfortunate. This whole building and standard commissions, they are controlled by the industry. And they will never accept standards in which all their systems will fail. Building statics. Can you imagine? I don't understand. By the way, it's not in our proper interest. Building physics. In Europe, they speak a lot about sustainable buildings. What the fuck? How can you say things like that? Carbon emission in a building is about 20% is from what we say, your materials embodied, and 80% is from your operations. They make glazed buildings, like you see here all over. I know projects with a Bryan Gold certificate. They are energy monsters. These are people who never heard about the greenhouse effect when you sit in the veranda on a sunny afternoon that is getting hot, because the sun is coming through the glass, it's absorbed by surfaces, and then it's trapped, and then the temperature rises. Can you imagine that? We are these engineers. Shocking. And I see it every day. Well, I hear about, how is this? Aluminium systems. We know all about aluminium systems. But we said we have to do something completely differently. What does this offer? And we started many years ago. So, by the way, the development of our products, we only distribute products which are worldwide, globally patented, which result in 800 patents. We never look to somebody else. You have to think out of the box and do it completely, the design completely different from know your customer, and to make a design as cost efficient as possible. And by the way, what do you see when you design and when you engineer? That every detail, the most simple solution is the best and the most cost effective. If you don't have the most cost effective, trust me, it's wrong. It's wrong. Things have to be solved. You need to solve complex things in an easy way. And we said we have to go to steel. We have to go to steel, cold rolled steel, but cold rolled steel without welding, not like in the Middle East, with the same weight of aluminium. Is that possible? For sure. We did it. It's over there. You can see it. It's a facade of about 7 to 8 kilo per square meter. And I will show you there's the only facade on the global market available, which is not unitized, which has architecturally unlimited freedom, and which is installed from inside. For facade contactors here in the audience, to give you an idea, production time, what we have there, 1 minute per square foot. 1 minute per square, and then it goes to curtains. In steel, we have a global partnership, because we have aluminium, for steel, we have a global partnership with Montage Stahl. Montage Stahl is the number one of important steel facades and based in Switzerland. There we will have one of these fully robotized. It's not automated, it's a robotized factory. We do about 100,000 square meters with only 4 people on the work floor, and we can guarantee exactly a consistent quality degree. I will try to discuss a bit about this. I go further. Oh, sorry. A few topics I have to look for my disruption. Disruption is good when it means cost savings. Disruption has no sense when it costs more. It's all about money. We always say, at the end it's all about money. Sorry, engineering doesn't make any sense. It's money. And if you can make it more cost effective, forget it. And disruption and cost saving goes hand in hand, but you have to do it properly. You have to know what you're doing. What is a hybrid system? I go fast over that. A stick system was developed in the years 50s, 60s, past century. We know its positive parts, its pros. The guy who developed unitized was a friend from me. He's almost as old as me, Mr. Fenzi in Italian. He tried to solve a couple of problems. But here, the reason why he did this, lots of negative points, cost times, techniques, but he inserted lots of other problems. Very high material cost, astronomical transport cost, at the value 0, lost money, high long-term finance cost. One of the main problems, I'm a banker, I'm an economist, why all these companies go bankrupt, they do stuff and they don't have the financial backbone to do this. Don't do that. High storage cost, very long production time. People say it installs fast. That's bullshit. You have to wait half a year before your first panel is there. Long lead times, technically, I saw it here. I come back to that later. Oh, no, I first come in. I think we resolved what we did here. What is this? It resulted in this. Took 40 years of development. But I think we cut off all these negative points and we added some more. Why steel? Carbon emission, I think in US is not a big point. Steel is green. Very easy. We do this so in a productivity capacity. You don't know. I go over this. Carbon emission. Everybody speaks about 20% embodied. It's a discussion in the margin. It makes no sense. This is the key. That 80% operational. Did you know that when you use proper shading systems, that you can reduce your operational cost by 50%? Did you know that? The best glass, people around you, with a G factor of 0.2, we can reduce it to 0.01, so 20 times less. Nobody does it. And this is just due to the fact the whole operational cost is linked to your skin, because your skin is your barrier between inside and outside. People forget this. This is common sense. It's your skin defining your performance of your building and your consumption. By the way, for investors who say they build to sell, that it doesn't care, they are wrong. They are wrong. Because the savings on this, you can sell it on yield basis. We do it. I'm an investor myself. One in London, Bryan Gold, an energy monster. People say they use the energy, whether it's green energy. Wrong. If it is cooled or heated with green energy, use the green energy for something which makes sense. But first, don't create a problem then to solve it. That's the way how they do it in countries where they don't have money and resources. Very basic, round, no window. I didn't say that you have to design without windows. I didn't say that. That's a good solution. That's a bad one. Or does that mean that hypocrisy of that system, of that certificate? It's a nice one. You can do this. There is a sample over there. You can do it in steel, but you can do it also in stainless steel. We can do it in dual-fold stainless steel, which has been developed to be used on offshore constructions, and we give 50 years of warranty without corrosion. So the whole coastline, and therefore we can do electrostatic coating. I don't know if people saw this ever. This is fantastic. It's the coating in the metal. We give 100 years of guarantee. And by the way, at a lower cost than aluminium. And we do this only here at the exterior shell. What is this? Circularity. I just saw here a presentation. It's a good one. For investors, developers, it's key. A curtain wall, it exists of two things, a grid and infill element. That grid is good for about 50 years. Let's say that's a life cycle of about 50 years. But not these infill elements. For two reasons. First of all, double glazing, it has a lifetime of about 20-25 years, but there is another reason. There's a huge evolution in performances of glass. Enormous. And we are now in the stage that we can make from a building a power plant, even from vision glass. This means what you do now, 2025, is old-fashioned in 5 years. You have to replace the glass. When you need to replace the glass, and you want to do it at a cost effect, you have to do it from inside, without taking a curtain wall off of this mantle. Dismantling a building costs a fortune. For developers here around you, you can say, it's not my problem. No, it is your problem. You can sell a building that can be updated in 50 years 2 times, and that thing, that difference in cost, you can sell it on a yield basis. Then you make money by thinking. It's different. Time has changed. We are in 2025, and we are not living more in the 15th century. This is what you need. It's your skin which allows you to make money or not. Everybody is crying, but nobody is thinking. Lead time. They're on top. Unit tires. By the way, I have nothing against unit tires. Because we developed ourselves some unit tires. We took it out of the market because we want to follow a straight policy. Structured glazing. Don't let me laugh. You have to take it off, and performance-wise, it's the worst solution you can get. Don't do it. That's the technology of 30 years ago. My car, it was developed 2 years ago, not 30 years ago. And that's here, Fuzzy. That's our little guy. We're going to launch on the market to help people. Now, we come to US. We're going to start constructing huge facilities in Kentucky for the aluminium port. We made, meantime, for the aluminium port, we made a partnership with Goodis for whole North America. And we are in negotiation for the steel ones. We only make exclusive agreements because we don't allow that people with our products, they go in competition. Don't fight between each other. Make a partner, I will make a deal, they have to make money. Our clients have to make money. We don't have to concern them. We need to give them the stuff that they can make money to avoid that they go bankrupt. External claddings. Unlimited. And we fix this directly on the millions. All the kind of shading devices. Patented systems for smart glazings. This here, we solved. We have a technical solution, what we call in passive fire resistance, that with a steel curtain wall, we don't need sprinklers anymore. Out with all the disadvantages of sprinkler systems. First we think. Then we need to think to last. That's my thing. Thank you for your attention.
Thank you so much, Eric, for your charge to us to push to think differently, especially as we have to approach our facades differently and do more and be better. So, dankjewel to Eric. Up next, we have Jim Lamm, who is the National Architectural Manager from Viracon Glass. Vitro, I'm so sorry. From Vitro Glass, who also worked with our office recently to help us understand what our options and choices are here with the facade. So please help me welcome Jim Lamm to the stage. Thank you.
Thank you. Okay, I've got giveaways. Wow. Okay. Well, there's an old show business saying that should never follow children or talks on hybrid steel curtain walls. But I'm going to do my best. So I should always start out with a joke. So I didn't write this, but I'm going to do the best I can to present it. So a group of birds are flying downtown, and they come across this brand new all glass high rise. It's shimmering, sparkling, reflecting the sunlight like it's auditioning for a glass commercial, right? And so the lead pigeon looks at it and says, "All right, team, standard operating procedure, full speed ahead." But then one of the younger sparrows pipes up, "Wait, look closely, that's bird-friendly glass." The pigeon squints and says, "Bird-friendly? What's that mean?" Sparrow replies, "It means the architects thought about us this time. They added patterns so we don't mistake it for open sky." Pigeon rolls his eyes. "Great, another design trend. What's next, bird escalators?" But the sparrow insists, "No, seriously, watch this." So they dive towards the facade at full speed and stop just short, because instead of an invisible death wall, they see dotted patterns spelling out in architect handwriting, "Not sky. Please don't sue us." And birds are impressed, and one of the cardinals says, "Finally, a building where survival is part of the design intent." And the owl, who of course is the building inspector, hoots, "About time. For once, the architects made something both beautiful and functional. Write that down. It may never happen again." So, anyway. So why are we designing glass to save birds? This happens to be a very low-resolution picture of McCormick Place here in Chicago. It's 120,000 square feet and about almost 3 acres of glass walls. And south of the center is a bird sanctuary, and the northern section includes a recreated prairie. So no problems there, right? Well, in the United States, more than 1 billion birds die each year by flying into glass, and this makes glass the number 2 killer of birds. I have a question for you. Does anybody know what the number 1 killer of birds is? Anyone? Yeah. Right there? Come on up and get your spotter scope. So, right there, kitty cats. So, so why the high numbers, right? Well, because of a bird's instinct, it does risk dying by colliding with structures in their flight paths. So when the structure is transparent or whenever it resembles the natural environment, that's a danger. A couple of years ago, some of you, if you're out from around here, you remember this. I was actually at a conference here the day after this happened. So on the night of October 4th to the 5th, 2023, almost 1,000 birds died. These are part of the birds that died after colliding with McCormick Lakeside Center in Chicago. And the event occurred during a period of significant bird migration. It did involve multiple species. Most of the bird collisions occurred on the east and north sides of the Lakeside Center. Bright lights and the building's location right along the lakeshore also contributed to the mass collision. And this event did highlight the city's high bird collision risk, especially for migratory birds. And this also prompted increased attention to the issue of bird-safe building design. So some examples of dangerous birds or glass for birds. Highly transparent glass. The birds mistake this. They think it's absolutely clear that there's no glass there and that they can fly into the trees and plants to perch inside the building when the glass isn't visible to them. Reflective glass is kind of the opposite. This reflects trees in the surrounding area, so birds attempt to fly into the trees reflected on the glass, mistaking them for natural environment. Fly-through conditions. A lot of times this is sky bridges, corners of buildings. Birds believe that they can fly through the transparent building areas to get to the other side. Glass that's amongst nature. Glass environments that look like the natural habitat can put birds at risk. Examples are glass near green roofs and walls and buildings that are integrated with glass in natural surroundings, just like something like this. Backlit glass at night. This is a big danger for birds. Stronger indoor lighting during low light hours can make glass imperceptible to birds. And then again, glass in migratory paths. This is for the flyways throughout the United States. You can see there's a lot of cities in those flyways. So test your knowledge. I've got 3 more spotter scopes here. So can anybody identify some of the dangerous glass on the building in this image? Anybody? Very good. Come up and get your spotter scope. Anything else? Very good. Anybody else? Come up, get your spotter scope. There's reflective glass, fly-through glass. Anything else? Where? Transparent glass, low visibility for birds. Coming up. So another thing that's not really pointed out here, but all the glass is lower than the canopy around, than the canopy around it, judging by the tree here in the corner there. So that's also a danger for birds when it's lower than the canopy. They fly around there, think they can perch, and run into building glass. So what is bird-friendly glass? Well, bird-friendly glass, bird deterrent glass, has optical markers that are visible to help birds, such as lines or dots or other patterns, helps them avoid collisions. These patterns on the glass surface, they could be on the glass surface, they can be embedded in a laminate, and the patterns are designed to maximize visibility to birds, but be less visible and intrusive to humans. So what bird-friendly glass is shown to work? Well, the ABC, which is the American Bird Conservatory, defines bird-friendly or bird-deterrent materials as having a threat factor of less than 30, and that threat factor means they reduce collisions into glass by at least 50% under real-world conditions. And how do they prove that this actually works? This is a test tunnel that the ABC uses. To assess this, various deterrents are tested. They put the glass at the back of the tunnel. They release, I think it's at least 80 birds at a time, and then they count the number of birds that avoid the collision, and then the amount of birds that fly towards the glass. No birds are hurt. They catch them in a transparent net, but that's actually real-world testing there. And with that testing and all the research done, there's a couple different rules. There's 2 rules. You'll hear them referred to as the 2x4 rule, a pattern that's no larger than 2 inches tall or 4 inches wide. This is most species can see these markers and avoid collision. For smaller birds like hummingbirds, there's another rule, which is called the 2x2 rule. This carries a lower threat factor. The lower the threat factor, the better it is at deterring birds. So this is a 2x2, which is 2 inches wide by 2 inches tall. So where do these markings work best? Well, they work best where the birds can actually see the pattern, which is closest to them. So that would be on the first surface or the exterior surface of the glass. And let's talk a little bit about a couple different glass technologies that we have. First surface laser etch or acid etch. This is very perceptible to many bird species. It is on the first surface. It has a lower perceptibility to humans because it's translucent. It's actually very light, and since you're looking out from inside the building and it is on the furthest surface from you, it's less perceptible. A lot of times, like with any frit, especially with something like this, after a while you get used to it and you just kind of look past it. Multiple pattern options, there's lines, there's dots, there's organic patterns. When you do something like this, you can use, it's the highest energy efficiency is achieved because on this first surface laser etch or acid etch, you can put your low E coating on surface number 2, where it does the most good at keeping the sun's heat out. Then you have first surface ceramic frit. This is also a technology that's available. Again, since it's on the first surface, it's perceptible to many birds. Typically, it's going to be more visible to humans because it's not going to be as translucent. It's going to be a solid color. Some things to think about with this, the fabricator that does this may not have the capabilities to produce a first surface ceramic frit. A lot of them might carry a less robust warranty because it is exposed to the exterior and the elements instead of being on say, a third or fourth surface. And typically, the ceramic frit on surface number 1, you're not going to be able to put your low E on surface number 2 where it's most efficient, so you have to move it back to, say, surface number 3 where it's less efficient. Second surface ceramic frit, also another technology that is available. It may not be as perceptible to birds because you're getting further away from the first surface where they can really see it. Again, the fabricator may not have capabilities to produce a second surface ceramic frit coating. This says first surface. Whoops, I went backwards there. Sorry about that. Second surface ceramic frit typically is not going to share the same surface as a low E coating for most glass fabrications. So then you have to move the low E back to, say, surface number 3. UV coatings, these are neat. A lower perceptibility to humans. They're supposed to be invisible to humans. The color intends to be clear or transparent, but sometimes, depending upon the conditions, depending upon the angle of light, it can be perceptible to human beings, and you can see kind of a rainbow effect there. One of the things, not all birds can see ultraviolet. Species like raptors, kingfishers, they don't see those as well. Hummingbirds, pigeons, less sensitive to UV. And some UV coatings do require the use of a laminate as well, which adds complexity. And as well, all in this room, we all know when you add complexity, you add price to it. So laminates. These are perceptible to many bird species. They're also highly visible to humans. And that's because the dots that they use on this, the color appears like a silver reflective, almost like a jewel. And light commonly doesn't pass through the markers. So another thing, it might be difficult to align the pattern since it is a laminate from window to adjacent window to keep that right. And an IGU with laminated outboard light with low E coating on the fourth surface may be an expensive IGU to construct. And in this IGU pictured, the coating should be placed on the fifth surface rather than the fourth surface. Post-installation first surface field applied markers. These are perceptible to many bird species, high perceptibility to humans with some patterns. Color appears opaque. Might be difficult to match patterns around openings since it is field applied. Some of the things to think about: longevity, 15 years, 20 years, maybe not that long. Cleanability, I don't know. It varies from manufacturer to manufacturer. So what did McCormick Place do? Well, 1 year after the bird strike event of October 2023, they applied a bird-friendly film, and then this particular film was then removed, and it left a dot pattern remaining on the exterior of the glass. This process was not easy. It involved lifts and boom trucks, 2 shifts a day, 5 days a week, 3 months to complete, at a cost of $1.2 million. The expected lifespan on it's 15 years. In addition to the window film, McPure also reaffirmed their commitment to the Lights Out Chicago campaign, which requires buildings to turn off lights when it's not occupied, also to draw shades and turn off lights that aren't necessary as well. And the result of this bird collision is reduced by 95%. So it looks like they've solved their problem there, which is great. So if anybody has any questions on bird glass or glass in general, come see us here at the back. You can. Absolutely. With acid etch and laser etch, they've both been tested, and there's no issues at all. So thank you for your attention. Appreciate it.
Thank you, Jim, for reminding us that we should be considerate of everyone, including our other fellow species on this planet. And also, I'm very excited about my new bird scope. We're going to have a short break, but I would also like to remind all of the speakers that have spoken for this first session to come back up to the stage so that we may take some pictures with you. And I would also like to thank them as a recap. Thank you, Daniel, for showing us how to elevate contextual details into a solution that fits the neighborhood but can also humanize to scale. Thank you, Stephen and Bryan, for showing us that with some flexible thinking and creative strategies, you can go after any challenging situation and pull off what you need to pull off. Thank you both to Eric and Jim for reminding us that there are a variety of tools in our toolbox that we shouldn't overlook as we try to pursue all of our goals. So at this time, everyone is free to take a short break, enjoy some coffee, ask some questions of the speakers, and we look forward to seeing you shortly for the second session. Thank you so much. We're now going to segue from talking about glass to talking about glass. But we're going to talk about glass in a new and exciting way and some intriguing new options and ideas, solutions. So I would like to welcome to the stage Lisa Rammig, a director from Eckersley O'Callaghan, and she will be showing you some of the new and exciting details they've been working on. Thank you very much. Cool. So we're going to talk about glass a little bit, just because. And when I think of Chicago, I think of that. And I think of how that is a lot of intriguing new ideas about glass that I think we all need a little time to chew on. Very impressive. It's also nice to have a good behind-the-scenes look at some of the projects I think a lot of us might be already familiar with, and to see how they've developed and evolved. Thank you very much. Next up, we are going to have our regional sales manager from Cosentino Façades. Please help me welcome to the stage, Eneko Igartua.
Hello, good morning everyone. I'm Eneko Igartua. I'm the regional facade sales manager for Cosentino, and today I'm talking about sustainable facade design. I'll start with a quick overview about Cosentino, then I will dive into our circular economy and sustainability strategies, and then I will introduce Decton, and I'll end up with some applications and real-world case studies. So Cosentino is a Spanish family. It's located, the headquarters are located in Almeria, southeast of Spain. As you can see, it's a very dry area. It barely rains there. And about 50 years ago, it might have seemed impossible to grow a company like that in such an environment. But the Cosentino family started this small family business extracting and working the stone. And they gradually transformed Cosentino in the company that it's nowadays, with operating in more than 120 countries and with more than 6,000 employees worldwide. The DNA or the essential values of the company are still the same. We do things with passion, with a lot of attention to small details, and most importantly, with a deep respect for the environment we work in. You can see here, again, it's a dry area. It barely rains, and it's in the middle of a desert. So we have 9 different water treatment plants to recycle 99% of the water that is used in the manufacturing process. Also, Almeria, or all the south region of Spain, receives the highest UV radiation in Europe. So that's why we have all the solar farms, all the solar panels there, more than 60,000 solar panels that are able to produce more than over 25% of our energy requirements. Not only that, we have also other technologies. We have waste recovery systems. We have heat recovery systems. So all of that contributes to reduce the carbon emissions, to reduce the greenhouse gas emissions, and reduce our footprint, of course. And that effort of reducing our footprint and being carbon neutral, it's not only focused in the manufacturing process. It's a process that takes or involves all the supply chain, involves somehow all the employees, of course, and it's something that that also involves like all the resource efficiency. It involves the design of the products, the distribution process, the use process. So everything is involved in that effort of reducing the impact. So I will explain a little bit this wheel. So if we go to the provisioning, if the provisioning stage, we are empowered by unlimited source of energy, which is the sun. As I said, Almeria is one of the regions that gets more sunlight during the year. And not only that, but also 60% of our Decton colors contain up to 80% of recycled content. That's a lot, and so we have those systems. In the design stage, all our new collections are safer and more environmentally friendly. Decton contributes to lead points. We have EPDs, we have different third-party certified certifications, and of course, Decton has also like different awards, not only related to design, but also to sustainability. In the production stage, as I said, we use best available technology. We recycle 99% of the water, 100% of the electricity that we use is renewable, and we recycle also part of the material. We have automated logistics. We have robots in the factory that bring the slabs from one point to another, and we have other technologies also to boost energy efficiency. All of those efforts are to reduce the emissions of carbon, of course. In the distribution side, we also have internal and external strategies. Little details like we have, for example, carpool. We offer like carpooling. We offer shuttle corporate buses. We build bike lanes. So all of those little details are to reduce the footprint. And also, Decton is in the consumption stage. Decton is designed to last over 60 years. And in the recycling stage, as I said, we also recycle. Overall, we recycle around 80% of all the materials. So that's a huge effort. Decton and ultra compact stone, it's a 100% carbon neutral cradle to grave material. That means that we track and we manage the full life cycle of Decton, and we reflect that in our EPDs, in our environmental product declarations, and you can see there all our emissions split in different stages. And not only that, we also offset the carbon emissions by investing in internationally verified carbon markets. So we have different projects to offset all those emissions. Let's jump into, I will introduce you Decton, the ultra compact stone. Ultra compact stone is known as also sintered stone or ultra compact surface or engineered stones. It has different names, but basically it's a mix of different minerals that are crushed down and then are processed under intense heat and pressure. So we basically replicate a natural process that nature does in stone formation. We didn't like invent anything new, but instead of taking thousands of years, we do it in a couple of hours. That's the only difference. So the result is that we get architecturally stunning material, very durable and flexible material that can be used not only in the exterior. We can also, we use it for facades, of course, but it can be also used in the interiors for flooring, countertops, shower trays, and many other hard surfaces, or even swimming pools, for example. The manufacturing process can be summed up in 3 key steps. The first one will be taking those 20 minerals, crushing them down, and mixing everything. We will use different minerals depending on the color of the decton, and we basically apply a big pressure of 25,000 tons. That's equivalent of 2.5 Eiffel Towers. And after that, we will take into this oven. It's 200 meters long, which where the sinterization process will take place. So in that process, all the minerals will crystallize, or the temperature will rise over 2,000 Fahrenheit degrees. So all the molecules, all the minerals will blend at a molecular level. So when it cools down, we have a hard material, a duro, death flat material, and the good news is that we haven't used any resin, any binding agent, anything, just minerals, heat, and pressure. So that will give us a lot of advantages. For example, it's UV stable, it's a non-combustible material, it's a non-porous material. That's very important. So that's why it's graffiti and stain proof, because of course you can paint a graffiti there, but everything can be removed very easily. Low coefficient of thermal expansion. Of course, it's freeze-thaw proof, so perfect for climates like Chicago. Dimensional consistency, extremely durable, resistant to abrasion, or to put like in high velocity hurricane zones or like this kind of zones. And then easy to clean and maintain. And as I said, it's carbon neutral, cradle to grave. And we offer 25-year material and finish warranty. So peace of mind is guaranteed with Decton. 2 different sizes, 56 inches by 126 and 64 inches by 130 inches. We have 4 different lines. We just launched the last one, and we are opening the 5th one here, not here, but in Jacksonville, Florida in 2028. So it's also a lightweight material, of course, for approximately 4 pounds in our 8mm panel. More than 70 colors available, inspired in different natural stones, marbles, graphites, granites. So, and we are also launching a new collection. And we can also do solid colors. Maybe we have to match the color with some other materials or the framery of the curtain walls. We have to match the same color. So we can do some solid colors, or we can even change the tone, or we can print different logos. So it's very flexible in that sense. And it's also, and there are also different ways of supplying Decton. Can be in full slabs, or we can supply cut to size with mechanization or without mechanization. All the panels will have a fiberglass mesh. That's a safety measure to cover like any impacts or any incidentals, and so all the material will won't fall off or won't fall apart for sure. 3 different ways of installing Decton in facades. One is ventilated facade, rain screens. Another one is curtain wall, and another one is just direct adhere using a thin set or a cementitious adhesive. When we are doing ventilated facades, we work with different partners, and the decision of using one attachment system or the other, it doesn't depend only in the budget. There are different reasons. Depends on the code compliance we are looking for, depends on the performance we are looking for, and of course depends also on the design design of the panels. It's not the same to have full slabs or just like small panels, or it's not the same to have flat panels or 3D panels. So depending on that, we will choose one or another. It's getting more and more common for us also integrating Decton into curtain walls. There are different ways, and it creates this dialogue with the transparency of the glass and the opacity of the Decton. So it's a very interesting approach, and we can integrate in unitized systems, or if it's a stick-built building, we can also glaze in using structural adhesive, SSG, or also glazed in or in captured systems using pressure plates. So different ways we can be flexible, and as I said, we can supply Decton cut to size with holes for mechanizations or whatever is needed for that specific project. This is one of the projects, unitized system projects that we have done in Germany. In that case, we supply the Decton panels cut to size and with a clip, an undercut clip installed. So it was easy to attach in an offsite shop, and then they ship all the pre-assembled unitized to the shop. So of course, you labor savings will be high. This is a building that it's 5 minutes walking from here. Maybe you are familiar with that. The architect wanted to use Decton because we created this book match effect with the Decton. The Decton part is the white one, by the way. We did like this book matching pattern, and they chose also Decton because, as I said, it's extremely durable, resistant to freezing and thawing cycles, and you can go all the way down to grade level because, as I said, it's scratch resistant, it's graffiti proof, and it's also resistant to chemicals. So very good decision in this project. We have another one here. This is in Vancouver. We use Decton Aura, veiny color here that creates this conversation with the cloudy sky of Vancouver. In all these projects, we use undercut anchors, Kale anchors or Fisher anchors. So it's a concealed system. And last but not least, we have our signature project here. This is located in Tel Aviv. This building is 30 stories high. We used 300,000 square feet of Decton in different heights and 11 different colors. So we can also like play with the colors. And the architect designed 7 custom colors for this building. As you can see here in the lower, it's a faceted shape inspired in an iceberg, and the lower stories they will use Decton, and all the AC machinery are located in the lower stories. So for this project, we designed like a specific pattern, these X-shaped patterns. So we allow natural ventilations for all these technical stories, and then all these custom colors, they were all gray colors, and so we create this gradient of colors from the bottom to the top. As you can see, we have here natural ventilation, and in the rooftop there is an upscale and luxury restaurant with all the views to Tel Aviv and the Mediterranean Sea. Now we are building actually another similar, not similar, it's the big brother of the small one, but it's 3 times bigger, and we are also installing Decton there. So thank you everyone. I hope this helps you in your projects, and we are there around the corner, and we also have a showroom here in River North, so you are welcome to visit us anytime.
So often we try to pursue all these sustainable goals for embodied carbon and reduced carbon. So thank you, Eneko, for showing how your firm has actually pursued it and made a lot of it a reality. That's really heartening to see. Thank you. And without any compromise to the aesthetics. It's really nice. Here in Chicago, as everyone knows, we love our steel and glass, and we love our stone, but we also really love our terracotta. So right now, I'd like to welcome to the stage Casey Pritchard from Boston Terracotta.
Thank you. Good morning. Thanks for having me today. I'm Casey Pritchard. I'm the new construction sales manager for Boston Valley Terracotta. I'm here to share what's new with an ancient building material. Architectural terracotta is a time-honored material known for its malleability, durability, versatility. It fits seamlessly with historic and modern facades. It's well-suited for restoration and new build, applicable to a variety of attachment systems. For example, the Fisher Building here in Chicago, Seaside Park Community Center, One Vanderbilt, and the Fitzroy at 514 West 24th Street in New York City. Terracotta starts out as one of the most abundant materials on Earth, clay. It's mixed with water at the factory to create the specified consistency for the forming method. There's 6 to 13 different elements that create each specific clay body color. Manufacturers are committed to the environment. Our clay mines fulfill the Land Reclamation Act to turn the pit back into a thriving ecosystem. Each terracotta recipe uses up to 30% recycled fired ceramics. Recycled content is crushed into garage, which acts like aggregate to concrete and gives it its freeze-thaw durability. All excess or rejected material is also recycled back into the new material, so there's zero waste and a closed-loop production. The building materials pyramid demonstrates environmental impact associated with common building products. Terracotta takes half the energy to produce compared to concrete and 100 times less energy than aluminum. In terms of cradle to grave, the material life cycle, it includes 30% recycled material, minimizing landfill waste. Installation systems also play a part. Individual panels can be removed and replaced instead of replacing the entire facade. The high plasticity of terracotta allows it to be formed into a wide range of forms. These forms lend well to different attachment systems and new build designs. Boston Valley offers 4 forming methods. The forming method is chosen based on the unit size, level of detail, and the most efficient approach for the project. Terracotta is a non-combustible material. It's fired at 2100 degrees Fahrenheit, so it performs well in extreme weather conditions and withstands yearly freeze-thaw cycles. It's UV fade resistant. The Gates of Ishtar were built 2,500 years ago. You can see them on display at a museum in Berlin. The design options offer unlimited combinations of profile, color, finish, glaze, natural through-body colors, or invent a new glaze formula based on your input for color, sheen, layering, viscosity, and other elements to achieve the desired effects. A local jewel, with combined efforts from BTL Architects and Central Building and Preservation to restore 168 North Michigan, Boston Valley was contracted to replace full courses on the facade. All 4 forming methods are used: hand press due to the larger sizes, extrusion for the lineal profiles with high quantities, ram press for the 3-dimensional shapes that can't be extruded but have high quantities of the same shape, and slip cast to create the 3D shapes with lots of detail, which have lower quantities. To quickly dive into these methods a little deeper, hand press is the traditional method for architectural terracotta where clay is packed into a mold. Slipcast is a liquid clay that's poured into a plaster mold, is allowed to dry until the desired wall thickness is achieved. The excess liquid is evacuated, the clay dries, and the mold's removed. Ram press is a 2-piece mold with a hydraulic press, where a slug of clay is placed in the center and 2,000 pounds of pressure forced down and form the shape. Extrusion is the most common for new build construction, where clay is pushed through a large extruder, auger, and a steel die. Restoration of historic buildings has reinforced industry expertise in replicating complex details, glazes, and assemblies with precision. This combination of expertise in forming techniques enables terracotta to serve both preservation and innovation seamlessly, transitioning from restoring heritage facades to creating custom solutions for contemporary new build projects. A redevelopment of the ground floor of the former Sears, now Willis Tower, was designed by Gensler to replace dark aluminum and a fortress of red granite that was transformed into a welcoming and transparent podium featuring extensive retail and dining experiences, as well as an urban green space in Chicago's Loop. The over $500 million redevelopment renovation achieved LEED for existing building certification. It utilizes 2 unique extruded terraclad panels, a white glazed rigid panel at the entryway which carries into the lobby, and a dark multi-glazed panel with an additional false reveal carved to resemble brick. A local to Chicago, Studio Gang Architects designed FDNY Fire Rescue 2 in Brooklyn. It's a state-of-the-art training facility with the ability to simulate a wide range of emergency conditions. It features 3 vibrant red glazes, terracotta frames, 18 different window and building openings. Units are all the same triangular profile die, but each opening uses unique geometry. Each unique surround required a mock-up to develop the interlocking pattern. Foam units were laid into a wooden frame, used the test fit. Adjustments can be made and tested quickly. Each unit was screwed into a frame at proper joint measurements to understand the attachment spacing. Precise layout drawings were developed, coding each unique panel. A full-scale mock-up was used to review all intersecting corner conditions. A concern arose regarding the size of the corner unit panels being too small to attach into the tracking clip system. So resolving this issue required developing a custom panel. It's an 18-inch triple profiled unit, allowing the corner profile to be smaller while allowing the panel to secure into the tracking clip system. Then we could step back and review the mock-up again. The angle of the panels also needed to be engineered to ensure that the tracking clip system could securely hold the panels in place. Each surround required its own engineering and layout for attachments. Panels were labeled by length and color to match the layout drawings. And another unique aspect of the firehouse included embedding the firehouse name into the flat Terra-clad panels. Hand finishers used templates to carve each letter into the panels before firing it in the kiln, doubling as both a training and a living space. It allows quick entry and exit as a working firehouse. The window treatments allow visibility to the sidewalks and street level. Inside, there's a climbing wall, an elevator programmed to shut off to simulate building rescues, and a chamber that can be filled with simulated smoke. The atrium allows direct sunlight and access to green space and open air environment. Ultimately, the terracotta window surrounds act as a striking visual element, clearly communicating the building's purpose to the community. And winner of the 2021 PCI Design Awards for Best Government and Public Building. So what's next? How does this solution get deployed into the built environment? What other solutions are there to solve these problems? And what else can terracotta offer to the built environment? Everyone here is a creative thinker. I challenge you to answer, what is next? What is the next innovative terracotta facade? Everyone is aware of the urban heat island effect and how facade material choices contribute to the intensity of the effect. It's prevalent everywhere and is something this community should be looking at how to mitigate. Coupling that with the carbon emissions paints a bleak picture. Building operation emissions account for 27 of the 42% the built environment is responsible for. It's fair to assume a good portion of building operation carbon is going towards our comforts. Danish architecting came up with a solution for the heat island effect by directing and collecting water across the terracotta facade to lower temperature. Additionally, they analyzed the buildup of the wall assembly and what terracotta wall type would be the least carbon intensive. The proof is in the numbers. After a 10-minute rain event time, terracotta stayed cool below air temperature. 2 hours and 40 minutes later, the terracotta remained 22 degrees cooler than surrounding building materials. So it's not just a beautiful facade, it actually performs. A multi-office international Arab team developed a load-bearing terracotta facade system that would reduce embodied carbon and be highly insulating to meet low energy costs and efficient for building contractors and developers. They researched varied wall systems to determine masonry walls are still lower embodied carbon compared to curtain walls. Using the foam glass, they developed an innovative load-bearing wall, low-carbon solution with structural behavior of a load-bearing terracotta facade system. The system results are 24% less embodied carbon compared to brick and 40% less compared to traditional terracotta rain screens. Not only was it successful in meeting sustainability and performance goals, but it achieves the beauty and aesthetic of ceramic glaze capabilities. Terracotta facade innovations respond to global challenges and enhance building performance. But how do we push the performance further? This is where ACAW comes in. The Architectural Ceramic Assemblies Workshop aims to push the possibility of terracotta facades. It's a hands-on research and development workshop for architects and facade engineers to explore the use of terracotta in high-performance facade design. Presented by Boston Valley Terracotta, Carnegie Mellon University School of Architecture, University of Buffalo School of Architecture and Planning, ACAW brings together professionals from the architectural industry and academia. offering participants the opportunity to explore innovative building solutions and further their understanding of architectural terracotta for large-scale assemblies. Now in its 10th year, research and experimentation at past ACOT workshops have culminated into real-world projects currently in development. Teams research facade designs that address climate concerns and sustainability. At ACOT 2022, WJE developed a terracotta rain screen to replicate a historic terracotta cornice masonry assembly using modern thin-walled terracotta extrusion and modular attachments. The unique profile could be economically extruded, hung from an anchorage system that can be integrated into a historic masonry backup assembly to reduce installation costs. The results are a lighter weight cornice, an easier installation, and a quicker turnaround time. Woods Baggett developed a holistic design that incorporates PV solar panels into terracotta. The objective was to utilize the building facade as a place to capture and create energy. Terracotta can provide a distinctive, unusual appearance. KPF disrupts a typical terracotta lineal pattern by rotating panels to create a unique and interesting facade by embedding it in precast concrete, creating an efficient, cost-effective approach that is fast to construct and minimizes site congestion. Seldorf architects focused on ornamental expression of terracotta and textured depth. Using parabolic strengthening and other measures, reduced the overall weight of the brand pressed tiles. They saw 60% reduction in typical panel weight. The prototype also experimented with the use of a red iron oxide recycled from local coal mines to develop the pigment in the glaze. ZGF architects developed a screen assembly to diffuse light and reduce solar gain. The modular terracotta units are mounted on a rod system that are individually manipulable and have the ability to rotate 360 degrees. Eric Perry's fish scale design for the Fishmonger building entryway in London was originally designed in stone but was going to be too heavy. The choice for glazed terracotta is because the material washes off the dirt easily and is less heavy compared to stone, which meant less concrete was needed for the foundation. The units are self-supporting, and a different series of species of moss and lichen were tested on the prototype to help offset pollution. Henning Larsen set out to design a panel that would accommodate moss growth using a crackled glazed sunscreen with alluvial grooves. And at ACOT 2021, Cook, Fox, and Bureau Happold embraced biophilia, designing a facade that used not just by people, but by the natural environment it's built within. Developed from a single module, rotated with varying microhabitat pods, set up for birds' nests, beehives, and planters, with a bottom watering system and an overflow drain. A facade can be so much more. Terracotta can be so much more. Beyond aesthetics, beyond a visual appeal, a terracotta facade can transform functionality. It can reflect sunlight, disperse heat, capture rainwater, and create habitats for birds, bees, and plants. The potential is immense. Let's reimagine facades as a dynamic element of the built environment. Imagine terracotta facades that do more. What innovations can we unlock? And how can these advancements shape high-performance facades that actively support a sustainable future? The possibilities await. Thank you.
Thank you so much to Casey for showing us how one of the oldest materials known to man is forever innovatable and can always transform all of our buildings in beautiful ways. Thank you again. Proceeding with a heavy discussion on facades, now that we've reviewed all the different materials, we're now going to bring up Luis Palacio from Smith Gill, who is going to take us on an adventure, I think.
Can you hear well? Okay, got it. Hello, everybody. My name is Luis Palacio, Design Director with Adrian Smith and Gordon Gill Architecture. We focus on sustainable design and highly performing architecture. And today I want to walk you through different illustrations of how facades can go beyond the envelope, and they can do more as we require more functions from them. Historically, especially in vernacular facades, the use of materials are very singular, like they respond to a single need, which was shelter. They had very few materials, minimized design elements, and that was it. Today, however, with modern facades, there is more requirements and there is more needs that we need to respond to. And they go from economics, performance needs and requirements, to culture and more human connection. I will talk about 3 types of facades that I have grouped. They are smooth facades, articulated facades, and blended facades. They span in terms of how much space they take and how much they morph and how much they do. I will talk about 2 projects per facade that we have developed. Starting with the smooth facades, it is about embracing plane and addressing performance and economics. Those facades tend to be highly performative. 2 projects are good examples of those types: the Central Park Tower in New York City and the Jeddah Tower in Jeddah, Saudi Arabia. Both buildings are iconic in nature just because of their size, with Central Park Tower being 15 and 50 feet tall. It's the tallest residential building in the world today. And Jeddah Tower is a kilometer high when it's finished, and it will be the tallest building when it's completed. Because of that, they have very high performance design criteria for the facades. They have to respond to issues of wind loads, pressure, constructability, logistics, and the economy of scale. It's all about repetition and how we build these structures as efficient as we can. In the case of Central Park Tower, the facade needed to be engineered to address very low temperatures in the wintertime and issues of ice and snow buildup. In the case of Jeddah, was quite the opposite. We need to engineer for very high temperatures and dust and sand, which is an issue in that environment. So similar characteristics. Jeddah Tower was about becoming an icon because that was the driver for that project, applying economy of scale and addressing a single architectural move, which was the taper of the building. A little bit on the taper, it was designed to mitigate horizontal forces from the wind. When we build that high, that really becomes the driver for the structure and for everything else. We need to do things like tapering to reduce the area at the top, to reduce the force at the top, notching with the balconies to confuse the wind and mitigate that, and also stepping and brakes at the top to do the same thing. It was all about mitigating the horizontal forces with the mass. We, of course, did a lot of studies in terms of pressure and wind on the typical conditions. We have a primary condition and we have a wind condition. Those are the main 2 wall types within the project. The diagram on the left represents the wall types. The red surface is the primary steel wall type. Is about 80% or so of the facade, so is very repetitive. It's a very simple module. It's a 4 meter high by 1.5 meter wide. There are additional conditions that include the wing wall ends, which is the purple line at the ends of the wings, the mechanical floors, and the balconies. Regarding to the typical condition is extrusion. There is no tilt in this area. It's extrusion from the ground to the top and is very repetitive. We opted to emphasize the vertical with an enhanced mullion. The mullion has a light fixture that runs all the way up and also some rails for equipment to clean the windows. The other condition is the wing condition. Like this is basically a tripod. The ends are the ones that slope. And each end, A, B, and C, they have different slopes. So that creates a special condition for the facade to address because it has 3 different angles and therefore the glass length is different on those areas. The horizontal bends for the mechanical floors, we opted to basically just break the facade and create a setback where we place the louvers for air intake and exhaust. It was a very simple, minimalistic solution to that issue. And the other condition was the notches to confuse the wind. They became balconies. And in that case, we needed to modify the module to get it into the slab and create that condition with the handrail. So what you see here is what we are aiming to, a simple shape with a few moves. The facade just has small modifications per performance needs. And it has resumed construction. It was stopped for a long time and it has started again. And we are expecting for it to be done in 2028. That's where we are today, about a quarter of the building. The next building is Central Park Tower, and similar issues, but in this case was more focused towards constructability and tectonic and economic performance. There is a requirement in that market to create something beautiful and special. This is Midtown Manhattan and very expensive. People want something nice. The solution was, these are super tall, not a mega tall, so like the solution was a little more conventional. It is a family of different volumes that stack and move to create some interest depending on different programs. The main architectural feature is a cantilever. It's a cantilever that is 290 feet from the street. It's the tallest one ever built. And the reason for that was to enhance views to our Central Park in downtown Manhattan. And the owner bought the air rights of the property next door to be able to do that. So that gave us a little bit of articulation on the mass, and the facade design addressed that, and I'll show you how. We have two mullion types. The enhanced mullion we call the super mullion because it has a big size. We wanted to give the tower a little more materiality and solidity, not only glass. And we have another condition which was basically just a bad glaze condition for certain areas. The majority of the tower, the shaft, applies the typical module. In this case, is 5 feet by 12 feet and 10 inches high. It just goes, like basically the whole thing. However, like in the cantilever portion, we applied the bad glaze because we want to enhance and to emphasize the views and the clarity of the building in that condition. Other conditions, of course, are the mechanical floors. We need bends, so how do we address them in the facade? In this case, we took half of the module, every other module, to create a vertical louver that will kind of play within the framework of the facade. Another kind is the balcony condition. This simply is an extension of the facade to create protection because of the high winds on those heights. And finally, the crown borrowed different elements from different systems to create something of a scale that was special. In terms of the mullion study, which is the simple element that gives the building a little bit of body and presence, we wanted to create a very big surface that will catch light in different times of days and give a little bit of body. However, we did some snow and ice studies, and we found that there was a lot of potential for snow and ice buildup on those surfaces. So we needed to address that in a way. The solution was to basically detach the mullion from the curtain wall plane to allow air to go through and minimize that surface to minimize the ice buildup, and that's the result of that study. So what you see here is, Manhattan in an evening, and that's the glowing building. That's the result of the use of that super mullion in a very simple way. The second kind is articulated facades, and they transcend the plane. They go beyond, they take more space, and they start addressing performance in different ways that could be maybe more flexible because the technical requirements are less. They deal with energy consideration, scale, and character. They are more special. Two projects are good examples of this. One is the Nanshan Financial Center in Shenzhen, China. The other one is the Federation of Korean Industries in Korea. Both projects are headquarter projects, and the facade design criteria is not as stringent as the super talls. They deal more with the identity of the building, what the client will want, sustainability, in both cases energy conservation, and in one case the facade moved more towards solar control because of the climate, very hot climate, and the other one moved towards energy generation because of policy in place, and I will explain that briefly. In the case of Nanshan, it's a mixed-use project. It has a hotel, residences, office, and a retail podium. We wanted to address that. We wanted to improve energy performance and create an identity. We developed a facade that could be slightly modified depending on the program of the tower and the zone. And that was basically a curtain wall, very simple, with a solar shade in front, metal louvers. We were informed through solar radiation studies, direct radiation, indirect radiation, and also wind. And based on those findings, it helped us to define what the system needed to do. What you see here is the assembly in different distances. We emphasize the horizontal because we wanted to mitigate the high sun. And the verticals are basically just the structure that supports them. You also see that they have different spacing in between them and different depths. That's because each of those address different needs within the facade. In this case, you can see a little bit better in the section. Some of them address need for shading, other ones address glare mitigation, and other address need for natural light to get it deeper into the space. Finally, that's what it looks like. The client was happy, it performs, and it has an identity that is recognizable. In the case of FKI, the facade is very performative and is environmentally driven, very specific, and it was about the policy implementation. In Korea at the time, there was very strong economic incentives to incorporate solar or clean energy into the buildings, and that was what made the facade possible in terms of financial feasibility. Solar studies are always our friend. We take a base mass, we did the studies on it to understand where we could put PVs, and that informed what we did with the facade. So we wanted to create a facade that could be cheaper to build than in other places, and that could perform. We ran different studies on the wall tilt to get to a good balance in between energy generation with the facade and also energy conservation through solar mitigation. This 15-degree tilt of the vision panel was the optimal combination of those two. We did analysis, like always, power generation, how much power can this generate, glare mitigation, and solar reduction. All of this informed the final configuration of the wall. This is the assembly. We did a lot of studies, the sub-studies about how much energy we will project the building will create. We were in the range of 15% to 17%. It's been reported year after year that is reaching up to 20% sometimes, which is really great for the project and for the client. The facade also gets some modifications. In this case, we have atriums for people in the office. And in that case, the sun is more important than power because there are very special moments to create these environments. And in that case, we didn't use solar panels. We just used clear glass to allow more sunlight. We also carried that idea to the roof. We created a trellis in the roof to create more power and also to create a shaded, nice area underneath the top. That's what it is today. It's a simple shape with a special, the facade articulated solution. Finally, the blended facades, those are less typical. They are a little more, pushing the boundary what facades could be. Like in this case, they are not building enclosures. They do something else. They detach to the building, but they create their own space. They go beyond the physical. They address identity, value, and community. They are more fun. And they are spaces that are closest to the human scale and to the ground, and they engage the public space. Two projects are good examples of this. One is the Al-Waso Plaza in Dubai. It was constructed for the Dubai Expo 2020 and is a great success. The other one is the Connector Park in Atlanta, Georgia. That is just a concept that we developed, and we wanted to really push what else we could do with these kind of facades that we developed for Al-Waso. Both of them, we think about them about platforms for social interaction, so they are just something for people, and they deal with identity, the public space, the experience of the people, and the integration of technology. Very important to start to understand how facades and buildings can integrate technology into those assemblies. The Al-Waso Plaza was the first project that we implemented a blended system facade. It looks simple, but it's rather complicated or intricate. For promoting civil engagement and create a destination within the expo. This was the centerpiece of the Expo 2020, say like the Eiffel Tower when the Paris, fair was there, something like that, of that kind of like interest. For this, the solution that we proposed was a civic platform where people could gather. It would be rather a tall, or instead of being a tall structure, it was a space that we could do. The main thing though was to create a garden within the desert that people could use. The issue here though was it's so hot in the summer or most of the year that people don't really like to go out and be in a park because it's hot. So with this assembly, we wanted to create a space that was 10% cooler in the summer months somehow, right? So we did the studies and we came out with this idea of these trellis that could allow some light but not too much and create a cooler environment. We also dropped the floor of the bottom to allow like cooler air to go down and remain there. So when people go there, they feel a little cooler. We did many studies to really understand what plant could go in there. When you create a microclimate, then suddenly the plants and the landscape that will grow in there will be different of what otherwise will grow. So like the design of the facade needed to address that too. We needed to create enough light, some shade, and allow for air circulation. The structural design was very much related to the logo of the expo. We wanted to be kind of cognizant of the culture and kind of be connected with it. The logo of the expo was inspired on a ring that was found in the desert that is precious for them. So that was the inspiration of the structure. That's why it looks the way it does. The panels within the structure is where the tensile systems go, and those are the ones that control the amount of light and air that go to. Another very important component of this was they needed to catch projections because we wanted this space to transform at night, again, to elongate the amount of time that people could spend there and take it into the night. So during the day, this is a space that when you walk in, you feel contained, and already you feel better because the light is not as bright, it's more comfortable to the site, and also it feels cooler. It contains you, and it gives you a sense of space. This is a photo during the expo. People will gather there. They will just be driven to it because it was just like nicer and more comfortable than outside. At night, however, it became this experience, media and a public space interface where people will basically share an experience. It's a 360-degree immersive kind of system, and the facade system needed to support this kind of technology in there. The idea behind this was to create something that could carry into the legacy phase, meaning after the expo is done, what does it become? And we wanted it to become the center of the district and to keep functioning. And that was just to generate value for the neighborhoods around and to ensure long-term viability. So the technical infrastructure that went into this surface is, you see all these things that went lighting, sound, cleaning, all those sorts of things were very important power because of the lighting informed this façade. So when I say a blended system is you see something, but it does many more things that what you can see. Like the things that it does, you can feel them and experience them. In this diagram, you see like let's see this thing. The yellow dots represent the projector pods. Each projector pod had 6 very high resolution projectors, and each projector, had kind of a zone within the sphere. So, and we had 42 of those pods with those 6. So we were like a very heavy technology driven. This is the projector pod. They were assembled in Mexico. They are the size of jet engines, and they contain the projectors, cooling, sound. They project a lot of infrastructure that goes in there, and that was installed within that to make that space, what it is today. So that's a photo during the expo, the outside. So finally, the connector park is an evolution. Again, this is a concept, is not getting built, but we wanted to push the blended system, push the technology integration, and push an enhanced experience. And the concept was to create an elevated park over I-85 in Atlanta, near Georgia Tech, between North Avenue and 5th Street. The shield is kind of like the main feature of that park, and it will house different functions for the school and for the community and for anybody. It could have graduations, concerts, or you name it. In this case, we wanted to take it further and create an interactive installation, not only a projection, but something that could move and react and perhaps understand what's happening and adapt to that. And that's what you see here. So we developed this piece that was a module that could respond to what's happening underneath. Those were connected with pulleys, and they created a network. So it was basically a landscape that was elevated under the shell that could do different things. So you could have like a home position when nothing is happening or it's raining, it just kind of closes. When it's active, it will do something, and when they're interactive, it will move depending on what could happen underneath that. So those are the different conditions in there. Yeah. It's composed by a node, and the node is inspired in a flower. It was something that we were conceptually developing. It has 3 axes, so it can move in, all those directions. When you connect the nodes, it creates a network, and that's what creates the landscape. We have an open position of the flower and a closed position of the flower, and that allows more flexibility to what this thing could do for us and enhance the experience underneath. We work with Kinetica to develop kind of like the mechanics of this thing and how they could operate. And they help us with this system, and that's how like the cables will kind of move and pull the things together up and down. We did a mock-up at the office just for our own understanding. We 3D printed the parts, we got the metal, we got the fabric, and we just did a bunch of these things just to see what is the vibe that they give. It was very fun. We also took it down to the shop to project on it to really understand, is this doing what we think it will do? We took the client on there, just to see the process and just to understand what those things could do for us. At the end, what we wanted to create was something that was very iconic and could be as simple as a background for everyday activities, but also house other things within it. In this case, a gala, or it could be a graduation or a concert. The main thing that we were pursuing with this project was an exploration of how buildings or facades, if we really, develop that, will become a digital interface and how they can enhance the programming and the experience of people with them. Also, how with the AI and everything that is happening today, how they can become sensorial and dynamic and perhaps intelligent, so they can know what's going on and react to it and create a platform for the technology integration. It's very important to start understanding how facades can do that for us, especially now in the age of AI and what's happening with the post-digital interface. So it is basically an invitation to push everybody, people who like make materials, design, architects, engineers, to see what else we can do with these systems. So to conclude, I walk you through three different examples. There are many in between because this is just a range from static to adaptive, and how facades need to give us comfort, like I always did, but also perform, and finally how we can interact with them. Thank you so much.
I want to thank Luis for showing us, taking us on a journey of their facade studies and projects. We are going to be setting up here for our final program for this particular session. It's going to be a moderation panel. In the meantime, I'm going to make this an interactive portion for all of you in the audience. A show of hands. We'll just keep it simple. We're not using the AI yet here. How many of you have traveled from out of town to come to Chicago to attend this event? That is fantastic. If you're wondering where to go for dinner, ask someone who did not raise their hand. We have a serious love of food, and there's no reason anyone should have a bad meal. Another show of hands while we're setting up. How many people have actually learned something new today that you did not know already? That is excellent. And of those, do you plan to adapt a project you're currently working on to use something you learned today? No one's opening their hand. Oh, there's a few hands. That's great. It's always good to continue to learn. How many of you have presented at a Facades conference before? Or a Zak World of Façades conference before? There are a few. How many have not presented before, but after attending this, want to prepare, and this is for Susan, want to prepare a presentation to teach your peers? Okay, we have some work to do, but I like it. I like the motivation. Does anyone have any questions for me at this time that don't involve the Thompson Center? All right, I've suitably killed time. Thank you for your patience and sense of humor. At this time, I would now like to bring up our panel moderator, and she will be introducing our individual panelists. I don't see her yet. Is she in the back? Please, let's welcome Scott Hurst to be your panel moderator to talk about a low funny presentation. I believe you can use this, or you're wired for sound on your head.
That sounds better. Good afternoon, everyone. I believe we are the only thing standing between you guys and lunch, and I'm sure people are getting kind of hungry, so we'll get right to it. I'd like to introduce Sean McGuire. He's a senior associate and design leader at Ginsler, and Dave Murray, trustee at Local 63, Ironworkers Local 63, has been our client for the project that we're going to share with you today. We're going to change pace a little bit, talk a little bit less about the products that were involved in making this building, and talk a little bit more about the purpose behind the facility that we were a part of. It's not every day that you get to moderate a panel about a project that you actually got to work on, so it'll be all softball questions and all answers we know we can cover. But starting with, again, the purpose of the project itself. Innovation's in Chicago's DNA, and ever since the Great Fire, Chicago has really been looked at as a hotbed for design and construction, particularly related to steel and some of the work that's done here in the city. And the Ironworkers since 1903 have really been rooted in making that happen, in that innovation, and they have touched some of the most familiar projects that we have here in Chicago, some of the most famous projects that we have in Chicago. One that I think everybody in the world might know of is the Bean or the Cloud Gate, and then right now, one of the more interesting projects happening is the redevelopment of the Thompson Center in downtown, amongst a myriad of other projects that you guys could, I'm sure, all be familiar with. Something you may not know, and I'll certainly let Dave do most of the talking when it comes to this, is the Ironworkers, this Local 63, installs all of the curtain wall, or a lot of the curtain wall and window systems of the buildings that we have here in the city. And curtain wall installation, facade glass installation was really what led to this project here. This is their current campus in Broadview, Illinois, just west of the city. This is their Union Hall, their current training facility, and in the big red box is really the home to what the building that we're going to be discussing today, which is what we've affectionately dubbed the Glass House. When I say we, I think really I want to just throw out Paul Windy, who couldn't be here today. Paul Windy is their business manager, and he was really the kind of visionary behind the need for a building like this, called again the Glass House, which is a training facility specifically geared at curtain wall and facade installation and innovation. With that, I think we're going to just jump right into questions. We started off this process talking about a lot of things that this building could be and needed to be, but I think rather than hear it from me, I'd love for you to hear straight from Dave. Dave, as a trustee, what made you guys decide that the time is now for a new training facility, and what went into making that kind of a decision? Legitimately, the main reason was the property next door was going to be available. Our neighbor was looking to their tenant was leaving, and we were going to have the availability to purchase the property. So the first thing we thought of was, we're going to get this property. We needed the land in between our properties was an alley. An unofficial alley in Broadview. And we were purchasing the property, and we had a lot of different variations of what we could do with it, and we decided that we're going to beef up the training center. Right now, or at the time, we had a training center that was built in 2003, and it did almost exactly the same thing. It revolutionized Local 63's ability to train on curtain wall installation, as well as the miscellaneous metals. We do the hot work and the window work at the same in the same place. And said in the last 20 years, we have grown out of that area, and we were looking for more expansion. Most recently, we did a renovation of the Union Hall to give us more classrooms. This gave us an opportunity to grow, and we decided its main function was going to be curtain wall installation. We also, having the space, we decided to create a water testing chamber for curtain wall functionality testing that is really a game changer for our apprentices and understanding the function of a curtain wall and not just installing it and, going to lunch. So this was the other thing that was really a decision to be made. But originally we thought, let's just get a big metal Butler building and we'll have the space, we'll make this big warehouse. And we decided we don't do Butler buildings. Local 63 does curtain wall installation. Let's build a curtain wall. The main driver of why it's not the largest job in the city is our other trustees, our management trustees. They are the penny pinchers, so they held us back from the crazy dream that Gensler gave us. But two of them are curtain wall installers, so they were instrumental in allowing us to put what we do every day into practice at this school.
That's great, Dave. And, obviously, as you said, this could be a Butler building. This could be a tilt-up concrete building. And so the desire to make this something that was super unique and extraordinary, and maybe not as extreme as it could have been, but certainly something that spoke to what you guys do. What were some of the conversations like? What were the aspects of why this project needed to look and feel different that actually ended up winning over some of the trustees to help move this project forward?
There was a struggle with the trustees on the cost the whole time, so we did have to take some of the glamour out of it. But they also, there's one of them. They absolutely understood and realized we want to be able to have a larger space to get into the different variations. It's not just curtain wall, it's window wall, it's panel wall. VS1 walls will be able to go in any kind of application. We want our members to be trained on it, at least in the apprenticeship, having the opportunity to touch all the materials. Each company is going to do its own installation, and we should,
Sean, knowing that they wanted a building that spoke to the trade, spoke to what was actually being trained in the facility, could you tell us a little bit about some of the design drivers that went into, ultimately what the final design ended up being?
Yeah, a lot of the vision from the union was basically being able to stand in the middle of the space, look around, and see the craft of their work displayed at its highest level. So the original intention of the building was essentially this pure house of glass on all four sides. And so it is, from a plan perspective, and overall, you can digest the building in probably like 5 to 6 seconds. It's a simple hourglass building with curtain wall on two sides and black precast in the north and south. So really, making sure that the highlighted moment here is everything surrounding glass, from, the super gray spec for the tinted glass and how that refracts and reflects light. So you'll see here that kind of gentle gradient that you see across the segmented facade alludes towards a perfect weld bead, something that's quite frequent in ironworkers' work. So even the allusions and the metaphors here were, again, playing into the craft work. I think, there's some disappointment we couldn't get all four facades to be glass. I was a little bit relieved from a solar heat gain point of view. That made our lives a little easier. But what we did do with the precast that we utilized, in addition to being part of the structural lateral system and helping a lot in the steel tonnage, it also is composed of aggregate that still, again, speaks to the ironworkers. There's obsidian aggregate in it. Again, that's kind of as close as you get to glass from a natural material type. And there's also black beauty sand, which is a byproduct of steel mills, and it was specifically sourced from the Gary Steel Mill in Indiana. So again, speaking to the ironworkers' craft, even though it's not directly a product that the ironworkers produce. So again, every single metaphor in the building, from the aggregate we utilized to the shape of that curtain wall, we wanted to play into some of the fantastic work that we've seen all across our skyline. And indeed, the building itself, we really wanted to reflect the skyline beyond. And so this is, although it's a quote-unquote small building, maybe in comparison to some of the other buildings you all will see today, is the tallest building in Broadview. It's very present. If you're going west of 290, we had intentions, we got a zoning variance to get it to be 63 feet tall.
Yes.
Value Engineering killed that, unfortunately. But still, if you're driving west out the city or going inbound in the city and you're stuck in traffic for 2 hours, look to your right. you'll see big red glowing letters of the,
That's why there's a traffic jam, right?
exactly. We made sure that we shot this photo during traffic, so you all can feel a little bit of pain, I guess. But
So the presence of this building and its relationship to the freeway, certainly the views to and from the building, were something that was really important to Dave and Paul and the whole team. As far as the community is concerned, the city of Broadview, it's the tallest building in Broadview, but from what I understand, there's a lot of pride of the building and what it sort of represents in the community. Dave, could you talk a little bit about the relationship you guys have with Broadview and what some of you've heard after the building's been open?
Yeah, there has been quite a few of the political leaders in Broadview who were thrilled. We didn't know how it was going to be received. We had to go for the variance, and at the beginning of the project to go out towards the street and to be as high as we are. But then after we had the sign put up, we had to have another variance because the sign was too high. So we had to go in there, and luckily everybody there was thrilled. They were like, yeah, go as high as you want. That building is beautiful. We're happy to see it here. We had no idea if they were going to think it was an eyesore or not. But yeah, the local government was very helpful with the vision and accepting everything that we had. We got Ironworker Way out of it. Part of the project was York Street. Had to be, it didn't have to be, but they renamed York Street for us, and it's Ironworker Way now, so it's pretty cool.
Well, and with all of the events that you guys host there, I think people have really seen what you guys do as a good neighbor that's contributing to the job market and creating jobs and giving people stable income and really, again, kind of training that next generation of iron worker into a field that frankly has a labor shortage. I think we're all pretty familiar with the shortages in skilled labor, and not just in the city, but within the country. So to that end, I think, there's been a lot of praise to what you guys are doing out there.
Yeah, absolutely. Absolutely.
Yeah, and Sean, you touched on something earlier. You talked about the facade. There is obviously a lot of heavy metal flying around in this building, and a lot of real work that's happening within this space. And you could imagine the challenges of putting a lot of that in kind of industrial work in a glass box, right? So, Sean, could you kind of touch on some of the precautions that had to be made as we went through that process?
I think we were all sufficiently freaked out about putting a 5-ton bridge crane in a glass house or box, for that matter. So there was a lot of study surrounding that. The superstructure has an outrigger that grabs that bridge crane and kind of offsets it to the innermost portion of the arc that pinches down the center. So that bridge crane kind of floats within the glass box and kind of sets it off a little bit from the glass it's just a safety point of view. We did mention that how the building's 50 feet tall. It's the tallest building in Broadview. But we were really maximizing the amount of volume that you had clear height space in the center, because there's basically a building within a building. There's a secondary steel structure that Dave's team hangs current wall on and also kind of installs and deinstalls at a certain point. And that's 36 feet tall. And the intention was to be able to put a Vala crane on top of that structure. So the bridge crane has a kind of OSHA minimum clearance above it right before the first light fixture of like 1 inch. And so that level of precision within this 50-foot tall space was pretty challenging. But it was something that really took a lot of coordination with our structural engineer, Nair, who did really a great job on this project. So just this is looking at a section of the building. Again, 4 kind of symmetrical quadrants. There's 2 mezzanines on either side that are primarily utilized for storage right at the midpoint of the height there. And you can see that bridge crane that's going north-south, that kind of white box towards the top there. And, also speaking one thing about the facade we haven't touched on yet, but, majority of it is this black tinted super gray substrate. And in the center, we allowed to kind of have this viewing window in the middle. So, folks trying to cut through traffic the west there can look inside and see the ironworkers at work in the center of that training structure there. In addition, when the sun hits the east and the west facade, you see the shadow of that casting down, and the contrast between, your 8% VLT and your 60% VLT, and just seeing that arc of the window cast against the ground was really an interesting feature there. This diagram also speaks to some of the natural ventilation strategies. There's no cooling in the building. we had just a higher temperature set point. Ironworkers are used to working with a little bit, hotter temperatures, but we also have operable skylights and a very large overhead coiling door at the north. So during those, spring and autumn days that are a little nicer, you can open those up and get that kind of natural ventilation approach there.
And these operable skylights, as well as the solar panels that are on the roof, it's not just for show. They're actually speaking directly to some of what Local 63 installs. And Dave, could you talk through maybe how this building is not only just for curtain wall, but also used to advance the products, the offering, the services that Local 63 is getting trained on and actually move the market forward?
Yeah, part of having this space is not just for the curtain wall, obviously, but we want to be in the market for solar installation. The installation of the racking is for sure part of the scope of the mist metals that our guys do every day. And we also have a mass timber mock-up where we've sent a couple of our instructors to be trained on instructing the installation of it. So we have a mass timber mock-up that we still have on the mezzanine. We haven't put it together yet, but in this next coming class, our apprentices will get their hands on mass timber ready for installation. The other, what you can see was over here, that's where our curtain wall function training is. So we can install the curtain wall and then spray it, make sure that it's sound. If it isn't sound, which our guys go in and poke holes, so they have to find the leaks, that is, like I said, huge for our apprentices to have that availability. But the solar training, the carports, the mass timber, all of those things are going to be utilized. And it gives us more avenues for our fencing industry in the space in the parking lot as well.
Yeah, one thing that I think really came into sharp focus during the duration of this project was our ability to implement new and emerging technologies really relies on training people to be competent in their installation. And without that, none of the products that I think were probably being talked about today would actually make it to market, right? There's a limitation there. So what I think is amazing about what Dave and their team does is really embrace these technologies, making sure people are trained up on it. So things like solar panels, things like today we were talking about solar pavilions that you might put in a parking lot over cars, things like mass timber. When we have a workforce that's competent and capable of installing those things, we as a design community have a much better chance of getting those things implemented. Something that I think it's great to be associated with projects that actually start to touch on all of the quadrants of the design and construction field. Something else that I think, Sean, you touched on earlier was the mock-up, the 3-story kind of mock-up training house in here. And something that we all got a chance to witness was the day or the week that the building opened was a national competition that was housed within the space. Dave and Sean, really, could you guys both maybe expand on the flexibility and the sort of operability of how this mock-up building gets installed and taken down?
The structural steel that is in there is mainly to hang our curtain wall. So we had to put up the structural steel, and we're having the curtain wall developed, and what we thought was going to be an easy, we'll just take it up, take it down, put it up, take it down. This one's probably going to stay exactly how it is. It was extremely time consuming to put it up, but it gives us the opportunity with 4 sides and some flexibility on the interior to have multiple exteriors installed on it. We can have a panel wall on one elevation, a curtain wall, window wall. It gives us so much flexibility on the other training. We tricked ourselves into thinking that this structure was going to go up and down, but I don't think that's the case after we put it up. Because like we said earlier, on the top, a Vala or a mini crane, it's structurally rated for that, and all of that grading, that is some unbelievably heavy grading and extra pieces to be able to do that. So with this application, our guys are going to be able to take the material off of the mezzanine, bring it down, so they learn to unload the material, bring it down, tilt it up, install it using a Vala, and just almost exact conditions in the field they have those. So there's 3 or 4 different training applications all in one process once it's all up and running. So it's really exciting for our apprentices.
Yeah, we call this kind of the laboratory of learning in the title, and the intention with that is to be as flexible as the lab is for multiple different uses. And so this is like a 100-year building. We don't know how it's going to be utilized, maybe 30, 40 years, generations down the road. So from a design point of view, we made sure that it was as flexible as possible. All the guardrails were removable. They kind of insert into these removable leave-outs at the second floor mezzanine. It's a composite deck. There's a 12-inch slab below the structure, and it covers most of the training ground as well. So Dave's team they decide to put a column 4 foot east of the leave out that's already built in. They can do that. And indeed, you see this guy kind of climbing up a training column here. They added a couple of climbing columns rather west of that structure. So during the competition, that they can do the kind of races to climb up the steel there. So this kind of long-term, highly flexible space was something from the onset we planned for and made sure that we were future-proofing the building as much as possible.
Something we talked a lot about during the design process is the pride that Local 63 takes in the work that they perform, and that the environment that they train in should be one that fills their apprentice and fills their members with that pride. Dave, you're a 3rd-generation ironworker. What would you say about facilities like this, and what do they start to say about the union's commitment to future generations?
The commitment is there. We built a building in Broadview that has 0 resale of ability. And it's a $10 million building that we can't even get appraised.
If there are developers in the room, ignore that, please.
So we've anchored ourselves in this community, on this block. This is our only avenue. That building is only worth anything to us. As a 3rd generation, my grandfather was an instructor. If Paul was here, he would tell you that he never touched a piece of curtain wall or a stair in school when he was an apprentice. They were just starting to really develop curriculum in apprenticeships. My grandfather was an instructor who went to the first instructor training in the International 43 years ago or 44 years ago. So our lineage here is every 20 or 30 years, we were able to build a new building. I was the first apprenticeship class in that building in 2003 that was built. And that's all I knew. I didn't even realize they had this area called the Pit. I never knew anything about the Pit. I knew of a very nice, brand new looking warehouse. And now if my kid fails out of high school or college, he'll be, one of the first classes at this one. So we're anchored here. This is what we've been doing for almost 125 years now.
Yeah, you just mentioned college, and I can't help but be reminded that colleges and universities have a long history of using their built environment to underscore whether it's pedigree, whether it's importance, whether it's pride, whether it's a sense of camaraderie or community. Architecture and the built world has always been kind of a natural extension of their brand. And I think what these guys have done here is really built something that is a natural extension of who they are, down from the aesthetic of the building to the functionality of the building. Beyond the training that happens here, I know you guys have hosted a handful of other events and fundraisers. Could you kind of talk about some of the other kind of events that you're opening your doors to be able to host in a space like this?
Yeah, we built a beautiful new building, and we really haven't trained anything in it yet. We've done three or four different events. We have another event coming up this weekend, but we are filling it with the school aspect of it. But yeah, we have the Trade Women Build Nations coming in this weekend. We're going to host all of the lady ironworkers that throughout the country that are going to be there. They're going to see how beautiful our place is. All the apprentice competition, that's what we had last year. The international apprentice competition was at our facility, and we got nothing but accolades from the envy from the other coordinators throughout the country. And we host every fairly if it's not quarterly, it's monthly meetings with the local politicians. We'll have stuff, maybe not at the House of Glass, but they're in our facility. We volunteer our space for anything. As a matter of fact, when we tore down the building for that we purchased, we had the Maywood and Broadview police able to go in there, and we knew we were tearing it down so they could do some of their training, and they beat up the building a little bit too before we tore it down. But they were happy to do it.
All right, great. Well, we have about 5 minutes left, and I know everybody's probably hungry. So with that, I don't know if we're set up for questions or not, but if there are any questions that we could field while we're here today, we'd love to take some questions from you guys. Is there anybody?
We thank you as a contractor, because none of our guys do any of this unless we have the contractors that put up their risk to install these buildings. So we can't do anything without the contractors. So thank you.
All right, well, with that, thank you guys very much. We really appreciate your time.
Otherwise, we will see you all after lunch. Welcome to the afternoon, everyone. If you could come in and grab your seats. I hope everyone had a delicious lunch. Hopefully you're not too full, and we will do our best to keep you awake. Right now, we are gonna roll the dice. See what I did there? And we are gonna welcome Basim Shamsuddin up here to tell us, from HKS, sorry, to tell us how things are proceeding with the Bally's here in Chicago along the river. So please welcome Baz to the stage.
Okay, thank you everyone. I know it doesn't sound like it, but I am now a Chicago native. I've been here for 10 years, and I am really excited to present this significant project in the city. Prior to joining HKS, I've worked at HDR and John Ronan Architects, and this has really been an incredible effort over the last year to develop this project and get it to the stage that we are now at. So today I'm going to be sharing the design approach for how a project can contribute to the city, and we'll be presenting this new casino, hotel, and entertainment venue on the riverfront, how it's been conceived for more than just a place for gaming. The project is located on the north branch of the Chicago River, on the former site of the Chicago Tribune printing press. The project is bound by the Chicago Avenue on the north, the Ohio Street ramp to the south, and it can be difficult to grasp the full scale of this project. But to give some context, the site is about 500,000 square feet, so it's nearly 3 city blocks. And it's currently under construction, with the core rising less than a mile away from where we are now. I'd like to give thanks to the incredible team that's worked on this project, the Bally's team, the HKS team, and the incredible list of consultants and partners that have made this possible. I'm going to walk you through some of the exterior design strategies, how some of the call it project constraints and requirements became a design opportunity, and in particular how we approach glass selection to balance performance, identity, and sustainability. So casinos, by their very nature, they often turn inward. They focus on controlling the environment inside, the gaming floor, the entertainment, the amenities, whilst giving little back to the city and the area around them. The mandate from the city and the owner was to turn that inside out. A casino in an urban environment like Chicago demanded something different. It's not Las Vegas or Macau. Chicago is a working city with a natural aversion to flash and ostentation. At the same time, the design and its function as a place for play within the city called for a building with a memorable and energetic exterior identity. A tribute to the site's former use. Let's see if we can get this. A tribute to the site's former use features at the northwest corner of the site, where the illuminated Chicago lettering from the old Tribune building forms an art piece behind a 100-foot-high structural glazed curtain wall. At the city level, the project creates a new stretch of Riverwalk. So this is our site. Goose Island to the north, loop down here, and we're right here. This adds a quarter of a mile of amenity space along the riverbank, and it invites future developments to the south to connect to the existing Riverwalk and can continue this thread on towards Goose Island to the north. At the site level, the project has two parks that anchor the north and south ends of this stretch of Riverwalk. Both parks provide accessible routes from the upper level down to Riverwalk, incorporating play equipment, a dog park, native plantings to encourage biodiversity, and a variety of seating built into the landscape, as well as amenity lawns. Trees within the parks provide shading, and a new water taxi stop is integrated toward the north end at what will be called Bally's Landing. Here's the view looking north from the Riverwalk. Program along the Riverwalk include a food hall, a sports bar, a venue, and a restaurant. So the project comprises roughly 2.5 million square feet, inclusive of parking, terraces, roof areas, with just under 1 million square feet counting against FAR. On the ground, the building footprint is about 300,000 square feet of the site's 500,000, but it extends further beneath, creating a new bridge and roadway. This move was critical, allowing us to locate the building servicing, employee parking, and major mechanical spaces and back-of-house spaces below grade, freeing up valuable street frontage. So everything that you can see here is all below grade, and then the building traverses, takes a change in level and hides all of that stuff below grade. I mean, the strategy is unfamiliar to Chicago, as you can see in Lower and Lower Wacker Drive, and this allowed us to achieve some of our core goals, creating an outward-looking, approachable destination that feels connected to the city. We located the 36-story hotel tower towards the south of the site to avoid placing deep foundations over city infrastructure at the north and to sit at the narrowest point of the site addressing the city. A tray green roof system covers the majority of the roof, improving stormwater runoff and providing another opportunity to improve biodiversity on site. You can see that the orientation of the tower follows the river, the path of the river, and in doing so, it sets up the tower in dialogue with the rest of the city. It will reflect light differently to the other towers in the loop, which are oriented on the city grid. Given the size of the project, it could easily feel imposing and might risk being a fortress. Our challenge was to break down that scale into approachable layers to give the building a rhythm, a sense of movement and relationship to the human scale. We also wanted to be judicious in how we use exterior materials. Each elevation of the building addresses different conditions: a freeway, a river, a street, and a park. The horizontal banding flows around the building, rising and falling, as different materials respond to different interior functions. A series of terraces, cantilevered bands, and projections animate the building. The horizontal banding flows, and two large terraces are associated with the hotel meeting and conference facilities. And another large terrace is associated with a restaurant adjacent to the casino floor, all located along the Riverwalk. This theme of layering and breaking down massing is continued at an architectural level. The idea of creating porous, inviting groundscape call for entry points with a sense of occasion. Here you can see some of the primary entrances along the west of the building. This one is into the hotel. Linear light picks out steps in the architectural soffits and the transition from grand gestures, the loggias, the overhang, the canopies and porte cocheres to a more human scale at the entry. The same language is continued at the casino entry, and a further variation of this theme is at the theatre entry. So the exterior material palette consists primarily of three materials: glass, architectural precast concrete, and metal panels. This provides complementary change in texture, reflectivity, color, and mass. This copper rose gold, this metal here, this is a relatively new three-coat system from Sherwin-Williams. It's a 70% PVDF finish. The third coat includes a gold fleck that lends warmth and catches the light. In terms of the precast on the building, we tested a number of different mixes, looking at this with glass and the metal. The mixes are predominantly white blend with fine gray and coarse amber aggregate. An acid wash helps to expose the aggregate and as well as conceal imperfections. The vertical striping here is intended as an abstract nod, an evocation of Chicago's skyline, while appearing playful and adding visual interest that can be read from distance. We found formliners at this scale tended to recede visually at a distance. So we explored options for a custom design and developed a system of patterning and panelization here that would limit the number of forms. The base thickness of concrete that we're using here is 9 inches deep, and then we have this series of bump outs and reveals, each 4 inches out and 4 inches in. And at occasions, we combine those and kind of smush them together to give an additional layer of depth that really kind of helps to exaggerate these ins and outs as you see it from along the Riverwalk. A linear wash is going to illuminate the face of the precast. Let me go back to the previous one. So we will have a linear wash that's uplighting on the face of the precast, as well as at select moments, including a spotlight at the reveals that's going to light up that pattern and also catch the top of that reveal. We also took advantage of horizontal breaks in the massing, as sectionals ins and outs to provide ventilation to the garage. So here is the section, this is the bottom of the precast. We have an ornamental soffit here, and this allows one of these bands to provide fresh air into 2 levels of parking, both into this level as well as through a cut through in the floor to the level above. So this reduces the reliance on mechanical ventilation while maintaining the appearance of a fully skinned garage, limiting light and sound spill into the surrounding areas. The copper rose gold metal extends to the design of the curtain wall. These 10-inch deep vertical fins on the outside of the curtain wall along the Riverwalk help to mitigate unwanted heat gain. Amongst the sustainable features integrated into the design, including green roofs and passive ventilation strategies, I'd like to talk a little bit more about bird-friendly glass. Designing buildings that are more considerate to fauna has become part of a designer's responsibility. As an industry, this area continues to see innovation through development of new materials and application of pre-existing technology suited for this purpose. Efforts to reduce bird death from collision with buildings is undergoing ongoing attempts to legislate at both the state and city level. While updated policy is not yet is into effect, bird advocates claim that not enough is being done. So currently, the Chicago Sustainability Policy calls for a kind of an a la carte menu of different approaches to mitigating bird strikes. With this project, part of the host community agreement between the city and Bally's required bird protection provisions as detailed within the city's sustainable development policy. Well, that's great. So what does that involve? So basic protection calls for protecting all high-risk facade areas. So that includes everything from grade up to 75 foot, as well as high-risk features. So we heard about this earlier, but fly-through conditions, such as the radial corners of this tower, the glass railings, windbreaks, sky bridges, and awnings and overhangs. Enhanced protection calls for medium risk areas, which is everywhere at 75 foot and above. So combining both everything from 75 foot down and 75 foot and upwards. So that's basically everything on the building. All glass on the building was required, and this was kind of a prerequisite that was written into the agreement that the cities had with the owner. Looking at how this kind of integrates into our design, we have one moment where the layering of the precast bands at the podium fragments and gives way to a sheer curtain wall, which at one point rises continuously from Riverwalk all the way to the top of the parapet, about 450 feet above. So finding a way to meet this criteria required an approach that could stretch uniformly for the full height of the tower, creating a cohesive and crystalline tower, an object, if you will, as first envisaged. So what are the American Bird Conservancy prescriptive requirements? While custom materials can be evaluated by the American Bird Conservancy for material threat factor, the time constraints meant we needed to follow the prescriptive criteria. And for some context, we started designing this in July 2024, and we were bidding the curtain wall about 4 months later. So the option of trying to develop new and custom materials wasn't really an option. We had to look to the prescriptive criteria. There are two approaches. The first one is utilizing an opaque marker on the first surface, the outer surface of the IGU, with a prescribed pattern spacing. In this scenario, there's no limit on exterior reflectance. So surface one patterns only, no limit on VLR. The other approach is doing the same on surface 2. However, in this scenario, the exterior reflectance needs to be below 15% for the whole unit. As you can see from this, this middle image from the American Bird Conservancy, putting the frit on the second level as the panel turns and gets more oblique, the effect of that frit becomes less and less noticeable. You can't see it, the first surface takes over. We also looked at UV coatings as another option. However, these can distort optics, create a pearlescent look, and often required an outward laminated light, where the interlayer acts to dissipate reflected light. The prescriptive criteria also allow for different pattern spacings, which provide different threat factors. So the denser the coverage, the lower the threat. One being a fully solid material, an opaque material, and 100 being air. So, for example, a threat factor of 20 requires vertical lines spaced 1/8 inch wide, spaced no less than 2 inches apart. Whereas a threat factor of 25 requires vertical lines 1/8 inch wide, spaced no further than 4 inches apart. The hotel tower floor plate is it's a single loaded corridor locating the elevator core, stairs, and ancillary spaces along the west face. The overall dimensions of 70 foot by 250 foot give an elegant silhouette when viewed from the west and from the city, and provides a broad canvas facing north. The top of the tower is carved out and recessed, where a restaurant will provide views across the river and then across the river north and the loop, and then the themes of layering, and step soffits is reintroduced, as well as the rose gold metal and the fins. The approach to lighting here being similar to at the main entries, about emphasizing architectural moves and surfaces. The idea of introducing a solid material in lieu of a unified skin felt clunky and at odds with the concept. So using insulated shadow panels was an efficient way to keep the skin aesthetically unified and under one subcontractor scope. When considering the prescriptive criteria, it was clear that a surface 2 frit requiring a reflectance of below 15% would allow the solid elements to read through at odds with the intent of a uniform appearance. This led to the development of four criteria for selecting the glass, in addition to the thermal and environmental performance. The first was the vision to spandrel blend, high reflectivity, the color, which is a significant component of the whole project, and these prescriptive bird-friendly measures. So not all glazing manufacturers have the ability to manufacture a surface 1 frit or etch, but this is rapidly developing with many manufacturers joining the ability to do this. And I think this is going to become more prevalent as the requirements for bird-friendly designs become mandatory. At the time of bidding the project, AGC Interpaint had the capacity and ability to manufacture a surface number 1 frit. We looked at both laser etching and ceramic frit from the inside, the effect from the outside, and determined that a surface 1 ceramic paint provided the best balance of performance and aesthetic. So this is looking at kind of the different patterns that were available as standard prescriptive requirements, both from the inside and outside. And then we also looked at performance and color. So based on review and looking at other towers with our shortlisted classes, we were kind of determining that an exterior reflectance of over 30% was the minimum that was needed to provide a uniform appearance during the day. We also preferred a more neutral silver or color over a hue of green, blue, or bronze, or anything overly saturated to avoid clashing with the precast and the rose gold. We considered glass up to 60% reflectivity and ultimately chose the Ipersol Platin 4729 over 3526 due to a slightly better U value and solar heat gain coefficient. This also allowed us to use a single 1-inch IGU as a slightly thicker outboard light without adding any additional cost to the project. We also considered how the different frits impacted performance. So although these differences are not dramatic, the reduced solar heat gain and improved shading coefficients further reduces cooling loads. Taking into account the size of the building, even these small improvements are meaningful. Another component of this is that the project is targeting LEED Gold. So we're aiming to achieve an innovation credit from LEED through a full evaluation of the building skin and lighting. So what that involves is there's a calculator that's provided by LEED where you have to kind of input all of your exterior materials. It gets assigned each material is assigned a threat factor, and then obviously we have these prescriptive threat factors that we've used on our different classes. We have to put in the proportions of those and ultimately arrive at it's a weighted calculation where you have to arrive at a bird collision rating of 15 or less. So on this project for the whole building, we're down to 12, which is from the analysis shows to be a friendly building for birds. And then kind of folding back that the idea of kind of the language and creating an identity and something that's meaningful to the city. We kind of decided that the goal was not to minimize the appearance of the frit and kind of ignore that it's there and make it completely go away, but to celebrate it, use it as a way of layering further interest and providing a unique identity to what's really quite a large expanse of glazing. Arranging multiple frits in a mosaic revisits the vertical striping of the precast in a subtle way. The frit will mostly disappear at night to humans, but will dance and shift throughout the day and under different lighting conditions and viewing angles. So the convergence of functional, aesthetic, and architectural concerns is in full display in this way, and we hope will serve as a marker to this unique destination in Chicago. Thank you very much.
Thank you, Baz, for updating us on a very special spot that's in the city, and we look forward to it being resolved and given back to the city as an amenity. So that's very exciting to hear. Also, was appreciative of how they're showcasing the frit and how it can also be a kind of educational tool potentially in the future. So thank you for that. We are now going to transition it to talking about a necessary component of all of our facade systems in balancing out the air. So I would now like to welcome to the stage Colleen Stuber-Zukanovich and Lincoln Taylor, who are both from SGH.
All right, thanks everyone. I'm Colleen Stuber-Zukanovich. I am an architect and a project director at Simpson, Gumpertz & Hager.
And I'm Lincoln Taylor. I'm a senior consulting engineer at SGH.
So Simpson, Gumpertz & Hager is kind of a mouthful, so we go by SGH for short. We're an engineering consulting firm, and Lincoln and I both work in the building technology group, which means we specialize in the building enclosure. We work on a lot of new construction as a consultant or a commissioning agent, so that's looking at the architect's drawings, reviewing the installation and enclosure testing. We also do a lot of existing building investigations, so we're who owners call when an issue happens in the future after occupancy. So that gives us a pretty unique perspective on what happens to building systems and materials over time. So today we're going to talk about how to achieve air tightness, especially with building codes moving towards whole building air testing. So how do you proactively prepare your project in design, in construction, and then in testing and verification to make sure you're able to pass that whole building air test? We're going to talk about air barrier importance, some of those building code requirements, design considerations, and how to detail some tricky conditions with a continuous air barrier, pre-construction and QA/QC in construction, and how to verify whether that design and construction is actually successful. And then we're going to look at a case study on a successful whole building air test at a middle school in Massachusetts.
All right, I'm going to kick things off talking about why air barriers are important, why we care about them. So fundamentally, air is going to be moving from areas of high pressure to low pressure. So in buildings, we have this pressure difference between the interior and exterior. That's why the continuous air barrier is important. But what happens if your air barrier isn't continuous? You have this gap, air leakage occurs. That results in energy loss, higher space conditioning loads while the mechanical system's trying to compensate for that air leakage. When that air leaks, it's not just alone, it's also carrying water vapor. That can cause condensation in wall cavities. That leads to damage to finishes in your structure or mold and mildew. The air leakage can also cause localized drafts. It's not comfortable for the occupants. It's difficult for the mechanical system to maintain set points, and you're allowing in environmental pollutants.
So as we're moving towards the most amount of insulation that we can feasibly install into buildings, building codes are starting to recognize that air tightness in buildings is really important for energy efficiency, for occupant comfort, and for long-term maintenance of buildings. So the IECC 2024 is starting to recognize that air barrier documentation is really important. So they're pushing for designers to start identifying the air barrier in their drawings and details. All components and transitions and joints have to be identified, typically with a different color or a different line weight or line style. Whole building air testing is becoming something that will be required, as well as design and construction verification plans. So that's looking at the design documents, doing construction site visits, and final commissioning inspection report. So the whole building air test is a test that can be kind of scary for owners and especially for contractors. This happens at the end of construction, so the entire building or portions of the building are pressurized or depressurized to track what the air leakage rate is, but this happens at the end of construction. So what happens if you have all the cladding installed and your entire parapet wall leaks all the way around the building? So this is where being proactive in the design and construction phases can be really helpful with passing that test. So a successful air barrier system depends on three things, like I mentioned, and we're going to cover these in the rest of this presentation. So in the design phase, like I mentioned, you should be showing that air barrier in a different line color, like the image on the left. You want to be looking at all of the details, making sure that everything is continuous. In construction, you then want to be taking that design and making it constructible. So talking about how to make that air barrier continuous, what materials you're going to be using, looking at the actual installation of that, testing the installation, and verifying that that design and construction is successful. So some air barrier design considerations. You're going to hear us say this multiple times, but the most important thing for the air barrier is continuity. That is required by code, and it's required for an energy efficient building. Looking at systems and material selection, there are so many different products out there, and those products keep changing formulations every couple of years.
So making sure you understand how those systems can work together or not work together. In detailing, you want to have integrated details that show the transitions. You want to show the typical details as well as the difficult details, and sometimes that means showing them in 3 dimensions so that you can actually understand if that is constructible and work through those things. In your specifications, this is where you want to be listing out all of the testing So what testing is required at what point during construction, how many tests, and then considering what happens if those tests fail. In the specifications, this is where you can also call out for that the air barrier sub to be submitting shop drawings that actually show what products they're going to be using at difficult detailed transitions. And this is where you also want to be including some of those code requirements. So some requirements for material selection with air barriers. There are multiple different types of air barrier systems. So a peel and stick type of air barrier, a building wrap type, spray fluid applied or roll down fluid applied, or utilizing some of the newer products that are coming out where there is a factory applied air barrier already on the sheathing. Again, the most important part is that it's continuous. The air barrier system also needs to have some sort of substrate for stiffness and strength. So air barrier membranes can really only span a gap of about 1/4 inch or 1/2 inch. So you need to understand what happens at those joints and transitions, what materials and products should be used. And then in addition to having stiffness, it also sometimes needs to have flexibility. So if you have a penetration through your exterior wall that may move differently from the exterior wall, understanding what that movement is, do you need a control joint, expansion joint? How should that be treated differently from other penetrations? The durability is also important. So thinking about the service life of the building, you also want that air barrier, weather barrier system to meet that same service life. And of course, it needs to be impermeable to air leakage. So a little bit of a warning. I know there's a lot of new products out there that are combining sheathing and insulation with your air barrier and your vapor barrier. These products can be great because it can make construction go faster. It can cut down on installation costs. But be aware that they can be very installer dependent. When you have the systems where the air barrier is factory applied and then you're treating the joints and detailing it on site, at every joint you're going to end up with a reverse lap that can be susceptible for air and water to be getting in. So just like a 2-in-1 shampoo and conditioner combo, you might have a product that can do both things, but it may not be doing both things as well as two separate ones. So just be aware that you understand your project requirements and the specific performance requirements that you need from those products.
All right, next I'm going to talk about a couple of the most common areas where we see air leakage in buildings, starting with fenestration transitions. So first and foremost, the key to this is integrating your fenestration with your air barrier. That seems straightforward, but the catch is you really need to understand your line of air tightness for your fenestration system. In the detail on the left, we have a curtain wall to two perimeter sealant joints. Seems pretty normal. The issue here is the curtain wall mullions are only sealed at intersections along that hatch line I've highlighted. So in the detail on the left, the risk is air from that cavity infiltrating, inboard of that seal in the mullion and reaching the interior. To fix this, we just need to be careful. Add a sealant joint between that area and within the line of air and water tightness of the curtain wall system. Another option with curtain walls is adding a silicone sheet into the glazing pocket. It's that pink line on the right. This essentially gives you an extra redundant layer of protection against air and water. So another common area of air leakage is roofing transitions. The diagram on the left shows, all these different pathways for air to leave through the parapet, through the decking, the roofing assembly, structural connections. The key to roofing transitions is integrating your roof vapor retarder, if you have one, or your roofing membrane with the air barrier, or better yet, create a redundant detail where both of those integrate with your air barrier. That's shown on the detail on the right. And another key to this is using compatible materials. Colleen will touch on this a little bit more later, but in short, roofing membranes don't get along with air barriers often, so confirm compatibility or introduce transition materials. So shifting to QA/QC during construction, Designing an air barrier system on paper is one thing, but actually implementing that in the field requires a structured process. And we're going to focus on coordination and planning. That's pre-install meetings, submittals and shop drawings, things that are happening before any air barrier actually goes on the building. And then field verification, which will get into mock-ups and field testing to actually verify things are being installed as they should and they're performing. So first is pre-installation meetings. This is a great chance for the designer, consultant if you have one, all the relevant contractors, preferably the manufacturers, to sit in one room, really hash things out. This is coordinating details, ensuring we have that continuity between systems, making sure materials within the system are compatible and the materials that are tying into are compatible as well. Also a chance for the contractors to ask about sequencing, who goes first? Does someone have to come back to tie in this detail? And along with that, UV exposure. Air barriers will start to break down after a certain amount of time. It depends on the product, but the project team should have a plan in place to get that air barrier covered up by cladding within that limit. The team should also discuss warranties if they're meeting the manufacturer's requirements and the QA/QC procedure throughout install. Moving on to submittals and shop drawings, this is also the chance for the team to align on exactly how the details are going to be installed and the products that are going to be used. Typically for air barrier shop drawings, I see standard details. Maybe if you're lucky, you have an outline around the building where the air barrier is going to be installed. We definitely recommend specifying to show individual products and shop drawings, like on the detail on the left, kind of a legend. Modern air barrier is going to have a lot of different products, so details like this will really help you understand what's getting installed. Another key is to coordinate with other systems. The detail on the right is the shop drawing version of that roof detail I showed, just carefully showing how they're integrating with the air barrier. Mock-ups are also a great way to figure out how things are actually going to come together on the site. You can then have off-site mock-up standalone on site, first in place installation on the building, or virtual, which are kind of like 3D step-by-step instructions. If the project team has air tightness goals, it's really important to test that performance throughout installation. One good test to perform at the beginning of a project is ASTM E1186. One of those methods I'm just going to call the bubble gun test. Essentially, you're applying liquid solution onto penetrations or seams in your air barrier, applying that plastic dome. It depressurizes, essentially trying to pull air through it. So if you have air leakage, it's going to cause a continuous stream of bubbles. You can see that on the photo on the left. Adhesion testing is also very important for air barrier materials and sealants. It's important to just perform these regularly throughout construction. Fenestration air testing is also great. Not only can you measure the air leakage through the window product itself, but you can actually include that perimeter condition and make sure that transition is detailed airtight. Finally, we have air leakage testing, blower door testing. That's going to use blower doors to positively and negatively pressurize your building. That gives you a number. That's your quantifiable air leakage. You have to use diagnostic testing to actually figure out where that's coming from. The examples we have are using IR images and theatrical fog to actually trace where that leakage is coming from. I'm going to talk about some common pitfalls, lack of coordination. The detail on the left is a shop drawing detail. We're not sure where the air barrier is going to go. And then once installed, you can see there was really no integration. The detail on the left shows where that air barrier actually ended up. We didn't have integration between the air and roof, so unfortunately just this gap in our air barrier. Another common pitfall is just lack of coordination and constructability. These were some steel framing members for a precast brick soffit. Just a lot of conditions where connections or members are happening right along the air barrier plane. The top left photo, you have that just long, narrow joint. It's very difficult to seal. Just a lot of on-site challenges.
So another common pitfall is material compatibility. So when we talk about compatibility, that can mean like the picture on the top left, where the two materials may not actually stick together. So this was an investigation project that we did where we knew we were getting a lot of water into the exterior wall system. When we opened it up, we saw that the flashing tape above the through wall flashing didn't stick at all to the air barrier system, and that's because there were two different manufacturers. So that's where we were getting all of the water coming in. We also look at chemical compatibility, so that, like the picture on the bottom left, are those materials actually going to degrade each other over time? The chart on the right shows the chemical compatibility between air barrier and weather barrier systems across the top, and then different flashing materials on the left. So, this isn't something that you can see, and I know it's something that maybe the owner or the architect don't want to spend a lot of money on, but it is really important, like I said earlier, to match the service life of your weather and air barrier system with the service life of the building. So while some systems are designed to be replaced, like the roofing system, you don't ever want to be in a position where you have to replace your air barrier system. It's very expensive. It's very difficult. So you want to consider materials that are going to last a long time. For instance, any of the metal flashing materials you see here are compatible with everything. So stainless steel and copper. Those are great materials to use as a transition between two materials. Like Lincoln said, a lot of times roof membranes and air barrier membranes are not going to be compatible. So installing some sort of stainless steel transition in between can be really useful. And then some of the other materials you see on this chart are kind of hit or miss. In this case is where we recommend to get a letter from the manufacturer that you can have these two products actually touching each other, because nobody knows products better than the manufacturers. Another common pitfall is not following the manufacturer's installation instructions. There are so many different products out there now. The installer may think that they know how to install a liquid applied air barrier system. However, different manufacturers are going to have different requirements for temperature or humidity, as well as substrate conditions. So you want to make sure it's dry and clean. You also want to make sure that you don't need a primer for whatever material you're putting it on. Even the substrate itself needs to have the appropriate air barrier material installed. So the picture on the bottom left is an OSB sheathing. OSB is very porous and the surface is very rough. This was a very thinly underapplied air barrier system. Water was able to get in and that air barrier system just flaked right off. You also need to be looking out for over application. So like these other photos where it's so overly applied that it's actually slumping off the building. They need to be using the appropriate tools. And like Lincoln mentioned, looking at every manufacturer's requirements for how long it can be exposed to UV rays.
All right, I'm going to wrap things up with a case study. As Colleen mentioned, this was Concord Middle School. This was a new middle school that opened in Concord, Massachusetts, near Boston earlier this year. The owner and designer had an emphasis on sustainability, so they had this goal of achieving an airtight building. We were the building enclosure commissioning provider on the product, so that means we were a third-party independent quality control reviewer for the owner throughout design and construction. So we reviewed the design and submittals like we talked about. We also developed the enclosure testing. That way we had a good plan of how to verify performance throughout construction before construction actually started. We had a mock-up on site, this mock-up cube with 4 walls and a roof. We performed air leakage testing, the bubble gun test on the cladding like we talked about, and we also did fenestration air testing. One cool thing about this is we were actually able to pressurize the entire mock-up, essentially do a little mini whole building qualitative test. So we were able to test things like the roof transition. The photos on the right, some of these tricky sunshade details going into the windows. During construction, we were making regular site visits as the enclosure commissioner. The project also utilized the Air Barrier Association of America Quality Assurance Program, which involves using approved products and installers. And then a third party was also providing testing throughout construction. Finally, at the end of the building, we performed quantitative and qualitative whole building air tightness testing. So the photos on the right, you can see there was some air leakage at that parapet at that tricky roof to wall condition. Also, another example is a column where you have multiple planes meeting all at one point. It's just very difficult to detail those. This is a diagram showing kind of the current goals and current code requirements for whole building air tightness testing. The unit here is CFM per square foot, which is cubic feet, which gives you the volume of air leakage in cubic feet per minute per square foot of enclosure area. You can see the more stringent, it's around 0.1 to 0.2 CFM per square foot, and the more lax, less stringent, around 0.3 to 0.4. Concord Middle School, we ended up at 0.114 CFM per square foot. So the project team was happy. We think usually following the structured process, really helped us have an airtight building. I don't think we have time for questions, but if you see us floating around on the floor, feel free to ask us.
I'd like to thank Colleen and Lincoln for that very, very in-depth presentation. Thank you so much. I would now like to welcome Delana Bura. There she is. She's ready to go. And she is from Curari. And she will be telling us more about inner layers for laminating glass. How are you guys doing today? Good? All right, there we go. Well, as she mentioned, I'm Delana Bure. I'm with Curari. If you're unfamiliar with Curari, you may be familiar with a few brands that you see throughout the presentation, Trosaful or Centriglass. I am trying my best not to bore you guys with formulas and data, but I do want to take a deep dive into how choosing the appropriate inner layer can impact the results of your projects. So this is anywhere from safety, decorative, acoustical projects, structural needs, and just, of course, specialized applications. I'm going to touch on inner layers, but first I want to talk about glass. It's a great product. It's clear. It's beautiful, but it does have limitations. One of the main limitations is it breaks. So it also does not, it transmits sound and it just doesn't provide much protection. The most popular inner layers that you're probably familiar with would be PVB and ionoplast. PVB is the most commonly known inner layer because it's been around for hundreds of years. It's used in a variety of applications, such as the windshield of your car. It's extremely flexible. It helps to reduce sound, which we'll touch on later. And you can just be very flexible with it as far as your design opportunities are for color, or just basic safety glazing because it meets the requirements. However, PVB is great and it's flexible, but if you need something stronger or stiffer, ionoplast is the perfect inner layer for that. So ionoplast was invented in the 1990s with hurricane resistance in mind, as well as security glazing. It's 100 times stiffer and 5 times more tear resistant than PVB. And it's used in quite a lot of structural and security applications. So if PVB is your flexible workhorse, think of ionoplast as your heavyweight fighter. Now we're going to look at how these applications are applied exterior and interior wise. For exterior, if you have, natural UV or UV protect, any structural needs or just some decorative, that's where you'll see Centriglass used or specialized PVBs. However, for interior use, you have a little bit more flexibility to play with colors, privacy films, and of course, acoustical needs. That's where it's best used. Now we're going to look at ionoplast and PVB used in this application. You notice I mentioned it was flexible. So for PVB, upon impact, it folds over almost immediately, but the glass stays adhered. For Centriglass, it's stiff, so although the glass does break, it stays in place. So this is where ionoplast really shines. I would say for any railings or balconies or exposed edges, ionoplast is the inner layer to use, and you can see why. Here are a few examples here. Had to add some funny faces for privacy. But you see on the left-hand side, the left-hand side, the glass is broken, but it stays in place. So people are more protected below on ground. On the right-hand side, there are very few, support points, but the glass is still in place and the people are protected. So keep that in mind when you are specifying inner layers for projects where edges are going to be exposed or balconies or railings. Uh-oh. Let's talk clarity and optics. So for Century Glass and Trustful Ultra Clear PVB, both have a very low yellowness index, which is really, really good for, storefront applications or anywhere where the owner is looking for a lot of clarity. They want people to see what they have in the store. And so a good example of that would be the Louis Vuitton store here in Chicago. This is where Ultra Clear really shines. I don't know about you guys, but it definitely makes me want to go in and buy some stuff. Okay, we're tricking. Another one will be an observation deck. So I know this is probably not viewed a lot in airports, but when you're in an airport or even sporting events, the observation deck is something that's very important to owners. They want to make sure their customers can see out or in. So for observation decks, this is a good example of using either Trustful PVB Ultra Clear or Century Glass, depending on the structural needs. Now, I mentioned earlier that PVB is great for acoustics. Reason being, it's a soft inner layer. So the softer the inner layer, the better the dampening properties are. I'm going to show you guys a brief video of the Hoxton Hotel, which is near the train here in Chicago. Window open. You can hear how loud the train is. This is with the window closed. So this is the acoustic PVB performing at its best. So when you're designing for projects that are in high volume areas, such as downtown areas, acoustics really comes into play here. Also, I'm not sure if you guys have noticed, but if you have any newer cars, the cars have gotten quieter. I think they're using acoustic PVB in the windows as well, not just in the front windshield. Staying on PVB, you have a lot of flexibility with colors. Now, this could go anywhere from, branding, which is where you see it most, or just privacy films, or just being creative. A good example of that would be a project in Seattle, a headquarters that we're all somewhat familiar with. Now, in this project, there was PVB included to create the illusion of the white as well as the orange, aligning with the branding of the company. So with PVB, that's one of the biggest draws, is the flexibility to play with colors and branding and design. Now we're going to shift gears. I know design and pretty colors is fun. We're going to shift gears to life-threatening applications. Unfortunately, it is a trend where, school shootings are happening quite frequently. So I want to touch on safety glazing versus enhanced forced entry. I'm going to start with a video, if it'll let me go to it. So to briefly touch on the videos that you just saw on the left-hand side, that was with PVB. And the person that was testing the inner layer it was pre-weakened with shots from a handgun and then a set of tools, a person hitting it. They penetrated the glass pretty quickly. On the other side, that's a pretty lengthy video. Why? Because they used Century Glass. So there was a set of tools used. It was shot 5 times as well. And the person that was performing the test, they used bricks, their foot, a mallet, and so forth. Now, that's not really a repeatable test because my strength, his strength, and your strength is all going to differ. And if we're being honest, a lot of the times we're seeing enhanced forced entry being applied to people using guns as a way to enter into a building and cause more harm. So a few years ago, the ASTM F3561 standard was passed. And I like this test a lot better. It's more of a repeatable test. So the glass was pre-weakened with 10 shots from an AR-15. And then they used that metal log. It's 100 pounds. It was dropped from 1/2 foot up to 4 feet, twice at each level. And this yielded really, really, really good results. But as you see in this top picture, it's just a piece of glass with a thick inner layer. A system test would perform even better. So if you are working on a project and you have an owner that has security or safety as top of mind, I know you can't necessarily, or not always, especially with schools, are you going to say, hey, you need to use this? But I would encourage you to lean on the ASTM F3561 standard and try to determine what level of safety they're looking for. The results from this test had eight results, and I believe it used even our thickest inner layer, got you to a level 8 of safety, which is more than what most people get for bullet resistance, which is level 3. So please keep that in mind. Beyond forced entry, there's also hurricane resistance. So we're going to shift to missile impact. So laminated glass in some areas like Florida, laminated glass is required for a lot of their buildings, but the biggest determination is how close it is to the water and where in the building are they using certain inner layers based on windborne debris, okay? So I like to suggest that any architects working on projects that are in hurricane areas lean heavily on the hurricane standards as far as specifying for laminated glass, because it will differ depending on how close the building or the project is to the water. I don't think this clicker is a fan of me. Now, for tornado impact testing, it's even more strenuous. So the 130 mile per hour design requirement and 250 mile design requirement, they don't differ much as they both require a 15-pound 2x4 impactor, but the impact speed does differ by 20 miles per hour. So when you're building with tornado impact in mind, and mind you, this is all going to be Sentry glass because these are very severe, weathering, and you want the strongest and stiffest inner layer to protect the people inside, but of course, just protect the building in general. Behavioral health facilities. I've been seeing this as more of a hot topic. Behavioral health facilities, they also require safety glazing or security glazing because the goal is to protect not only the people on the outside, but the people on the inside. So a lot of the times beyond just Sentry glass or ionoplast, you'll see a CPET being applied because for CPET, if someone on the inside tries to hit the glass or break the glass, it will stay intact and you won't see as many large shards, so where they can use it as a weapon. So behavioral health facilities, that is one where you have to definitely take special care because the testing does require for no holes to be produced after the impact. And this is a way that inner layers affect, people socially. Here are the design requirements for behavioral health facilities. So it requires a 2,000 foot-pound impact, 200-pound dropped from 10 feet. And that's a configuration example that I provided below. But as I mentioned, the past criteria is no holes and no sharp edges present on the interior to protect the patients on the inside as well as the staff that are working with the patients. Now, Solution Finder. I wanted to add this tool in there because I get a lot of questions on how to apply a specific inner layer based on the project. This is a tool that we have on our website, trosaful.com. It asks you those questions that I asked you to consider. What are the performance needs? Where is it located? And what's the goal of the project? It asks those questions in 5 quick questions, and it'll help you by providing the inner layer of choice. But of course, if you have any additional questions or you want a more nuanced answer, my information can be found at the Carrari table, as well as my colleague, Alberto. Feel free to email me. I help you guys out any way that I can, because I know inner layers can sometimes get complicated depending on what the owner may be looking for. All right. I appreciate your time. Thank you, Delana, for that non-nuanced presentation on a very nuanced product. It's very informative. We are going to stick with what feels like a really good chemistry class for this next session. And we are going to now invite Skyler from Dow. Do I see Skyler here? He should be. Maybe he's getting mic'd up. Oh, I think he ready now. Here he is. Okay. Yes, never. So Skyler is here from Dow. He's going to be, I'm actually eager to look at this one. Showing us how they're working on a commonly used product for all of us and making it more carbon neutral.
Absolutely. Thank you very much. As you just said, I'm Skyler Will from Dow, looking at designing with more freedom by engineering for less impact and doing this through carbon neutral. And carbon neutral means that through a transparent process of calculating emissions, reducing those emissions, offsetting the residual emissions, you get to a net carbon emission that equals zero. And so a sustainable building, by its design, construction, and operation, must reduce or eliminate those negative effects overall and may even generate a net positive impact for the climate and the environment. Preserving resources, improving the quality of life for the occupants of the building. And to say that a building is sustainable is easy. It's even, seductive to some people, but what exactly, makes that building sustainable in construction? The world's going to need about 45% more energy as that world's population grows. So does that energy demand. Every new shirt made, every cell phone that's produced, every house that's built results in that tangible energy that's spent. And obtaining more energy means burning more fossil fuels, which means releasing more CO2 and other greenhouse gases. And so the built environment, that's responsible for 39% of that global CO2 emissions, 28% from the operational CO2. And so that's the carbon spent heating, cooling, lighting, maintaining that building. The 11% from embodied carbon or embodied CO2, and that's the carbon from manufacturing, transportation, the construction materials and their installation, and the building's eventual demolition as well. And I don't think this is any surprise, but climate change is or has been a rapidly escalating, we call it an emergency, call it what you will. And we have a lot of hard work to do in order to mitigate its effects. For building professionals, that's typically meant increasing energy efficiency, pushing renewable energy production, reducing that amount of carbon generated by the fossil fuels we burn in order to operate our buildings. But as crucial as that is, we know it's not enough. And we also need to think about the greenhouse gases that are emitted to construct our buildings in the first place, that embodied carbon, that 11% of the total greenhouse gas emissions. And that 11% might sound small compared to the impact of operational energy, but for new construction, embodied carbon honestly matters just as much as energy efficiency and renewables. And that's because the emissions we produce between now and 2050 really will determine whether we address those goals, the 2015 Climate Accord, and help prevent the worst case effects of climate change. And unlike the operational carbon emissions, which can be reduced over time, with building energy upgrades, the use of renewable energy, embodied carbon emissions are locked in place as soon as the building is built. It's critical that we get a handle on embodied carbon now if we hope to achieve those zero emissions by 2040. And that will require adopting the principles of reuse, including renovating existing buildings using recycled materials, and designing for deconstruction as well as reducing, including material optimization, the specifications for low to zero carbon materials, and of course sequestering, which is the design of carbon sequestering sites and the use of carbon sequestering materials. So the biggest contribution for silicones resides in the raw material extraction and processing, transport to the facility, and the actual manufacturing process. And thanks to the back integration in Dow's and production process, we produce silicon metal with low carbon raw materials and renewable non-fossil fuel energy at two of our production and two of our production rainforest locations. Raw materials are sourced and produced locally. The Dow uses quartz mines, waste from the wood industry, as well as Dow's own eucalyptus plantation. And so this energy-intensive process is supplied with 100% hydroelectric power, and this allows the manufacture of silicone feedstocks with less embodied carbon needing to be offset to reach carbon neutrality. And offsetting, I think I've said this a couple of times, what exactly is offsetting? For most people, you would think about tree planting is often the first thing that comes to mind. In fact, there are two very, very distinct categories of offsetting. So there's the carbon avoidance projects, which leads to a reduction in carbon emitted to the atmosphere, for example, through funding of those low carbon fuels or renewable energies. And there are the carbon removal projects leading to the direct removal of carbon from the atmosphere, most commonly through nature-based options such as sequestering trees. There is also kind of an emerging direct air capture technology, and the distinction between these types of offsetting can be easily missed, but it's one more of the fundamentals in the global debate around decarbonization. So there are legislative proposals on substantiating green claims that aims to fight at reducing the greenwashing or companies just giving a false or misleading impression that they're of what they have on their environmental impact of their products. And these kind of legislative proposals should help society, commercial buyers, investors make more sustainable decisions and increase the consumer confidence in green labels and information. Currently, there's more than 200, I'm sure this number has actually risen, more than 200 labels, green labels that are active in the EU, more than 450 worldwide. But really how accredited is each one of those? And it's could be very tough for a consumer or anyone to know right offhand. And for Dow, it really starts with our life cycle analysis, LCA, which are externally audited following the past 2060 PAS 2060 standard published by BSI in 2010, offers guidance on how to offset greenhouse gas emissions and to produce a carbon reduction plan. It is the only internationally recognized certification for organizational carbon neutrality. Verified, credible carbon neutrality claims help increase the market confidence and trust. Annual audits contribute to continuous progress of the journey of reducing and offsetting emissions. And then a key difference is that offsetting using certified credits emphasizes and requires the support of climate finance projects with the aim of adding social and environmental value. That PAS 2060 standard includes an ambitious commitment to climate action, as they so nicely put it, and is intrinsically linked to the efforts of a company's environmental, social, and governance values, which are critical components of carbon reduction journey. Certification systems offer the possibility to measure and compare the sustainability performance of buildings by applying a set of quantifiable criteria. Before certification systems were developed, it was near impossible to compare sustainability performance from one building to another. And then increasingly, certifications are used to help ensure a high level of quality during design construction phases while strengthening that sustainability agenda. And as a result, more and more certification systems are emerging, and they do differ vastly in their focus and application. The focus of our carbon neutral services is on offering those LCAs for our materials to show the positive environmental impact of carbon neutrality. We are following the ISO 14040 as well as ISO 14044. The LCAs are prepared by product categories using the highest common denominator on carbon emissions for similar formulations applied to all regional products. Dow's carbon neutrality service are available for specific projects involving structural glazing, insulated glazing, weather sealing, and then furthermore, the performed LCAs and assumptions cover all geographical areas, not just North America. And then in parallel, the audited LCAs are used to produce environmental product declarations, EPDs, which are a way of reporting that LCA data following those product category rules or PCRs. And those PCRs offer category-specific guidance for estimating and reporting the product life cycle environmental impacts, typically in the form of those environmental product declarations and product carbon footprints. The lack of global harmonization between PCRs has led to the development of duplicate PCRs for the same products. Therefore, it's really important to bear in mind that the values of different EPDs considerations are not comparable unless they were really issued by the same program operator and follow those same PCRs. So, Dow is introducing the first ever carbon neutral silicones for facades, offering carbon neutrality services for the individual project. Covers the three applications discussed: the structural glazing, insulated glass, and weather sealing. And then the documentation is available for at least in North America. Our Dowsel 795, 983, 3363. And then with the internationally recognized standard of that past 2060 carbon neutrality and its annual audits, it proves not only carbon neutrality, but also underlines the strong commitment of Dow to continuously reducing carbon emissions. So you can request carbon neutrality certificates for our products on a project-to-project basis, which can help contributing to additional green building certification credits. The 50-year long-term performance also plays a role in the carbon balance between what has been emitted during the production and the end of life show more of a 20 times benefit. So it is important to note that these carbon neutral silicones do not only contribute to a lower carbon footprint of the building through their sourcing and production, but also the way they're used in a sustainable design. So when we talk about sustainable design, it's not only about using preferably low embodied carbon materials, enables the materials to or resource efficiency, which is building kind of more clever by preventing or reducing material usage first. And this in turn leads to further reductions in embodied carbon. So once this has been optimized, the focus really should be on ensuring efficient building envelopes and reduction of operational carbon related to the use phase, energy-related emissions of buildings. This was a substantial part of the footprint in the slides that we saw earlier. However, with increasing energy efficiency and switch to renewable energy sources, in the longer term, material efficiency will become much more important. And finally, the last part of the sustainable design really assesses the circularity, so the end of life and the renovation or recycling possibilities that they can provide. So let's look at kind of how the system choice itself can further contribute to energy efficiency construction. So first, just a quick note that we won't really talk about aesthetics. That really is, the personal choice of the building. So things like your panel types, and are you using metal or glass or stone? Your panel sizes, their shapes, their colors, it's flat or curved, seamless, not seamless. Those aren't things that we're going to look at or discuss in this. So with that said, we can focus on the facade requirements. So we listed a few requirements up here that you can see. There can be many more of requirements, of course, things like acoustic performance. We've already seen in the previous slide that using the silicone bonding to fix an IGU on a facade helps ensure a durable weather tightness of the building envelope, which results in energy savings. And then in the next kind of few slides here, we want to compare how the assembly system of the facade influences its thermal performance, which impacts the operational carbon. Besides energy efficiency, the building envelope bonded silicone glazing can also contribute to material efficiency in the design. And then that material efficiency includes that building more clever by helping prevent or reduce that material usage in the first place, allowing for easier maintenance, repair, reuse, and recycling, and eventually helping to ensure recovery and disposal. First, the general contribution of silicone sealant to an energy efficiency envelope is really enabling weatherproofing. Air tightness is important to insulation. Air leakages represent up to 50% of energy losses in the building, and construction elements can't really be produced to tolerances that allow for an airtight fit on their own. So filling up any gaps improve air tightness. I won't go through the hard science with you. If you guys are interested in kind of the assumptions and calculations we made, by all means, come and find me and we can discuss this. More than happy to share that. And so we also, like I said, evaluated the bonding glazing can help prevent or reduce material resources by comparing the capped and bonded versions of frames in terms of material usage. Again, if you want to know any of the assumptions, but by all means, come get me. And then just as a quick illustration, the carbon savings for a representative facade using carbon neutral silicones versus standard silicones can be calculated. Again, I'm going to try to skip through some of this for you guys. Again, more about calculations, but you can see the unit sizes we use multiplied by the weight of the aluminum. We extrapolated to a 40,000 square meter project. And then as opposed to that more rigid bonding, silicones offer good potential for disassembly at the end of life. This method was developed for the dismantling of bonded glazing units, can further benefit from those 50 years of our experience, thousands of experience in facade inspection, deglazing, repair exercises.
Yeah. Yes.
And then just as a quick recap here, Dow's introduced this first ever carbon neutral silicones for facades. With that internationally recognized standard, the PAS 2060 carbon neutrality, and its annual audits proves not only carbon neutrality, and you can request these carbon neutral certificates for our projects and for your specific projects, and can help contributing to additional green building certification credits. And we've clearly defined those 2025 sustainability goals. We're working to redefine the role of business and sustainability through leadership and action, working together at the intersection of business, government, society to help drive the transition of a more sustainable planet. And we will build a more sustainable future, not only by reducing those unsustainable actions, but by proactively collaborating with you, technical university startups, partners who are willing to reach for a better tomorrow. Thanks, everybody.
Thank you, Skyler, for that deep dive on a ubiquitous product that we all use and rely on. It's good to know that a small thing can have a big impact. As we're prepping for what's going to be the last presentation of this session, I'm just going to ask this question. Who's familiar and would like to know why that large portion of Lake Street is closed right now in the loop? Anyone? Anyone wondering what's going on there with the closed road in the middle of the loop? I believe these two gentlemen are here to advise us on that reason. Please welcome Mark Negus, Principal at Skidmore, Owings & Merrill, and Brad Young, Senior Associate Principal at Skidmore, Owings & Merrill, to explain what's happening.
All right. So good afternoon, everybody. So my name is Mark Negus. I am a design principal at Skidmore, Owings & Merrill.
And I'm Brad Young. I'm a senior structural engineer with SOM in Chicago here.
So Brad and I are very excited to present to you the latest CTA station that's now beginning construction here in Chicago. So located in the heart of Chicago, at the northern edge of the loop, Staten Lake serves as a critical hub where 4 elevated lines and 1 subway line intersect, connecting thousands of riders across the city each day. From the very beginning of the project, we all envisioned the project as a true gateway into the loop, welcoming both daily commuters and visitors to Chicago with a sense of arrival into the heart of the city. Now, given its prominence in the theater district, the loop, and the city as a whole, we aim to create an iconic landmark, something that transcends mere civic infrastructure. For the rider, our goal was to elevate the daily transit experience, designing a station that not only provides shelter from wind and rain, but also creates a more comfortable, welcoming, and reliable environment year-round. We also saw this as an opportunity to both enhance the pedestrian and vehicular safety, removing columns from the middle of the intersection and narrowing crosswalks to improve visibility, efficiency, and overall flow. All of this is approached with a focus on craft, creating a station that is light, beautiful, yet resilient, reducing future maintenance while elevating the quality of fabrication and design. The original station, built in 1897, was one of Chicago's original elevated stations. Today, it served more than 2.3 million riders just last year. It's the busiest in the entire CTA network. Its age and intense use now call for significant repair and reimagining. Well, let's first start by looking at how the station experience has actually been improved. So at street level, sidewalks along Lake Street have been widened to create a safer pedestrian environment. Previously, people had to weave between columns and cars across a 50-foot roadway, an unsafe and unwelcoming condition that we've now resolved. 2 new ADA elevators are being added on the west side of State Street. Remarkably, the busiest station in Chicago has never been ADA accessible. Now we're able to ensure equitable access for all. We're also creating a seamless underground tunnel linking the Red Line subway directly to State and Light. And if you've ever navigated the city in the middle of January, you'll understand why a protected tunnel is an important addition here. And then at each corner of the site, stairways wrap around the 4 abutments that support the dome above. These stair towers rise to shared viewing platforms along the north and south sides of Lake Street, offering open vantage points for both riders as well as passerbys. A flyover bridge on the west spans above the tracks, seamlessly connecting the north and south platforms to provide riders with safe, convenient circulation across the station. Now, all of these improvements come together beneath a structure that is both strong and refined. Rising above the platforms, it shields riders from the elements while creating a clear, welcoming environment. Designed with durability in mind, it ensures long-term resilience while improving comfort, safety, and the overall rider experience. At a high level, the station's enclosure is organized into 2 distinct elements. The barrel vault, which extends east and west to cover the majority of the platform area, and the dome, which spans across the entire State and Lake intersection. Now, today we're going to focus most of the conversation on the dome, but let's first touch on the barrel vault. The vault is formed by a rhythm of structural ribs, spaced every 10 feet. These repeating elements span across both platforms and tracks, creating a unified enclosure that is both efficient as well as structurally expressive.
So the structure of the barrel vault canopy consists, as Mark said, of pretty simple vaulted plate structures, structural steel at 10 feet on center, and they are spanning across from the north side of the platform to the south side of the platform. And their depth is able to be kept fairly shallow as they rely on the form for its efficiency, taking advantage of multiple points of inflection, and also some arch action in the structure that keeps those structural plates fairly shallow. The geometry of the barrel vault is defined by 3 simple circular arc forms intersecting to create the full enclosure. The structure of the barrel vault is really a linear, moment-resisting frame structure, as you see on the right-hand side there, for resistance to wind and seismic forces, and interestingly, also for resistance to inertial effects by the braking of the train as it pulls into the station. So this precludes the need to put diagonal bracing in the structure, which is something that we were interested in doing in terms of maintaining a sort of orthogonal aesthetic to the geometry of the structure throughout the canopy. We also thought about ideas of pre- or off-site fabrication of larger sub-assemblies of the barrel vault structure so that we can bring larger assemblies onto the site and minimize the amount of on-site welding that would need to occur up at the platform level. Okay, we'll focus in a little bit more now on kind of the focal point of the station, which is the central dome canopy, or the grid shell dome.
So the dome springs from the 4 corners of the intersection. It's composed of a delicate array of intricately designed steel members. Together, they create a sense of enclosure while maximizing transparency, allowing dappled light to filter through, keeping riders and visitors visually connected to the city.
So the design of the central dome canopy was really an integrated process between the architectural and structural teams. Things that we did with the geometry of the dome affected the structure directly. It also influenced the way we panelized that curved surface with flat panels of glass. And then in turn, of course, everything is tied together through the details that relate the structure to the glazing system. The architecture is the structure. In this case, the structure is the architecture. They're one and the same. So in terms of the geometry, we wanted to create a vaulted structure just to maintain structural efficiency as much as we could. We also wanted to make sure that we held tight coverage to the entire extent of the platform canopy to maintain that rain protection. And then on the ends where we interface with the barrel vault, we wanted to make sure we had a smooth transition from the dome structure geometry to the barrel vault geometry. The structure itself spans approximately 120 feet from left to right, and it is supported on 4 main abutment towers, or to the non-engineer, stair and elevator towers for the station. Now, one of my mentors always used to say, constraints are a good thing. And the single most influential constraint or design principle for this project was the client's mandate that we must utilize flat glass panels, and that those flat glass panels, to the extent humanly possible, must be of the same rectangular size everywhere. So we really took that to heart, and that really kind of, influenced a lot of the decisions we made about how we take this curved surface and panelize it with the glass panels. Now, the details are important too. Obviously, the structure and the architecture wants to sort of be harmonious together. There are some differences that we'll touch on a little bit later, but the details are what kind of brings those two in harmony. Nothing on this project is hidden. Everything is visible. And so this really was an iterative design loop. As I mentioned, there isn't really a starting point to the loop or an ending point to the loop. The details don't fall out at the end. In fact, a lot of times we'd work through this loop and we'd come up with the details that made this happen, and we'd realize there was an issue with the details and we needed to go back and iterate through, adjust things on the geometry side to kind of resolve some of the detailing issues that we had. So just going to step through the geometry, the overall geometry of the dome form itself. It starts out by defining a pair of inclined arches or parabolic arches that make up the extent on the north and south of the dome canopy. And then we bound that on the east and west with circular arc beam lines. That's where we're interfacing with the rest of the barrel vault structure. And then we define sort of a main longitudinal ridge line that is a smooth transition between that barrel vault structure on the east and west and the vaulted structure of the dome canopy itself. And then we bisect that with a circular ridge line transverse to that, or in the north-south direction in this case. Now that really ends up defining what we call the control geometry. So the control geometry is what the structural geometry is based on, and it's also our reference geometry for panelizing that surface with our glass panels. And then we have a final design surface. We begin to define vertical or north-south strips, which begin to define these north-south rafter lines that we'll use to marry the architecture and the structural glazing assemblies together. Now that we have that sort of design surface or our defined design domain, a lot of times what we'll do on the structural engineering side is look at topology optimization to try to find hints at what might be a efficient arrangement of structure in order to resist a particular load path. So we certainly did that in this case, and one of the things you'll see is that some of the takeaways are it ends up being a fairly connected, uniform network of load paths that start to develop in this design domain. And the other thing that becomes apparent as load collects towards those 4 abutments, you can see that in the red images here where it's kind of more intense magnitude of load as load collects in the dome and concentrates on those 4 abutments. So this is kind of inspiration for us as engineers. We don't necessarily want to take that topology optimization results literally. We sort of want to use it as a little bit of inspiration or hint at what we might possibly do. We started out looking at some pretty simple ideas of, let's say, what if we collected all those lines of those influence lines of force and just collect them into a sort of a main beam and column system. And that's, of course, a somewhat simple structural system. It wasn't very satisfying to us because it didn't really feel like it was consistent with the sort of uniform nature of the distribution we saw with the topology optimization. And it created really, really large overhangs, of course, off the main beam lines that were kind of difficult to deal with. So we started to look at more distributed systems, kind of like inching closer and closer to what we saw in the topology optimization, where we looked at a pair of arches or 4 total arches spanning across each of the abutments. We looked at a little bit more, taking that a step further, looking at a more uniform distribution where we look at a total of 8 arches now spanning across the abutments. This still seemed, it was better for us in terms of sort of how it married with the topology optimization, but it still seemed a little unsatisfying because it seemed like there was still a hierarchy, really dominant arch members, and then everything was very secondary, where the topology optimization seemed like it was a more uniform network of structure. And so we looked at a grid shell option where we just had kind of like an orthogonal arrangement of the structural steel members up in the dome. That seemed somewhat satisfying. Again, it was a very uniform distribution. We were able to still see as load collects towards the abutments. We saw that in the structural design. Those members wanted to be larger. This also seemed to marry better with the geometry that we had in the barrel vault structure, which was, again, a much more kind of like orthogonal structural system. So this is kind of where we ended up with the grid shell option. And if we kind of step back one more time and look at the topology optimization, one of the things we saw in our analysis with this orthogonal grid shell structure is as load did collect towards the abutments, we saw that manifest itself in the in-plane bending forces or Vierendeel action in the structural members. And one of the things we wanted to do is we wanted to maintain a lot of structural honesty and clarity in the finished product. So that expression of the forces is going to be visible in the member sizes as we sort of modulate the width of those structural members. They're built up structural T's, and so we vary the flange width of those structural T's to sort of, show that force load path. Now I talked about, the really like kind of strong principle idea that was mandated to us, which is the idea of a single glass panel size. Probably as important to that was another constraint or sort of design principle that we then enforced upon ourselves, which is to say that we wanted to make sure that at each one of those intersecting nodes of the dome, all 4 stems of these T's intersected at a single consistent axis. And this is incredibly important. If you think about one of the ways we could orientate the structure is we could change the orientation so that the structure followed the curvature of the dome at any point. But what that would mean is that when they intersected, because they'd be at different rotation angles, there would be sort of an offset there or eccentricity. So this idea of aligning the stems of these T's, we call the torsion-free node concept, that drove a lot about the geometry and the orientation of all of our structural members. One of the things that does, though, is that if you continue those members, the flanges of the T's into the same intersection, there's some kind of gnarly geometry that occurs because of that. And so in dealing with that, one of the things we did is we said, okay, let's take a step back, pull those flanges back, and introduce a kind of a custom cap plate. That's a custom milled steel plate that is able to navigate or bridge those differences in geometries and rotation angles between the intersecting members. So this is sort of a well-intended compromise to say, let's make everything, 98% of the structure of the canopy as regular and in alignment as we possibly can, and let's use these cap plates that then navigate those geometric differences. If you turn the cap plate upside down and look at it from the base, there are some other things we did to sort of try to facilitate ease of erection and fit up. We created these notches on the underside of the cap plate so that you could use that to align the stems of the T's coming in and help alignment and fit up. And then we introduced a node axis rod there that can be temporarily screwed into the cap plate, help alignment, and keep that node axis rod in place while they're doing all the welding. Then that node axis rod, the screw can be removed and that everything is welded up.
Okay, so taking a closer look at the panelization and how the enclosure actually interfaces with Brad's structure. To stay in step with the framework, we began with the same design surface already subdivided into strips. The edge of each strip was then subdivided into straight line segments. These north-south elements align directly with the structural framework, defining what we refer to as the rafters of the enclosure. At the midpoint of each line segment, a vector is established using the tangent of the design surface at that point. These vectors generate the segmented ribs, which we refer to as the purlins of the enclosure. Each line segment is then extruded 5 feet along said vector, producing flat, identical glazing panels. These panels follow the surface curvature while staggering in a subtle shingled pattern. The interface between the dome's flowing structural lines and its planar glazing panels creates unique moments at the points of greatest curvature, particularly where the dome springs outward from the 4 abutments. When isolating the glazing framework, you can clearly see how the stepped pattern that results from the requirement to use uniformly sized flat glass panels. But here the structure relies on concentric lines throughout, ensuring that it maintains both rigidity and efficiency. So that interface between these two systems has been carefully calibrated to minimize the stair-step effect, allowing the structure and enclosure to work together in complete harmony. The rafter lines run north-south, directly following their structural paths, while the purlins have been carefully positioned so that they never project beyond the face of the supporting structural members below. Now looking closer at the detail, you can see how the rafters supporting the short sides of each glazing panel, on the right there, are centered directly over the structure, whereas the purlins, however, are shift slightly across the width of the structural T. Please ignore the misspelling of the word purlin. Now, the areas of the greatest curvature near the abutments, we did introduce 5 different glazing frame types. This approach keeps glass sizes consistent, while accommodating the variable distance to the purlins through additional aluminum inserts and widened sealant joints. The end result is a structure that feels seamless, rational, and elegant, one that is inseparably wedded to the architecture itself. Rather than functioning as 2 separate systems, the structure and enclosure are unified into a single expression. In the end, our hope is that this station stands for more than just civic infrastructure. It becomes a true gateway into the city, point of arrival that welcomes both commuters and visitors alike. And it's an enduring icon that defines downtown Chicago for generations to come. This is a project that myself, Brad, the entire studio are deeply proud of. It represents years of collaboration, creativity, and dedication. We're genuinely excited to see it move from design into construction and to watch it become a lasting part of Chicago's civic identity. Now, we also see this project as being part of a larger evolution of the glass and steel enclosures that our firm has been developing over the years. From Polaris Hall at the Air Force Academy, to the new Penn Station entrance, to Moynihan Train Hall. Each design is unique, yet each draws from the lessons of those that came before. This station, St. Lake, continues that lineage, pushing our craft further while responding to Chicago's own identity and needs. Now, we bring that same integrated design approach to every project that we undertake. And that commitment is clearly evident in the new O'Hare Concourse. Breaking ground this past August, it demonstrates how architecture, engineering, and urban design come together seamlessly to create a world-class passenger experience. Just up the road a little bit, work is underway at the well-known Spire site, where our designers and engineers found a way to repurpose the existing foundations, creating a new tower we feel embodies Chicago's architectural spirit in a much more rational and achievable form. So just as these projects showcase innovation and integration, the same design philosophy guides our work here at State and Lake, transforming a critical transit hub into both a civic landmark and a daily amenity. Thank you.
Thank you to Mark and Brad for updating us on something that's happening right here downtown. We're going to be stopping for a short break now for coffee, tea, other beverages as needed, and we will be back here shortly for the final session. Thank you, everyone. Let's go ahead and get started, though, because one of our speakers would like to catch his flight, and there may be a few others in the room that would also like to do that. So right now, I would like to welcome up Nathan McRae from Snowetta and Jameson Guest from Heichie's. And they are going to draw some parallels between how we work and how the automotive industry works and how that can apply to our efforts. Please welcome them to the stage.
Hello. I guess I don't need to be near this, do I? That's just for the images. So I'm going to talk about one specific piece of this huge building that's just opening. Jameson's going to talk about another piece of it. It is, well, forwarding without me. So this project is for an automotive company, which we're not allowed to divulge who it is. It's in Dearborn, Michigan, but they have a large research and engineering campus there and their world headquarters. They just issued a press release indicating that this building actually is their new world headquarters. So that was exciting to learn for us, which we didn't know when we were designing it, as a design and engineering building. And it now has room for all their execs in it as well. So this is the first phase in a master plan that we started working on in 2017, which culminated in a plan for about 7 million square feet of new buildings, all interconnected workplace of various types. This is the design and engineering primary facility that with all their design studios in it. And this is about 2 million square feet. So you can get a sense of the scale here. That is an automotive company's research and engineering campus. That's their track across the street, Oakwood Avenue. I don't know if any of you have been there. This is only the first phase. So the building continues down towards me in the second phase. And this facade of it is almost a half mile long. So that led to some of the constraints that we needed to solve in that facade rather than having it, or on the building, rather than having it be a half mile of uninterrupted flat facade. We broke the building down into scalloped facets by projecting out pieces of the program at select locations. It reduces the scale of the building to your eye and creates kind of smaller, more intimate, if you can call it that, pieces. You'll see as we look at the facade how this blue piece differs from the white piece. The white piece is the part that has the frit on it that I'm going to talk about. And why frit? We looked at various means to achieve the performance necessary on the building. The exterior is largely office space, so daylighting was important there. And at this automotive company in Michigan, there's not a terrible amount of sunlight, so we wanted to maximize floor-to-floor height and daylight. But there are, of course, performance issues, solar exposure. So by being able to modulate the frit in order to achieve solar performance, which varies transparency, allows us to be expressive with the design of it, and being a cost-effective solution, we ended up with a solution for frit for this largest piece of more than 14 wall types on the project, and this is the largest single one of them. So the whole building's not frit, but the exterior of the upper portion is. So after making that determination, we started working with some workshops with the car engineers themselves, and brainstormed different ideas about what could be the generative geometry for that frit. So looking at the way air flows over vehicles, like their most popular vehicle. There was a suggestion by them, because they love the sound of their cars, that we could look at sound waves. There's one of their cars in the corner. Of course, I can't say who made it, but and then they used to tack these little pins onto the cars and put them into the air tunnels and look at the way the pin with the flag, look at the way that the flag deflected, and that they call those vector fields. So we landed on something between this airflow and vector field solution. We did studies of what an airflow sketch around coming or moving around the building might look like, what it might look like if it was used sound waves, and then what the vector fields might look like. and landed on, well, actually, I'm going to go through first the scale. So we obviously needed to deal with building scale, those smaller pieces of the facade scale, and then human scale, and it needed to work. It needed to function at all of those scales. So we ended up here, which allows us to modulate from about a 10% facade coverage to about 40% at the max, and that is a gradient that we can manipulate within the design of the facade. So what is the frit shape itself? We looked at the obvious dot. We looked at deforming the dots. We looked at patents because they have a lot of interesting patents, and then ended up on an oval, which may be obvious if you knew what the car company was. So zooming in, we had to make it work. Obviously, from the exterior, we wanted it to read solid as a pattern. From the interior, you want to be able to see through it. So we need to look at how to use those ovals and how to integrate. We ended up doing this thing they call an Easter egg, where you can find in certain places on the building little bits of those patent numbers. So we need to figure out what size the oval should be, how to integrate the patent numbers. Started doing in-house mock-ups, tests, fonts. We had to look at, everybody wanted to use digital frit because it's kind of the easiest these days, but it was really important because it covers the whole building to be able to see out through it very easily. So you want it dark on the inside because your eye can see past dark, and we wanted it white on the outside. And when you layer up digital frit, it gets muddy and it's all kind of gray from the inside and from the outside. So that wasn't going to work. And we ended up doing a double pass silkscreen process that allows it to be very bright on the exterior and very dark on the interior. But what it does then is limit you to a number of screens. So there's pressure to economize in terms of the number of screens because you can't print infinite versions of them. This was an analysis that one of our engineers did, showing where we had the strongest exposure, solar exposure, and where we wanted to concentrate the densest frit. That leads to a solution like this. This is the actual calculations that show how much we want on the different pieces of the facade and how that is deployed throughout the building. So this is actually, after that exercise, looking at what that frit looks like on the elevations. These slash things were a tool to sort of emphasize the reading of motion and also to increase the frit where we needed more density. A guy in our office spent like 2 years doing rationalization of this frit and producing files for the fabricator. And he told us that he used to dream about frit ovals. So this is his work. He started with a piece of the facade, a turbulent line, subdivided it into a reasonable size so they would meet up end to end because they're silk screens. Each of those goes 4 panels wide, multiplied them, put them together in a gradient. So this is how you see it working. There are 32 different screens. They also don't always need to go from light to dark or lightest to heaviest. As you go around the other side of the building, you need to go the opposite way. So we made the patterns work upside down so that you can go in the other direction. And that meant that the patent numbers had to also be paired with upside down versions of themselves. So here's a sample of that on various exposures, seeing the different density. That's all of the facade of this type on the building. This is what we delivered to the facade fabricator, color-coded. Started with vectors, turned them into ovals via a process of rhino and grasshopper, which this poor guy did for 2 years. And these were all the screens, but there were many other little small ones for doors and things. This is an example of it after being fabricated at Interpaint and sent to Harman, who was the installer. We did extensive full-size glass selection mock-ups where many were swapped out. This one, the one that we ended up with is this where doesn't matter. The one we ended up with is the one next to the curved piece just to the left. You can see that at night and at day was the most neutral one. That's the view from the inside. You can see the little patent numbers snuck in there between the ovals. So from a rendering on the left to the reality on the right, it's interesting the way that the frit responds to different daylight conditions. It actually does look very white in the sun, and it looks like the sky when it reflects the sky. So these are actual images of the frit on the building, showing that kind of variation in the way that it reads. Again, here you can see it on the left, you don't see it on the right. We use the same coating on all three of these systems of glass. So there's that zone that was blue in the first diagram is in the middle here. That's just dark spandrel and the same coating. The lower retail and entrance is the same coating with nothing, and then with the frit at the top. The fritted portion has these little nibs that project out, and so that from an oblique angle you start to see more texture and more density of giving it some substance. And then these are some sort of larger images of the building in a cool light, in warmer light. This is from 2 days ago, their press release, and the beginning image and an existing one. And I am over time, so passing it off to Jameson.
Thanks, Nathan. So as Nathan described with the development of the ceramic frit, we really like this idea of the parallels in automotive design, architectural design, this idea of concept cars, concept design, full-scale mock-ups, and testing these concepts through prototypes. And, because of their huge presence in American culture, there's this popular appreciation and familiarity with concept cars in particular that I find kind of interesting, how they push the boundaries of design and technology. And maybe some of this is my own bias growing up in the Detroit suburbs, attending the North American Auto Show every single year, and with so many of my friends and family, tied to the auto industry. This, as a topic was very interesting to us. So at my firm, Heinches Consulting Architects and Engineers, we are facade enclosure consultants. We're founded more than 35 years ago. And this practice of concept design, full-scale prototyping, and testing those prototypes to validate them is obviously such a crucial part of our process as a firm. And to show one quick example, this for a retail flagship project in New York, this particular project required a lot of glass fabrication research and development to develop a prototype of glass material that's really something completely new, combining processes, let's say. So an insulating glass unit that features slumped glass, laminated with a carved texture that's imparted into the outer surface of the glass. Combining these processes was something that produced a new glass composition, something that previously didn't exist before. And the processes that I'll just talk about briefly today, the two processes that we had to combine and test and prototype on this project are lamination bending and anti-reflective coating. And the project is a big project. It included more than 600,000 square feet of cladding. And today I just want to touch on one of the very smallest systems, only 2,000 square feet of this project, but one that featured, this kind of approach to prototyping and full-scale mock-up testing, materials. The challenge here was to develop an ultra-transparent monumental storefront glazing system and a glazing material that had curved geometry. And so this is a picture of an autoclave. It's essentially a pressure cooker that's used to fabricate laminated glass and other useful things, but in our case, to laminate and bend glass. And so there's many different ways to bend glass. And for our curved storefront geometry that had a very large radius, nearly 60 feet, lamination bending had very good potential to reduce the distortion we'd have from heat treatment, to provide good durability in the glass, and it worked really well with the design geometry, as I mentioned. So a little bit about lamination bending in some very quick and super high-level diagrams. So don't look too closely, but in lamination glass bending, we have glass positioned in the autoclave. It's shaped into a curved shape, clamped into that shape, really, while being subjected to heat and pressure. And the finished piece comes out of the autoclave It actually rebounds a little bit from the fully deformed shape. So of course that's got to be accounted for in the design. And, this technique of lamination bending been used very successfully on very many projects. It was more experimental in this case to combine it with the AR coatings and to do it at the scale. Each piece is basically a jumbo-sized piece of glass, so about 10 feet wide by 18 feet tall. And this second process that we're combining in this particular example is, it's a feature really more of the anti-reflective coating. And so this is actually a close-up of a moth's eye, which has anti-reflective properties that function in a really similar way to the way that anti-reflective coatings that we use for architectural markets or for cell phone screens, eyeglasses, etc. Different, but functional in a very similar way. And so very quick, kind of high level about anti-reflective coating in simplified diagrams. We start with a laminated glass unit. And, typically with that glass, right, we have light that's passing through it, visible light that's passing through the glass with a percentage of that light being reflected to the exterior that's visually observable as a reflection, about 8%. And so with the application of AR coatings, anti-reflective coatings, the effect is to reduce the visibility of this reflection. The coatings are composed of microscopic thin metal films, thin metal layers that are deposited on the glass surface. The outer surface of that very thin layer and the inner surface have different indexes of refraction. And when the light encounters those two different surfaces, the effect of the light refracting off those surfaces has a canceling out effect that results in more transmitted light that goes through, less visible reflectivity from the exterior, and we're typically applying it to the front and back surface of the glass to sort of maximize the effect, let's say. And so in testing this material that we thought was a very good idea for this project, that we thought had a lot of potential for success, we had to get to a full-scale prototype stage. The main concern, to simplify things a bit, was that the durability of the anti-reflective coating was going to be a potential problem in the clamping process and being subjected to the conditions inside the autoclave. And so prototype samples were produced. This is part of a full-size glass selection mock-up, a totally separate mock-up from the one that Nathan showed, and I think there were probably 4 others. The company's commitment to that process is really why I think these things worked out well. And this was a competitive mock-up also that features multiple fabricators and also multiple anti-reflective coatings. So a beauty contest, we like to call it sometimes. And this tested glass that was treated with the coating and also glass that was not. At this point, it was very possible that the AR coatings were going to be objectionable, that it wasn't going to work. Obviously, the pieces on the left are untreated. The 2 on the right are treated with the anti-reflective coating. And ultimately, in terms of fabrication and supplying partners on the project, so SADAC, as a glass fabricator, was selected to produce this glass using Interpaint AGC's ClearSight anti-reflective coating. I have to point this out, that none of this is possible without fabrication partners who are, multiple partners who are willing to take on these challenges, these risks, and really kind of buy into this as a process in developing, a specific product that's going to work for this application. And so I just want to close by showing a couple images during installation. In terms of, the remarkable degree of transparency that's achieved, I think we were very, pleasantly surprised with how things came together. There's always a jump in scale from going to one piece that you like to 10. And the effect is effective from the inside and from the outside. That's part of the idea here, that the cars are going to be on display at the exterior and also at the interior. So it really, made a lot of sense to select an AR coating like that. And thank you so much for your time, and it's been a pleasure.
Thank you to both Nathan and Jameson. I really like the way you just actually baked the identity of the company right into their facade. Our next speaker is ready. He's the president of Janssen, which you were, Robert Miller, sorry. Usually it's right there for me. Please welcome, Robert Miller, president of Janssen.
Thank you very much. So as just mentioned, Robert Miller, born and raised in Peoria, bit outside of the shadows of downtown Chicago here, but very proud of Chicago, proud of Illinois, proud of the Midwest, and happy to be here to have a chance to talk with you guys today. So I attended a Zak's conference several months ago. There was a panel on sustainable architecture. One of the architects made a comment on there that we should demystify a little bit the workload that's behind sustainable architecture. At the end of the day, we're all trying to make beautiful buildings, right? What we're doing with sustainable architecture is adding a few more things on the to-do list. We want to make certain that those buildings are built, constructed effectively. We want to make certain they're well maintained. And we want to make certain that sometime in the future when they need to do work on it, they can do it easily and with minimal disruption. I thought those are very interesting comments. They really stuck with me. And I thought, well, I'm going to use that as the basis for my presentation. I'm going to take it in a slightly different turn, though. I'm going to talk first about historical renovations, very briefly on new buildings, and then I'll spend a little bit of time on third-party certifications. Okay? I am going to start with the most obvious statement ever, which is we are in a city with beautiful architecture. And it's probably already been said several times today. I'll say it again. When I think of Chicago, when I think of Illinois, when I think of the Midwest, I think of buildings very similar to this, where there is brick, often red brick, steel, and light, and that turns into some very beautiful imagery. That beautiful imagery is not unique to this area of the country. Of course, we find it in other areas of the United States. Also find it very common in the UK, or very common as in this building in Cologne, Germany. I used the word steel, so let's stay with that for a moment, because for us to tell you our perception of sustainable architecture, you need to know a little bit about who we are. And at the end of the day, we're steel guys. We produce steel frames for doors, windows, and facades. We send these in to U.S. manufacturers who would then make finished elements. Everything is custom made. And then they would tailor everything to the building, including, I believe, we have one of our Chicagoland partners here in the audience with us today. We are a 100-year-old company based in Switzerland. We started with steel tubes. After World War II, we folded those steel tubes into architectural profiles. We are family-owned, third generation. And in 2021, we made an important decision. We decided to sell the steel tubes division of the company and focus on architectural steel. This meant that we expanded our product lines, our R&D. We also decided to go more international. So we created Janssen America as a subsidiary in New York, and also the reason why I'm here at Zak's today. So now that that's over, let's start with historical renovations. This is the Battersea Power Plant in London. If you imagine a big pink pig balloon floating over it, then you may recognize it from the Pink Floyd album. This building was built in 1928, and it was commissioned in 1933. All right, 1928 is going to play an important word later on, by the way. But it was commissioned in 1933. It then spent several decades being one of the primary sources of power into London until it was decommissioned in 1983. It then sat there, unfortunately, unused for many years. Now, on the outside, it still stayed beautiful. It was a cultural icon, partially perhaps because of the Pink Floyd album, but inside it was really starting to fall apart. Roughly 2012, there became a new group of owners. They decided that they wanted to take this and make a multi-use facility out of it. and they invited us into the project. So we worked very closely with the architect Forster and Partner, and more specifically on our scope, we looked at those windows that were built when it was constructed in the 1920s, and they wanted to keep the integrity of those windows as much as possible, but decide, okay, well, what else can we really do with it? Well, our R&D department looked at it and basically concluded that original style from 1928 was actually pretty good, right? Considering the technology they had at that time, the materials they had at that time, the technology or the techniques for making steel, they did a pretty good job. So we took that original concept and we did 5 iterations together with the architects. And what we ended up with was something that you see here in this drawing, but also something I have here in my hands, which is a very nice thin profile that keeps the original intent in place, but adds a very high quality thermal brake system. Now you got to keep in mind, Battersea Power Plant has the Thames River on one side, major highway on the other. So then there's also additional benefit, which is the noise reduction and also the air quality, considering it is in the center of London, certain air quality properties that really then brought a benefit into the entire building. Before I jump into the next slide, I just want to simply take a small deviation from my presentation, because there was a few presentations ago a very nice video we saw about a train going through Chicago, and you basically had the window open, and it was loud, you had it closed, and it was nice and quiet. Well, I can tell you last night was Mexican National Day, right? And the hotel I'm staying at is also right next to Trump Tower. So in addition to the fact that they were celebrating, they all decided to honk their horns at Trump, which meant that I got no sleep last night. But if the hotel would have taken that glass and these steel frames, I would have slept like a baby. So I kind of wish they would have. We took that concept from windows, we expanded it in. Like I said, we focus on architectural steel. So we expanded the different types of varieties from windows, doors. We expanded the types of materials from the standard steel, stainless steel, Corten. I want to say just a brief comment about Corten, because this plays an interesting role in historical renovation. If you don't know Corten steel is basically pre-treated. Yeah? And with pre-treated, you're getting that rusted look. In a way, it's very stylish, especially in Central Europe. But what I find in historical renovation projects is it opens up a theoretical conversation. What is the original historical intent of the building? What are we replicating? Are we replicating the original steel that was put in the 1920s? Or are we trying to replicate the rusted outlook that most people have become familiar with the building? And it's a bit of a silly one, but it's kind of an interesting conversation. And I would encourage you guys to also start thinking a little bit in that parameter of what is the original historical intent. Just a very minor comment. Next year, we will have brass bronze coming, and we are launching it this month in Italy. And I want to use this as a platform to officially tell you that it's coming to the United States next year as a pre-announcement of our product launch. Different types of application varieties. But here I would like to stay a little bit longer, because that really comes back into, I think, what a lot of us connotate with historical renovations, right? Regardless if it's steel, Corten steel, brass bronze, it's a lot of that curvature that you see in old churches, for example, or railroad stations, or even art museums or art depots, a lot of breweries. So imagine a lot of the breweries, a lot of whiskey distilleries, a lot of those things are turning into restaurants and hotels. Beautiful opportunity. And again, coming back to that traditional Chicago look, red brick, steel, lighting, beautiful combinations. So talk about new buildings. With new buildings, and I see I need to go a little bit faster here, I want to simply bring 2 comments into play. The power of steel means you can expand your spans. What I say is a lot of facades that are built have a certain cookie cutter in mind. Do a paradigm shift. Think about what you could be doing with that material, going larger. Like Moore's law for technology, you can go with twice the size with smaller. You can think of a steel of roughly being a power of 3 compared to aluminum. With 3 times the strength, you can go at higher spans. Or conversely, something like aluminum needs 3 times the material. 3 times the material means then that you have a different impact on your embodied carbon. One more comment on that is that connections are critical. Think about what these people are going to be doing in the future. If you have welded this, these people are going to have a very difficult time using bolts, using anchors, or even we have for some 20, 30 years, a little clip-in plug-and-play, which we intended to make it easier for our contractors, but now we also see it's very practical for facades. Let's go on to building certifications. Always dangerous. You guys probably know more about this than I do, but it could be there's some people in the crowd who know very little about it. There is BREEAM, more common in Europe, slightly more complex. There is WELL. Now, WELL is very interesting. It's looking at the well-being of the inhabitants that are inside the building, right? And think about it. For the last 20, 30, 40 years, we've been throwing a lot of technology inside of buildings. Everything from Wi-Fi to Internet of Things to automated controls and elevators. These things have an impact. There is something called building sickness, and WELL is basically just trying to find that balance, right? We all want to strive for a good design, but how do we do it in a way that really keeps the occupants in mind? LEED certification is perhaps the most common. There are 4 different types of LEED certifications. Which one of these is appropriate really depends on a discussion with the building owner based on what they're trying to accomplish and what's the ROI they're looking for. The one that I'm going to reference very briefly, oh, sorry, I thought that was already automated. My apologies on that. 4 different ones. I'm going to use this as a reference. This is a building in Spain. This is where we jumped in and helped the architects with LEED certification. So it's a little bit of our point of reference. Again, a building you easily find here in the United States. Now, that point system basically comes down to checkboxes inside of 9 categories. So each one of these, what have you done in this category? Boom, 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 right? Now, but building material manufacturer like us, we're not directly involved. We're indirect stakeholders. But if you look at these 9 categories, what you can say is 56% are influenced by a building manufacturer such as Jensen. All right? Now, materials and resources, obvious. Indoor, environmental quality, all right, I've already mentioned that one several times. But the big boy, 30%, not only in the blue category, but in the entire pie chart, that really goes straight down to the crunch of it, which is what is the energy source that's being used. This is your operational performance at the end of the day. What we did was we took our products. Here's an example coming from a German company, Dries & Sommer, who is a third-party consultant, and they basically worked with us. If we were to take those products into these buildings, what are the points that would be applicable potentially to LEED? Potentially, right? Because there are some devils in the details. But it gives you as architects an opportunity to kind of say, well, if I were to use these products in these type of building, these are the type of points that I could potentially expect. The main reasons for that, remember 1920s Battersea project, it was built, so it already lasted a very long time. We feel confident giving the claims that 75 years makes sense for doors and windows, and 100 years makes sense for facades. And we've justified that together with a German organization here called Institute of Construction and Environment. One reason also why we impact that category is because of recycling. There's 2 points to be made with recycling. One is that steel retains its strength, right? I don't want to make too much of a bash on aluminum, but today's big item with aluminum will be tomorrow's Coke can. Today's Coke can will be tomorrow's pen. The reason is basically it's always going down a reduction. multiple reasons for it. Steel always retains its strength. While steel retains its strength, and I'm going to go through this a little bit quickly now because of timing, there is a second part to it, which is the sustainability of steel. And if we were to take 60% less power to make that steel, and we use recycled steel, you have something called green steel. So green steel simply means we're using our profiles based on recycled steel, and we've also then verified it, the facilities that we do for production, to create something called green steel. If you compare that, the embodied carbon levels with aluminum, you see then the amount of impact that you can expect from steel in general, or then also green steel. So I'm going to summarize all of that with what is architectural steel's contribution to sustainable architecture. First one I mentioned earlier, high thermal performance, less operational costs. This was the idea of expand your spans, right? Think about the material you're using in that. Noise reduction plus light equals wellness. That was my example that I couldn't sleep last night. Strong, less materials, less embodied carbon. Long-lasting, decades. 1920s when Battersea was built, looking at it now and our promise that it lasts for 75 years to 100 years for our contribution to new buildings. Low embodied carbon, regardless if it's standard steel or brand new green steel profiles. And recycling with great strength retention and adaptive reuse. So I'm going to summarize now, how do we know these things? And how can we work with you or help you on those such projects? There's something called an LCA. An LCA is basically a project-specific analysis that our company would do with you guys to basically say these products, this project, this is how it would work. If we want to standardize an LCA, there's something called an EPD, Environmental Performance Document. We have 20 of these in Europe, and I'm proud to tell you that we have now the first ones coming in the United States within the next couple of weeks. By Christmas time, we should have, I believe, 8 EPDs and 5 of those 3 Summers reports, all then brought into the U.S. market. Let me just finish that one. Along with, you guys can get all of this stuff for free. This QR code leads you to a portal. The portal has all of our technical documents, including all EPDs. And once those American EPDs and reports are available, we'll put them in by the end of the year. Always also feel free to contact us, me or our technical department. And thank you very much, Chicago.
Thank you so much to Robert, and as some assistance in demystifying one component of what we have to do for some of our sustainable designs. Thank you, everyone, to making it this far. We are now going to be embarking on our final session. As we set up, I would also like to do a shameless plug for AIA Chicago. Tomorrow night is our design night. This is our annual event. There are tickets to the awards ceremonies available for $15, so everyone can come. You are all welcome to come if you're here tomorrow night, and it'll be held at the Harris Theater. You can find more information at aiachicago.org. It is another opportunity to hang out with a bunch of architects, and the beverages won't be coffee or tea. As we're getting ready, I'd now like to introduce our moderator. I brought up AIA Chicago Design Night. We're on the board together. Sarah Beardsley is from Solomon Cordwell Benz here in town, and she will be introducing the other panelists, and they will be discussing incentives and initiatives for historical rehab and reuse and adaptation.
Hello? Okay, that's better. I wanted to call out my fellow panelists. We have Gary Stoltz, who's a principal and chief of development at R2. Elizabeth Blasius, who is a preservation consultant with Preservation Futures. Allison Tunin-Talamo, who is a restoration consultant with Walker, and Mark Schwammel, who is an architect and director at Ware Malcolm Chicago office. So welcome to all of them. We've got a great panel for you today. So I know we're running a little behind. We'll try to get you all out of here on time, but we also have some great content to cover. And adaptive reuse is a topic that's close to all of our hearts. It's so important. It's a labor of love for everyone who works on these buildings. We become kind of the stewards of these existing buildings as we bring them to their new life. So we're all going to tell you first a little bit about who we are and what we do, and it really represents all the aspects of the team members that work on these projects. And then afterward, we'll have some Q&A with the group, try to get some discussion going. So with that, who has the clicker? That is the first question. Thank you. Forward, backward. How about you? All right. So as Lynda was saying, I work with SCB, and we are working on a couple of projects here in Chicago in the LaSalle corridor. But I wanted to start with just why adaptive reuse. We all know it's been a hot topic the last few years. Why is it so important? It's really important to our cities. We talk about the topic of re-urbanization. Really, we've got such high vacancy rates in some of these historical corridors that it's affecting our urban life and our urban fabric. So it's super important that we undergo initiatives with developers and with city officials to try and get these projects going to adaptively reuse or reposition these buildings so that they can be reoccupied and people can enjoy them again, and that the ground plane can be revitalized. So it's very important. And there's strategic investment when groups of buildings are incentivized to do this together. And that's what's trying to happen here in Chicago. So these are just some examples of types of adaptive reuse and repositioning that we do at SCB. The blue represents office on these diagrams. The yellow represents residential. So we have buildings that have been fully converted, like the Tribune Tower. We have buildings that have been repositioned. And we have buildings that are going through a phased conversion, like the 135 South LaSalle project. And all four of these buildings are landmarked or in the process of being landmarked. And there's many reasons for that, their historic integrity, but also the incentives that they're able to get. I did want to touch on embodied carbon as well. One other reason adaptive reuse is so important is we're saving all of this embodied carbon that was put into these buildings when they were built, and reducing the pollution that we as architects and builders must cause when we build new materials. So an adaptive reuse can take 25% or less of the carbon as compared to building that building from scratch. So here's just some quick examples of some of the projects that we have worked on. We do this all across the country. So one thing I found about existing buildings is you have to approach every one of them with a new eyes and really look at the problems of that particular building and how you're going to solve them. Enclosures are particularly important on existing buildings. And there's a lot of factors. It gets very technical very quickly, which I love because I love to nerd out on this stuff. But we're able to save a lot of energy. With these buildings. With Tribune Tower, we actually saved 40% of the energy on the building by converting it, putting in heat pumps, rehabbing a lot of equipment, and spraying the inside, and replacing the windows. So these window replacements, there's a lot of thermal analysis we do, a lot of building science that we get into with our consultants to make sure we're doing the right thing for these buildings, and we're not going to have mold, we're not going to have condensation. Also, there's code issues like operable windows, so we work on a lot of that with our teams. I did want to touch again on LaSalle Reimagined. We have 5 million square feet of vacant space and no affordable housing in the LaSalle corridor, and that will soon change, probably within the next year or two as these projects finish out. Every member of this group, I think, is involved in some way with LaSalle Reimagined. So we're going to talk a bit about that. SCB is currently in DD with the Field building, which is a 1.6 million square feet monster building with a beautiful 1930s arcade that's intact. So that's what I do.
I think I'll take the center.
You're going to take the clicker?
Yeah, I think you should.
Mike, so.
Right. So, all right.
So Gary Stoltz, I'm with our two companies. You might have heard of us through some projects on Goose Island, like REI, like Morton Salt.
I'm going to work through kind of how we got there from the developer perspectives. Thank you for having a developer here. Hopefully it is not the last time. So we'll see. So architect by training, come from a family contractors. We had in 2008, I was PA on a house. The GC walked. We started a design build company and took it over. So that is how kind of started getting into the design build side of things. The house in the upper left corner, the clients for that house ended up becoming the first investor in R2 individually. And I followed him over there to start a design build company within a real estate investment startup. The project at the bottom, 224 North Des Plaines, that was our first repositioning. And there's a distinction, as you know, between repositioning and adaptive reuse. Repositioning is building state as office, primarily systems and cosmetic improvements. And then either within the office market, selling it, recapping it, and moving on. So project in the middle was for Tybar. Some of you may have heard of it. This was teak reclaimed wood time within design. But this is a really good example of kind of the start for us of transitioning from repositioning to adaptive reuse. Moving on. So we started buying loft office buildings, and there was a period coming out of the crisis where loft office buildings became very desirable very quickly from a tenant perspective. And we had a lot of luck with the buildings that we were repositioning. Then institutional investors got involved and basically made them unaffordable for your local investors. So we were looking for their opportunities. We kind of zeroed in on Goose Island. Now, Goose Island is surrounded by some of the best residential neighborhoods in the Midwest. It is extremely close to downtown. Zoning has kept it, zoning and access have kept it kind of underdeveloped for quite some time. So we started by purchasing industrial buildings that we frankly just like the architecture of. That sounds crazy, but buildings with great bones, and they had existing tenants. So when we bought them, there were sale leasebacks, which made it economically possible to hold the building for a while till not only the market improved, but also we could figure out what to do with it. In talking about neighborhoods, nobody knew what Goose Island was necessarily when we started. Places on Goose Island were described by the neighborhood they were adjacent to. We started a campaign with Port Urbanism to get the word out about the island's potential, worked with the city on the change zoning plan, designed a couple of bridges, developed an art program for the island, and really started getting the word out there about what Goose Island could be. Moving on. So we, touching on technical challenges for a little bit. So every project within is, probably on the island, around the island, but mostly in the city, dirty soil. So the image in the lower left, that is a pit at the REI facility where I like this image because it touches on dirty soil, existing conduit, footings that were found from a building prior to our building, sewer lines that were unexpected, and so found newspapers. So really kind of in adaptive reuse, you have to anticipate that there's going to be significant number of unknowns and contingency on that on the front end. So quickly seawalls, environmental ACMs and lead, underground storage tanks, stormwater challenges, every single project. Project on the right, Morton Salt Sheds. Interesting thing about that project is we worked with Omni to develop a soil that allowed us to satisfy our stormwater requirements. It was the first project that ever used it, and we did not have to put in underground storage for that. So a lot of other kind of challenges come along. Structural deterioration. Morton Salt, as some of you may know, has been repurposed. That building, the reason the scaffolding's in it, wind over 25 miles an hour or snow over 2 inches, you couldn't go in the building. And that was after the salt collapse onto the Acura lot. So we came into that point in time and worked with Forefront to really determine a plan for how to reposition the structure, how to save it, basically. Another interesting thing about it was all of the existing panels on the facade were asbestos, the ones that had the sign painted on them. So worked with Landmarks, worked with legal, worked with Morton for them to allow us to do a sign of that scale back with an upgraded facade that was insulated and watertight. So one thing we've learned throughout adaptive reuse, especially in the office market, is if you don't start building, you won't be able to rent it. So one of the biggest challenges that we had was actually starting demolition to figure out what we had that we could then start to redesign and market. So
Just a couple more challenges building on the left. Never take out a concrete floor slab in a building with a paper-wrapped gyp roof system and without positive ventilation, especially if you plan to put in a hospital facility in the building. You learn a lot during these. We were kind of green, but learned a lot along the way. On the right side, 79 West Monroe, the project few of us are going to talk about. This is just a great image of, we removed the roof to lower it so that we could put in a roof deck, but just discovering things about the facade, discovered the steam loop that nobody knew about. So things that came up along the way that we're solving for with the design teams now. Quickly, so entitlement 79 West Monroe, 2.5 years, got rejected twice by the city for our proposal, and worked through 2 administrations to get it approved. We were outside the LaSalle corridor boundary. We were able to, through direct foreign investment in the city, which is another conversation with mayors, and through our ability to move without debt quickly, we were able to get our project approved and incorporated into the program, and we're going to be the first one to deliver next July. So there's some other details there, 35% affordable, minority GC, and JV partner, landmarks. It's a whole other conversation, possibly comes up during questions, but the entitlement was a wild ride. So a couple things to 79 West Monroe. Building had most historic features had been removed at some point. We have stairs that were left, so working with Mark and his team and city officials to make sure we can keep the stair looking like that. Mosaic tile underneath the carpeting. A lot of the facade detailing from the original building had been removed. We are repurposing the weather bell, so that is part of the project, which will now be digitally instead of manually controlled. The current example of what we're dealing with on the facade of 79 West Monroe, these cast iron, I guess they're kind of plasters between windows, but this is a great example of touching on everything, touching on window design. They're like everything at the building, it's painted in lead paint. Landmarks has opined means and methods with the GC to figure out how to support them because they were all loose. It accelerated the outdoor canopy at the building. And then 50-year rule for 79 West Monroe, the acoustic ceiling that you see in those images, the lower images, older than 50 years old. So NPS considers that historic, has to be preserved in a residential building. So working through some of the challenges like that for design to help you not notice it.
Good afternoon, everyone. I'm Elizabeth Blasius. I'm an architectural historian. I'm also a writer and a critic, and I'm co-founder of Preservation Futures. We are the preservation firm that you probably never heard of, but at the end of this conversation, hopefully you will remember our name because we're really working on some fantastic projects in Chicago. Prior to founding Preservation Futures with Jonathan Solomon, who is my business partner, we're just a 2-person shop in the Monadnock building in downtown Chicago. So prior to establishing Preservation Futures in 2021, I worked in natural disaster recovery. I'm an architectural historian by education, but also by experience. So I worked on Hurricane Harvey recovery and then also on Hurricane Maria recovery. A lot of my work prior to Preservation Futures relates to the National Historic Preservation Act of 1966 and the National Environmental Policy Act. So how preservation has an engagement with federal agency actions, federal funding, or anything sort of like that. Federal agencies, the Federal Communications Commission, FEMA, examples of some of the agencies that I've worked with. So we started Preservation Futures in 2021 as kind of a way to look at the field of preservation a little bit differently. So we all know that preservation mostly, except for maybe some of those NPS, those NPS things that say, well, you have to keep the drop ceiling. We're really trying to look at preservation in this sort of progressive way, in a way that preservation, it can be very good for communities, for buildings, for cities. But we really wanted to sort of be focused on ethics and working on good projects for good, and then also working in places, bringing preservation to clients and to places and to communities that didn't previously have access to the resources or the recognition of preservation. So we really we wanted to focus on sort of areas of preservation that preservation really hadn't been so far. So we work with a lot of communities that are disinvested. We work with a lot of clients who are interested in preservation, but maybe have had trouble accessing the accessing preservation. And we also work on a lot of buildings that are postmodern, modern, and sort of the architectural styles that are sort of more recent past. So I'm going to only talk about sort of 2 projects. The first one is the Emmett and Mamie Till Mobley home in Chicago's Woodlawn neighborhood. This home was the boyhood home of Emmett Till and his mother, and it was purchased by Blacks and Green in 2021. Blacks and Green is an environmental justice organization based out of Woodlawn in Chicago. And Naomi from Blacks and Green came to Preservation Futures and really wanted landmarking, national recognition for the home. But, this project is a little bit tricky. The home is a little bit tricky. It's just a vernacular 2-flat in Woodlawn. So, there's no architectural features that maybe would define a preservation project or a building that is worthy of landmarking. But of course, the home has a tremendous amount of cultural significance as the boyhood home of Emmett Till. So we are working with Blacks and Green to figure out how this sort of humble vernacular 2-flat can become a museum that tells Emmett Till's story and also the story of the Great Migration family that Emmett came from. I also, and here's my apologies, a slide of the way in which we sort of, before the museum has been established, so we're kind of working on figuring out how the spaces can be utilized as a museum. We're working with Studio Barnes, who's the architect of record. Jermaine Barnes, the principal, is from the west side of Chicago, so he's very familiar with the Emmett Till's story. And before the museum opens, we've sort of looked at different ways to kind of activate the 2-flat, including activating it with art. On the right here is an exhibit that Jermaine Barnes put together for us in last summer to sort of express some of the last words that Mamie Till Mobley said to Emmett before he got on the train to go south to Mississippi and then after was murdered by white supremacists in Money. And we're kind of finding ways to activate the home while it's sort of in this time period where there's no museum just yet, but we want people to sort of get excited about the concepts. We want people to think about Emmett Till and his story. So we're doing this through activating the outside of the house and then also using artwork. I'm a writer and a critic, and I write a monthly column for Moss Context. Moss Context is a nonprofit architecture and design platform. It's based in Chicago, but Moss Context is global. So one of the projects that I wanted to talk about that I didn't work on directly, but I did break, was the threat to Baxter International headquarters in Deerfield. This is a tremendously important Skidmore, Owings & Merrill design. Fazler Khan sort of worked out a lot of these, really wonderful moves that he would later use on, really important Chicago skyscrapers like the Sears Tower. So you kind of see these iterations early in the Baxter project. So I kind of got wind through my editor, Gill, who is the editor of Moss Context, that Baxter was being threatened with demolition. Baxter was planning on selling the building for the price of the land. So I wrote about the potential for adaptive reuse of the Baxter International headquarters for Moss Context. And one of the projects that I sort of pointed to was the former Ameritech Center in Hoffman Estates. This is a Lohan Associates project from 1990. Obviously sort of kind of on the new edge, and perhaps this is not a preservation project, but it's definitely a very compelling way to adaptively reuse a former corporate campus. So this is now sort of a place where co-working occurs. There's, various sort of health-oriented businesses. And it's a really interesting example of the way in which you can kind of take a mundane building, perhaps a mundane building like a corporate headquarters, and adaptively reuse it into something that really is more future forward. So, I feel like this project and, some of my thoughts around adaptive reuse really sort of lead into what the LaSalle Street Reimagined project is.
Thank you. So hello, everyone. My name is Allison Tunin-Talamo. I work with Walker Consultants. I am a restoration consultant, also kind of a different title, building enclosure consultant, historic preservationist. Depends on the project, depends on the situation. But we do a little of everything. We have engineers, we have architects and staff, we have material specialists, We do vertical transportation from parking structures, forensic work, litigation, you name it. We have a whole encompassing team on it. So, ignore that. This common conversation that's going on with adaptive reuse, some people feel like it's a new fashion statement, I guess you would say, that's happening. It probably spurred heavily when COVID situation happened, and where we have everyone doing the mass exodus out of the cities, and then we have office buildings that are just sitting there. So people are doing the what ifs. What can we explore? So this is actually a typical conversation that's been happening for numerous years. The National Trust of Historic Preservation has done a lot of forums with federal agents, people that are in affordable housing, people like myself and Elizabeth, asking these what ifs and how can we change and adapt these properties. And other cities like city of Boston, which is where I currently reside, they're already starting that whole movement, and they're implementing different ways of incentives that are different from what Chicago might explore. So if you have the right team, you know the knowledge, and you have the expertise and know where to go about it, you know where to go from there. So here's some existing examples from my prior employer with Klein and Hoffman. The Rosenwald Courts over on the south side of Chicago originally was affordable housing, left vacant for numerous years. We had the right team that came in and invested in the community, and they made it into more senior living and adding commercial space into it. Project that's dear to me is University Commons over by University of Illinois in Chicago. Formerly was a food market for many years. Then finally closed doors in 2003. Someone came over and invested into the property, switched it out to condos. And I also worked on the refrigerator building that also became residential. So it's happening all over the place, different aspects of it. When these projects come to life, again, it's having a client to say, we have a project that we're interested, how do we get the right team? So it could be public, it could be a federal entity, it could be private, it could be a nonprofit or a trust that has this property. And then they work with consultants like ourselves or architects or the engineers and try to develop a plan or a scheme to give you a beautiful final product. So the craziness, and this is kind of how Elizabeth and I kind of do a little dance when it comes to dealing with historic properties or soon to be landmarked, whether it's on the national level or local. You have a big web of entities that you have to work with. We have to work with the client to make them understand that not only we're going to have community engagement like Elizabeth, who with Preservation Futures, but we can have other entities that might have a voice or opinion on what's going on. Likewise, we have to work with the aldermen. We have to work with the local city historic commission. We have to work with the Illinois State Historic Preservation Office. Sometimes properties actually do have easements that are owned by nonprofits. So they have some ownership or some involvement on your property. So being able to know how to integrate and work with everyone together to get you a final product. It looks simple. Sometimes it could be quick. Sometimes it could take 12 years. I was involved in a project that took that long. So it happens. So again, 79 West Monroe, in our involvement, we were looking at the building enclosure. What is the existing condition? What are the different materials? Also the additions that were put on. Their building was originally constructed in 1905, and then there was an addition much later. And then obviously you could see from the old image up top that the cornice has been removed and replaced with newer brick. And then of course around the 60s and 70s is when a lot of property owners decide, hey, let's do an update and let's change the storefront to more of a panel system. So again, just seeing the years of change on these properties. So our involvement is, again, we're just looking at what is going on with the property, what existing materials reside, all the different years of interventions of materials. Are they working? Are they not working? If we're going to do a difference of window installation, what is that going to look like when it comes to the building enclosure? And of course, from our side, being as also historic preservationists, we're also trying to be mindful of any repairs that we do in the future, if that's going to be historically accurate to the property.
Thanks. Mark Schwammel, I'm a director and our office leader for downtown Chicago for Ware Malcolm Architects. And just a couple of projects that we've been looking at. We're a multidisciplinary architecture firm, internationally, North and South America located. We have 29 offices, so pretty large firm, close to 1,000 employees. And, a couple projects, just wanted to show some of the recent work we've done. This is definitely more repositioning work. This is up outside of Toronto,
This is your traditional kind of, this was a Campbell's Soup site that was built in the early 20s and 30s. So it had a very near and dear kind of community. A lot of generations of folks had worked and families had worked at the factory itself. So the buildings themselves were not really salvageable, but the facade was something they wanted to keep as just a monumental piece of the building. So this is the exercise, something, our firm does, working with historic. We took down every brick, marked every brick, and then rebuilt this facade, and then also built, new generation of industrial and manufacturing behind this current facade. We just finished up this project for Mount Carmel High School. It's a 500 all-boys high school just out next to Obama's library. This was an old boat trust building with a brick facade, 123-year-old building. We had to strap those the existing boat trusses to make sure there's a big initiative here in Chicago, a lot of boat truss buildings that warn you to be very careful. The facades start to obviously push out over time. So we had to make sure we save that facade, that brick facade. But then part of this exercise was the actual campus. They weren't using this building more for just, alumni dinners and the spaghetti dinners. They wanted to repurpose this into a new theater and arts building for the students. So really gave this building a brand new life and reposition it for hopefully, many decades to come for their campus. But a lot of us are here today to talk about 79 West Monroe. It's obviously the hot topic because it's going to be the first, as Gary mentioned, through the LaSalle corridor. A lot of good history on this building. Allison started showing an image of the 1904 building. It then got added on in 1922. And one of the landmark and historic requests is that we keep the existing window profiles, which you see on the bottom left. So we, I don't know how many hours we've put in of detailing those windows to make sure we get the exact panning correct to not only satisfy historic, but also keep the integrity of the facade of the building. We have a nice advantage because the windows, the actual glazing is set back. So that is helping us to, it's a big advantage. But these are some of the challenges that we face as architects. This is the exciting part. Gary talked about all the challenges, then we get to obviously solve them together as a team. Of course, we're going through, GGLD is working with us. They're women-owned lighting consultant. We're doing extensive rework, which I think is very collaborative to R2 to relight this building and actually highlight the features that I think went away when Allison's team is done cleaning this facade and repairing it. Adding the lighting back is really what's going to make this, in my opinion, the exterior of this project just come to life. And that's the fun part that we get to do. And then just lastly, we want to save some time for questions. This is just some of the marketing images that we've shown. You can see some of the units. The 14th floor that Gary showed of the tearaway of the roof is going to be a very exciting roof deck when we're done. As you can see, and we think that's the jewel of the building, along with the amenity floor and fitness center that's also going to be located up there. So really excited to see this project come to life. And I know all of us are really excited to be working on it together.
All right. Well, thank you everyone for telling us about your work and your projects. We have about 10 minutes we want to do for questions. We thank you for hanging in there. We know we're running a little over on World of Façades today, but we thought we'd give people a chance to answer some questions. So first, I think for Gary, as we have our developer here, as a developer, what do you look for in a potential adaptive reuse project to assess if it's viable and it's something you want to do? And also, what incentives do you consider in terms of the financial model?
I think it has to make sense. The building has to make sense at its base case. And so for us, if we're buying an industrial building, it has to work economically as an industrial building. And so that is, if we buy a building knowing that we can economically basically float until something new is able, like the development of Goose Island, that's a big part of it. I think with a project like Morton, the income from Morton, so Morton leased back the rights to the sign. The income from that capitalized exceeded the price that was paid for the land. So there are factors like that with every project that we look for, where there's something that makes it economically viable to actually buy it. And that's really focusing on the base case. And anything else is a potential feature that will take some time to figure out.
In terms of incentives, I think 79 is a great example. Pursuing historic tax credits, pursuing tax assessment freeze through the HB 2621. We're really small, 117 units, so we don't qualify necessarily for LIHTC, which a lot of larger projects do. But in terms of incentives, and obviously part of the capital stack, there is TIF funds from the city. So the reality for these projects on the corridor is that they just don't economically work without a pretty diverse capital stack and help. You can build a ground-up new construction residential building in the West Loop for a lot less than you can adaptive reuse an office building into a residential building in the Loop. So that's just the economics.
Wow, you wouldn't think that, but it's certainly complex when you get into these projects. And we have had owners tell us they would not be able to do a lot of the projects that we do without taking advantage of incentives such as Class L. I wanted to give a question to Elizabeth here. As an architectural historian, what is your perspective on the LaSalle projects, and what role do historians play in the approval process and making decisions about these projects?
Cities all over the country are dealing with what the LaSalle Street corridor has dealt with before the LaSalle Street Reimagined project was announced. We have sort of aging office buildings. We have a culture of people who are working remotely. We have people, like Jonathan and I as Preservation Futures who are working on a smaller scale or a different scale. So those big sort of form offices are really not sort of a part of the way that we work as, even just the folks up here. I'm sure many of us work remotely many days a week. So I think it's really important that the LaSalle Street Reimagined project sort of is figuring out how to repurpose buildings like this. And I will use the Monadnock building where our Preservation Futures office is as sort of an example. It's one of the sort of foundational Chicago school skyscrapers. In the 1960s and 1970s, the owners were really sort of reticent to support listing on the National Register or a local landmark designation. And now the building is sort of full of folks just like Preservation Futures, nonprofits in architecture and preservation, lawyers, psychologists, that really sort of love the culture of the building. And if you're familiar with the Richard Scarry book, the Busy Town sort of concept of, there's a shoemaker, there's a shoe repair shop, there's a jewelry store, there's a really wonderful restaurant. So all of these things are happening in a historic building. And the great thing about adaptive reuse in historic buildings is you really have to only sort of prove the concept one time. And, once you prove that concept one time and that sort of landmarks designation protects the building, it sort of prevents, Walgreens from coming in and building no offense to anyone who's working for Walgreens or Walgreens as a client, but it sort of prevents these purpose-built buildings from being built, used one time, and then, now we have to figure out what we're going to be doing with this purpose-built building. So the LaSalle Street Reimagined project is really, I think, going to show the rest of the country, here's something that we can do with sort of a whole collection of historic office buildings. I do think, and obviously with our panel up here and many of you, there's sort of cultural challenges to projects like this. We're kind of creating a new residential neighborhood in an area that really doesn't sort of have the foundational things for a residential neighborhood. So, I hope as these projects sort of develop that the city and, different entities and developers sort of think about, okay, well, we're going to have thousands more people in the loop with, different sort of income levels. We hopefully will not just have sort of single young professionals working and living in the loop and living in these buildings, but families. So, where will the grocery stores be? The closest grocery store to the LaSalle Street Reimagined project is a Target. Can we have a grocery store with fresh vegetables? Maybe there's no sort of school there. There's no daycare. So, how are folks going to really sort of live long term and want to stay in the loop once they occupy the LaSalle Street Reimagined buildings?
Well, we're trying to put some retail in 135 LaSalle. Clearly, it'll fill some of that need. But it is making buildings become landmarked too, which may not otherwise have been landmarked. And it's actually surprising to me when we approach these projects. Many of them will be in a historic district, but they're not actually landmarked. And so the owners have to make that decision to go ahead and do that. And that is a good thing in most cases for our cultural resources. One for Allison I have here is, how do you approach upgrading the thermal performance in these historic walls without compromising the historic character or violating the preservation guidelines?
It based off location, 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 and use, the future use. When we're taking consideration of office going into residential, that's a very different dynamic. People are residing there much longer term, and you have to kind of look at it in that sense. Even, for example, 100 North LaSalle, or Riverside, was a property of mine I worked on for many years, big skyscraper. Simply replacing the sealant, keeping that historical integrity, even though it's like 50 years old, which is kind of hitting that mark, we were able to help energy performance in that building. Utilizing Therm, Wolfie, some of the companies have these programs, and really looking at the overall building construction that you're dealing with right now, seeing what the energy loss looks like, and then kind of going from there. Again, simply just addressing some tuck pointing, getting some windows that are landmark approved and utilized for the use of the building. But, just minimal repairs definitely helps improve the property overall.
Yeah, I think there's a big range of what you can do. We're reglazing some of them, we're re-insulating some of them, but there's also some buildings where you can make it better and maybe not necessarily bring it up to what it would be today, but it's still a vast improvement. And one for Mark now, as we wrap up here, as an architect, what are some things you find most interesting and rewarding about the adaptive reuse?
Yeah, great question. We say it where Malcolm, and I'm sure other firms do too. Adaptive reuse is the most sustainable project you can ever or would work on. It's the number one fundamental thing you can do, is just take an old building stock and convert it into something new and hopefully give it a brand new life. So that's definitely the most rewarding. Just to maybe wrap up some of the comments too, 70 West Monroe, we got approval to do double pane glazing, which at first when we were going to stay with single pane, we were extremely worried. Condensation on the windows and et cetera. So there are folks out there that are supportive of some of the other reasons to do this work. But ultimately, yeah, it's I don't think there's any feather in any architect's cap but to do an adaptive reuse project and say, you've taken something that took something that maybe didn't have a life anymore and gave it a brand new life, hopefully for 100 years to come. Something that hopefully my children and children, it's something you, doing a new project or a green project is easy, honestly. Adaptive reuse is a lot harder, I think. It's also because, two reasons too. Number one, in the design front, you have to carry the DNA and heritage of that building forward, but you also have to make it new and modern at the same time. So those two things colliding and the output of that is really what an architect loves to do. That's what we love to do.
I would agree with that. Well, on that lovely note, I would say we're going to wrap up our panel here, and I hope that you guys enjoy hearing from the group. So I want to thank all the panelists.
Thank you. Thank you.
Thank you.
A special thank you to the whole panel, and Sarah, thank you. Again, once more, if you spoke in this session, if you would kindly come back up to the front so we can give you your plaque and take your photo, that'd be great. Otherwise, thank you everyone for coming today. Thank you if you participated. Hope to see you again, and
let's give Lynda a big round of applause for keeping the energy going and just being supportive of the Zak event. And thank you all for being here. We'll see you maybe in 2027, but come to our New York event. It's close. All right. Take care. See you soon. Oh, and sign up for your AIA credits on your way out if you need them.